And before we get started, we just wanted to get in a little bit about what the Building Science Committee is, as well as introducing our the sort of topic and panelists for today. The Building Science Committee is one of the committees here at the AIA New York. We focus on the technical and performance side of design and tackling issues and topics that are focused more on that. We have a number of members that come from a wide variety of disciplines across the field: architects, designers, engineers, consultants, contractors, researchers, academics. But we're all united sort of around this central theme of technical and performance-driven design. So with that, I want to introduce you to Kritika. She's going to say a few words, and then we'll get started.
Thank you so much, Chris. Thank you again for being out here this early. We really appreciate it. It's getting colder, so I know the effort it takes to get out of bed. Before we begin, we just wanted to thank the AIA New York for their continued support for furthering architecture, education, and looking at how do we further engineering and construction as well, which are some of the topics that this team and the amazing panelists will talk about. And of course, the event sponsors, without whom this event couldn't have been possible. So I want to thank Henry, Rockwool, and Walter P. Moore for continuing to support this symposium. They have a few things out there which are super impressive. I took a brief look, so please go check out their stuff during the breaks. Lastly, we also want to thank the Building Science Committee core team members who have been working tirelessly for the past few months to put together this event. I do want to say Chris and I took on this role super late. We've joined this committee in May, June, and we've stumbled around a bit trying to find out what is it that we are trying to do. So I really, really want to thank the core team members for helping us with this first big event. And with that, we are super excited to dive in. Thank you again for joining us today. And we hope the discussion sparked the ideas, collaboration, and maybe even a few debates. One thing I want to say, after the end of each session, we'll pass around the continuing education sheet. So if you want to get those, just sign your name. And mostly all of the sessions have been set where the presenters will be going through their slides, like 10 to 12 minutes, and then we'll have a panel discussion. So start thinking about your questions as you listen to their presentations. So with that, thank you so much. Hope you enjoy the day. We have a packed schedule, and I'm going to hand it over to Kushnav.
Thank you, Kritika and Chris, and good morning, everyone. I'm Kushnav Roy, facade consultant at Walter P. Moore, and an advisory member of the Building Science Committee. This session is titled Breaking It Down to Build It Back Up, and our discussions will revolve around themes of circularity in the building envelope and interiors, and how this is realized through designing for deconstruction and disassembly. I would like to introduce our speakers. Our first speaker will be Ben Martinson, Associate Principal of Facades at Bureau Happold, and who will be speaking in Fraser Reed's place, who unfortunately was not able to make it today due to a personal emergency. We are very excited to have Ben speak to us. At Bureau Happold, Ben has collaborated on a wide array of facade projects in the US and abroad. He started his career in architecture and has worked across multiple scales. Ben has a special interest in integrating aesthetics with technical solutions, ensuring the building envelope meets high performance standards. Ben's recent work includes significant investment in the development of tools to evaluate both operational and embodied carbon impacts from the building envelope. Welcome, Ben. Our second speaker will be Sydney Mainster, Vice President of Sustainability and Design Management at the Durst Organization. Sydney brings over 2 decades of professional and academic architecture, design, and construction experience. In her role, Sydney oversees the company leadership's vision for sustainability in ground-up development projects, existing building renovations, and building management, while developing strategies for implementing circular guidelines, setting sustainability targets, and maximizing tenant engagement. I would also like to introduce our session moderator, Nicole Spina, who is the Vice President of Climate Innovation at the New York City Economic Development Corporation. At NYC EDC, Nicole leads innovation programs to address the city's most pressing climate challenges and to help shape a city economy that is more inclusive and sustainable. Her portfolio focuses on de-risking and accelerating climate solutions that decarbonize buildings and construction, develop a renewable energy system, and enable low-carbon alternatives in transportation. Welcome, Sydney, Ben, and Nicole. We'll be having 2 presentations in this session, followed by a panel discussion. Please note that the Q&A will be at the end of the panel. With that, I would like to hand it over to Ben.
Thanks, Kushnav. Good morning. Let's see, what do I do with this thing? Aha, okay. So I'm a pinch hitter today, and I'm really happy to be here. When I was thinking about how to kind of start this presentation, I thought back to a project that I had worked on in a previous company, which was the refurbishment of a piece of the UN curtain wall that is now in MoMA. And I thought that this sort of encapsulated a lot of interesting things that are related to the topic of this symposium today. It, sort of raises questions of what does it mean to reuse. It has a lot to do with, what do we do with buildings that are at the end of their lives, especially buildings that were built at the middle of the 20th century, where nobody was really thinking about the end of the building's life. They were just, building these buildings. So I think this is an interesting picture because it sort of wraps around all of those things. But first, what is the problem we're here to address today? And hopefully this will kind of set the stage for what Sydney and I are going to talk about. But this probably doesn't need a whole lot of preamble or explanation, but the work that we do as architects uses a lot of materials. And that is only increasing over the next 35 years and beyond. And all of that is, has detrimental effects on the world we live in, the atmosphere, extraction, as well as the end of life use. What do we do with all of this material? Obviously, that's the kind of crux of what we're here to talk about today. Just to put it in context of some numbers, building operations and materials construction account for almost a third, or a little over a third of global CO2 emissions by sector. And we're going to be talking a lot about embodied carbon and operational carbon today as a kind of metric for keeping track of, well, how well are we doing in terms of how much damage or how much potential damage are we doing to the planet that we live on. The chart on the right is really just showing that over the next 30 years, operational carbon and embodied carbon are going to be roughly equal in terms of their contribution to the carbon emissions coming from building operation and construction. So we've been doing a lot of work at the state level, the national level, certainly at the level of the professionals in this room to reduce operational carbon. And now we're kind of having this conversation about what we're doing about the embodied carbon. It's sort of the next, horizon and how we're going to be reducing our impacts. So I'm interested in facades. So that's what I'm going to focus on primarily today. In terms of where the embodied carbon in buildings comes from, structures, we use a lot of concrete, we use a lot of steel, is generally the biggest contributor, followed by facades, which is around 10 to 30% of embodied carbon in a building, which is a significant amount. So anything we can do to reduce or offset or plan for helps with that overall picture. So how does circularity fit into this, or how does embodied carbon fit into the circularity conversation? So what is the circularity? What is the circular economy? We throw these words around a lot, but it really is at least for me, it really is a change in thinking, or an addition to our thinking. We think, okay, we're being sustainable. What does that mean? Not just now, but in the future. So you can no longer think about, oh, we're just going to build a building and that's it. What happens at the end of that building's life? So moving away from this idea that we extract, we build, we use, and we throw away, to something where we are at the end of that throwaway. We don't use throwaway anymore. We say, how do we reuse that? So that's a catalyst for innovation, and I think a number of the things that we're going to talk about today will kind of describe how that's happening. And also thinking of buildings as a repository, a resource bank, or something that could be inventoried and used and cataloged, so we kind of understand, what's on our balance sheet of materials to use in the future. Just quickly, there's kind of a lot on this slide, but how do these two things relate to each other? The main idea is that anytime we are deconstructing a building, if we don't have to downcycle those materials, if we can keep them in the highest value, that's desirable. So this chart on the right, if we're collecting the materials from a deconstructed building, if we're able to reuse them in situ, great. That takes very little additional carbon added to it. If we can repair them, great. If we can remanufacture them, great. If we can recycle them, that's still great because they're not going to a landfill. But it still requires, sequentially more and more work, and therefore additional embodied carbon to reuse those materials or recycle them. So we're trying to keep them at the highest value for the longest possible time. So why now? I think this is an interesting slide, just because it's conceptual, but back in the 70s, we weren't concerned about embodied carbon. We weren't really concerned about operational carbon as well. We used single glazing. We didn't think about thermal breaks. We didn't do any of that kind of thing. We just heated our buildings and cooled our buildings, and that was that. Then there was an energy crisis, and we said, oh, we probably can't do that. Maybe we should use double glazing. Maybe we should put more insulation in. And all of those things are great for operational carbon, but they increased the amount of embodied carbon that was going into those buildings. So the proportion of embodied carbon is increasing. And the idea of getting to zero carbon means that we have to deal and we have to contend with this idea of embodied carbon. So policy frameworks, New York City and EDC is on the kind of forefront of this right now. And I've had the pleasure of working on the Spark project, where we're kind of testing this out using the EDC's clean and circular design and construction guidelines. But the idea is that we're eliminating the concept of waste. So basically, if you take that as your base point, it totally short circuits this idea of a linear consumption, and means you have to interrogate every single material that's in one of these buildings. What this has meant, specifically for Spark, is a lot of conversations, but sort of broken down into recycling, reuse, and ideas that how you can approach design of new buildings to, one, use the materials that exist in these older buildings, but also when you're designing these things, how can you think 50 years in the future? So 75 years in the future. So those materials can be, easily extracted, not from a mine or the earth, but from these buildings. So circularity in the building enclosure. This was a animated GIF, but it's okay. We've been building buildings the same way for a really long time, until about 100 years ago, and then things changed. We started, building there was a separation between the building envelope and structure. We started cladding buildings instead of the building itself being the building envelope. And so we're learning about that. We learned about that, and in the mid-20th century, New York City was a hotbed of a kind of new building type, using curtain walls, cladding these buildings with light materials. And we're now at the point where all of those buildings are kind of at the end of their life. So what do we do with them? Chase said, well, we're going to take 270 Park down. That makes more sense for us. And we're going to put a new building up. There are many buildings around the city where they've decided to reclad. 3 Columbus Circle, it's a Gensler project. There are a number of other projects that have not gotten off the ground. The owner, for whatever reason, has decided, we're just going to do the bare minimum here. But it's a really interesting kind of problem in this city, especially. And I think the UN picture that I was showing at the very beginning, again, really encapsulates all of this. This project was sort of begun 2009, 2010 was when they were doing the construction. And there was not a discussion of circularity. In fact, these 3 panels that are at MoMA are the only pieces that remain of that did not go either through a recycling process, a downcycling process, or end up in a landfill. Why are facades important? I sort of touched on it earlier, but we use a lot of materials that are really, really high in embodied carbon. They take a huge amount of work and energy to produce, and we use a lot of them. So we did a kind of retrospective embodied carbon study on a curtain wall project that we did, and it was really interesting. We were looking at the material weight versus the global warming potential in carbon, and the aluminum frames and panels and all of that kind of thing were about 25% by weight, but almost 3/4 by embodied carbon. So the metals, both galvanized steel in this case, excuse me, and aluminum were just outsized players in the overall carbon picture for this building. And this was a relatively straightforward curtain wall project. So what does that really mean? It means, can we reduce at the beginning? Yes, but we also need to think, how can we make it easier to reuse that material at the end of that project's life? So, facades, especially large commercial facades, we've been thinking in a lot of terms that sort of lend themselves to this idea of design for manufacturing and assembly. We try and push projects to, build panelized systems in a factory. It's controlled. You can manage all of the kind of water and air and all of these performative things that a building needs to do. But you can also kind of think about that as priming yourself for deconstruction in a certain extent as well. So DFMA, you're simplifying parts. You're optimizing for how you're going to build it in the factory. You're standardizing components. And you're selecting appropriate materials. And a lot of those things translate into, if you were to press rewind on the same process, where you're going from the building, completed building at the end of its life, you can remove panel by panel, package those panels up, move it back to a factory or an off-site location where you can disassemble these things in a controlled way and make sure that all of those material streams end up back where they need to be and get the most yield out of that material. So the design for disassembly and the enclosure, again, we're thinking about the standardization of these things so they could be easily kind of cataloged. One thing that's been really interesting for me to think about is, how do you keep track of all of this material? And I think technology ends up playing a big role in how this can play out over the lifetime of the buildings that we're currently designing. Like, we have access to BIM software. We can literally embed so much information into the documentation for these that we simply didn't have before. And I think that's something we'll probably talk about in the panel. So I think maybe to kind of end here and sort of act as a provocation. The idea of deconstruction, or the idea of reuse, is not necessarily new, but using it in a way that makes sense for kind of our current economic situation requires the balancing of a huge amount of what on their face may seem like kind of mutually exclusive goals. But I think that as we're contending with these things, sort of not for the first time, but we're kind of early in this process. It's really interesting to think about, how we can kind of pave the way for all of these things to happen in our current design and construction practices. So I think I'll leave it there, and I'll hand it over to Sydney.
That was such a perfect tee up for what I'm going to talk about. That was amazing. So hi, everyone. I see some friendly faces in the audience. For those of you who don't know me, my name is Sydney Mainster. I'm the Vice President of Sustainability and Design Management for the Durst organization. I think, let's see. Perfect. So I just wanted to make sure, usually like to start these talks in case people don't know who Durst is. So Durst Organization is a 105-year-old family-run, privately held real estate developer, owner, operator here in New York City. These are our commercial properties here. Some of you may have worked on some of these buildings, but hopefully familiar to you. And these are our residential properties. We have about 3,400 rental apartment units across 3 million square feet. And these last two, 20 and 30 Hallett's Point, were just completed and are available to rent an apartment if you would like to live on the Astoria waterfront. So I always like to start my talks with this slide, and I know some of you might have seen me present this before, but I think it's important to frame why I'm even talking about this stuff. I am a materials nerd. I love supply chain. I love talking about products. I like thinking about scale. And so I'd say probably, there you go. That makes more sense. All right. So I made this slide for our design consultants in an effort to explain to them, and I'm going to use that same exact word, and this was not prescripted, to how to interrogate the products that they are considering selecting and installing on our buildings. Interrogation necessitates an iterative approach to product selection, which we push for early in the design phase in order to end up with products that satisfy a range of criteria: performance, sustainability, cost, availability, appearance, maintenance, end of life, reuse, but certainly there are few perfect materials on the market. Please note that as an owner, I have a time-based relationship with these products lasting beyond installation. That could be anywhere from 1 to 2 years, all the way to 50 plus for some, like those products either used in the building envelope in the structure. No building product is permanent, and I think it's important to take away that notion. That maintenance, that's why maintenance and end-of-life considerations are so critical to consider and understand when specifying anything for installation. So I created this back in 2015, and it's still how we assess and evaluate what products go into our projects. So if you think about what's out there and what is installed, look at the potential of what we might be able to find. This is part of the white paper that came out of the Cornell Circular Construction Lab in 2024. There's both an economic opportunity here that's pretty substantial, as well as a physical opportunity. I think this is a state level statistic, about 58% of materials annually being discarded from buildings. And if I remember correctly, New York City is similar. I think it's 60-something%. So to build on what you just heard, I like to show this slide because it talks about embodied carbon over time. The previous speaker spoke about the embodied carbon impacts of the different materials, and that is 100% true. It's still valid. Those LCAs are still accurate. But I think when you start to think about the impacts over time, this is actually a result of LMN architects looking at the office building that they were moving into and renovating. And the churn over the interior office renovations starts to actually add up, such that over time, the cumulative effect of all of those renovations on the interior environment start to equal and exceed those of the original embodied carbon impacts by structure and enclosure. So that was a pretty provocative slide when I saw that, and sort of enforced why we at Durst have a distinct approach to interiors renovation. For our interior fit outs throughout the portfolio, we've adopted a circularity strategy for a few products: furniture, ceiling tile, carpet tile, and drywall when possible. We're certainly looking always into others to pilot, and products that we are currently considering are lighting, wall base, and doors. This was actually our office out of One Bryant Park. These are the demo photos from last year. I will tell you, none of this is easy to do, nor inexpensive, and it should be. So in order to really make this happen and successfully recover these materials on DERS demo projects, we rely on three primary things. One, specification language. If there's something else I would really like you to take away, is how critical it is to be specific early in your demo language and identifying outlets and materials for target so that they can be bought as part of the demo contractors package. This on the left is actually our own internal, I'll call it like cheat sheet of where things need to go and what we are currently focusing on. I am happy to share this with anybody so that everyone can use this and build off of it. The second is an ongoing tracker, identifying the minimum quantities, condition of shipment, and the current contact number for who you have to call to make sure that you're meeting those minimums and actually get this picked up on your project. And then finally, the most key part of our process are these two people here. This is Maddie and Brian. These are people who work internally in our construction and sustainability team. They're tasked to oversee the reclamation process and ensure demo contractors are documenting and actually deliver and make sure that this stuff gets picked up in accordance with what they've been contracted to do. So, as might have been obvious in my previous slide, this is far from industry standard practice. But there are two very helpful guidance documents that were recently released that provide structure and process guidance to projects who want to tackle deconstruction in a meaningful way. One was mentioned earlier. The other I would point to is this Hennepin County, actually I never remember the title, Guide to Material Reuse in Commercial Buildings. Both offer spec language, ideas, a process overview, really, really helpful in trying to guide how to implement this practically. So for us, a material we didn't focus on until last year was interior glazing. For the first time in June 2024, we successfully reclaimed over 22 tons of interior glass for reclamation and reuse. As you see in this image, our former offices on the 48th and 49th floor at One Bryant Park featured a significant amount of interior glazing, both in our office fronts and entry doors. And while glass used in the building envelope might be expected to last 50 years, the glass used on the interior will likely only be installed and in use for a much shorter time frame. So 8 to 10 years if the average lease length in New York City is assumed. In conversations with Certainteed, a subsidiary of the global manufacturer Saint-Gobain, we identified the potential to reclaim post-consumer architectural glass and use it as feedstock for the manufacture of fiberglass insulation. And actually, by using recycled and reclaimed glass, which we call cullet, essentially tiny little pieces, it reduces the embodied carbon of that fiberglass insulation by about 1/3. If you ever want to know why, I can go into way too many details about this, but it's really fascinating. In total, from this project, we recaptured 22 tons from about 63,500 square feet of interior office space. And that's just one demo project and one office fit out in just hundreds of office towers in New York City. To make this happen, we actually were connected with a key player, a recycling company out of Minnesota, Infinite Recycle Technologies, which has developed a process that mechanically recovers almost 100% of the glass as feedstock for manufacturing. And I will caveat this, that we have been focusing on reclaiming our exterior glazing for recycling purposes and trying to do this at scale for the last 8 years. We had one successful project, which we actually thought about doing it after we learned of the UN project. And we were able to recapture glass out of one of our office buildings. It had a film on the coating of it. It was extremely laborious. It was physical. It was dangerous. And we had to keep the sheets whole. We had to have guys with razor blades literally scraping off the films. And we had to take it out whole. We had to shrink wrap it. And we gave it to Urban Mining to turn into glass pozzolan for use in concrete. But it was a significant amount of human labor, frankly, and kind of dangerous human labor in order to make that happen. The difference with what you see on this screen now is because there's a mechanical way to separate out the interior layers, to use this for anything that's coated. It could be laminated glass. The variety of glass that this this processor can take is so much wider, and they can take it off the site. Actually, you can crush it. It does not need to be whole, meaning you don't have to put it on A-frames down an elevator. Makes the process infinitely more, infinitely faster and safer. Maybe we still have to talk about breaking glass on site, but much more palatable in terms of a fast demolition schedule in a way that makes this really possible. So why glass? I think it's important to understand the potential impact of reclamation and what is existing and what is happening. So about 12 million tons of float is manufactured in the US annually, and about 25% is recycled into cullet, and that is exclusively pre-consumer. So this is coming off the float lines themselves. They've gotten to the point where they're so good off the floats, although they're still at about 10 to 15% loss, even on a manufacturing line. They take that float off the line and they're able to turn it into cullet and re-put it back into new float. So this is a doable, known process. But again, this is pre-consumer. In Europe, who you would think is we typically look at as leaders in this area, they are really only at under 5% from end-of-life post-consumer cullet. And I would say they're really only about 2 to 3 years into this as well. So we are not terribly far behind. So after doing the interior project, we were able to actually run a successful exterior pilot with partners from Consigli. And they were able to capture about 40 tons from a retrofit reposition project just north of the city. But between these two projects that we ran as pilots in June, and I think this project was a little bit later in the year, we successfully demonstrated how to do this on both interior and exterior projects. Now we keep going. So for the past year, we've had more and more people that are willing to try this and are willing to figure out how to do this on more complicated projects. So 222 Broadway, Skyline, who is the reglazer on the project, is recycling all of the existing windows. This is a office to residential conversion project. It is occupied. There's no loading dock. They are live loading these glass. They are taking the full IGU out, and they're figuring out how to reclaim this. This was a commitment by Skyline on the project first to figure out how to make this work, which I think is a real incredible commitment from a contractor, or I guess they're a sub, but to do this. And then at 1233 York Ave, this was a full demolition. So this was a little bit longer time frame. They had more site ability. There were 2 30-yarders on site. And since this is a full demo, they removed the glass first, and they were able to fill up those 30-yarders for removal. About 400 tons of glass coming out of these two projects. That's that live load you see here. We had to figure out how to do this within the contractor's scope, within the labor conditions, how to make sure this worked again with, frankly, a very tight site in Manhattan. But I think they're almost done at this point. And to be honest, this is just, showed you 3. We're now on track this year, a year later. We're over thousands of tons. There are multiple other projects not mentioned here, and it's pretty exciting to get such buy-in. So in the UK, where they're about 2 years ahead of us here, they have reclaimed post-consumer glass on about 200 projects in the past 2 years. So how is this doing? How's this working? Literally, they've standardized the process. This is what they're using, and they're sharing all of this with the subcontractors in a way that this can consistently be repeated project to project. Here's some additional work that we've done. This is some other interior glazing projects from our sites. We have literally used different means and methods for every project we've done so far. And it's not to say this is right or wrong. It's just we're trying to sort of test out what's the best method and give contractors a variety of ways to approach this. Here's another one where we use minis on site. We site separated and then actually loaded outside our loading dock. So what do we want to do? We really are trying to create this closed ecosystem map frankly, for New York City, but certainly as a national model. The pilot the pilots are running at all these projects, and honestly, we're still considering it pilot, but we've been doing this for about a year now. We're testing out quirks, testing out hurdles, and we're sharing this information, which I think is one of the critical pieces. And again, why glass? Well, sand is the second most mined natural resource in the world. Globally, 50 billion tons of sand is mined on an annual basis, and 500 million tons is used for glass mining. It has a significant environmental impact, including riverbed depletion and coastal erosion. It's also incredibly nefarious. Sand mafias, corruption, violence, illegal sand mining is rampant. In one part of a recent book, Material World by Ed Conway is dedicated to sand. I highly recommend it. And as an anecdote, just here in New York City, if we think we're immune from this, I had a concrete sub actually threaten to walk off one of our construction sites because I told them to tell me where they got their sand from. So this is real and it is everywhere. So how do we get wider adoption of recovery and reclamation and circular efforts like this in demo and construction? We need to anticipate the questions and support people in the field doing the work. You got to remove the hurdles. You have to remove, I've never done this before, contractor markup, which will add 10 grand to your project, no matter what the cost is, because they frankly don't want to do anything new that might involve risk. You have to identify those areas of risk. Right now, do you have a loading dock? Can they meet insurance requirements? Do you have timing constraints? You have there's contamination on your glass. You have to make it easy to contract. You guys in this room putting it in the specs so that there's no question at the time of award that the demo contractor needs to know that this is an area you're going to be focusing on. You don't have to figure out means and methods, but again, just that language on even a drawing or in the spec is going to make all the difference. Get you guys engaged early and specify products from the beginning, which we saw in the previous presentation, that don't contain toxic recycled content from reclaimed products, and you've got to demonstrate demand. The other area we can start talking about is how to specify post-consumer reclamation percentages in the insulation that you specify. That's another opportunity to signal to the manufacturer that they want to be part of this. As an owner, the question people often ask me is, why do I do this? And that's frankly the wrong question. I ask, well, if it's possible to reclaim valuable existing materials through urban mining, why would a project ever choose to discard such a valuable material in the first place? Finally, you need a stakeholder ecosystem. You need people at the table from every part of this problem. We have been meeting every 6 weeks since June with a variety of stakeholders that includes architects, people from the city, it includes construction, it includes processors, manufacturers, lots of building owners like myself, and envelope consultants. If you're interested and have a project you want to try this on, please let me know. I would love to hear from you. We're at about 80 people right now. I will say we have about 40 attendees pretty regularly, but this is how it's done. With that, thank you.
We'll now
Fantastic. Well, first, thanks so much to all of you for being here today. And thank you to Ben and Sydney for your amazing presentations. I'll do a quick intro of myself and EDC, as our name was thrown up on the board a couple of times. I'm Nicole Spina. I'm Vice President of Climate Innovation at the New York City Economic Development Corporation. We're a quasi-governmental agency really focused on strengthening infrastructure, strengthening neighborhoods, and strengthening industries that are really key to growing New York City's economy and keeping it inclusive. We have a big capital portfolio ourselves, about $9 billion in capital construction and over 200 assets that we manage on behalf of the city. So circularity in construction and building decarbonization overall is an area in which we're spending a lot of our time. We put out our circular design and construction guidelines last year, which were referenced. And it's been a real time of learning for New York City, and that I think we like to go into these conversations acknowledging that we don't yet have it figured out, and really that candor and putting forth these guidelines and these pilot projects to help the city get its footing around what is uniquely difficult and opportunistic about this work so that we can get smarter and develop more of the infrastructure that enables its success. And so it's been so fantastic to have partners in the private sector like Ben and Sydney who are doing this in real time. I'm very grateful to join lots of events with them like this, but also to be working on some projects, particularly with Borough Happold in the case of our Spark project, which is one of the projects that is first leveraging our guidelines. So in structuring today's conversation, I'd first love to see a show of hands from folks in the room. How many of you are already implementing circularity in your own work? And for how many of you is this a new concept or something you're hopeful to do but are not yet doing? Okay, that's really helpful. I think in terms of how we like to tackle these conversations and taking big ideas that are very exciting and really grounding them in execution, we're thinking at 3 scales, sort of like what is the technical and financial feasibility of this work? How do we make that make sense? Who are the partners that help to enable it? I mean, we have folks who are passionate in pursuing projects, but you need a wide ecosystem of actors to across the supply chain to really scale something like this. And then 3 is around embodied carbon reduction and data. How are you telling a successful story around this? How are you collecting enough data so that you can scale it in a way that is repeatable, that you understand impacts over time and patterns across projects? And so maybe just to start with the technical and financial feasibility aspect of the work, Ben, I was struck by the last slide you had thrown up and where you had that table, the X and the Y axis, about what is really challenging and what is really important. And I saw most challenging and most important is business case. And we are dealing with this all the time. It is expensive to do this work. Sydney, I'm thinking to your point of considering the 10% contractor markup. Nobody wants to take risks. It's a really different way of doing work. And so I'd love to just first hear from both of you of what does it look like in the day-to-day to make decisions around circularity while also thinking about the bottom line, whether that's as a building owner or as an engineer or advisor on a building project.
Yeah, I think that's the big question that sort of hangs over all of these discussions is, we can talk about the concepts behind it, and I think everybody is sort of on board with all of that. But then you get down to kind of the brass tacks of, okay, what does this mean for the project finances? What does it mean for getting the right contractors on board? And I think at least from the design side of it, it really has to do with having the right partners on board at the very beginning, and making sure that everybody understands that the expectation isn't that this is an add-on, but that this is a fundamental and intrinsic aspiration or even requirement of the project. And I think, Sydney, your slides about specification, it's like you have to have this explicitly in there from the very beginning. And then I think the financial part of it can sort of fall into place because the expectations are already set. It'll be interesting to see on our Spark project exactly how all of that shakes out. But like you mentioned, we're really at the beginning of figuring all of this out. And another slide that you were like, we do this differently on every project, and I think that's it's certainly true for us. this is new stuff, and that's exciting.
So I think the more I have conversations about the stuff that someone should be able to take back and reuse, the madder I get, because I feel like the architectural community specifically has been sold for a lot of years that these are the materials you specify, they have take-back programs, and you will be able to easily reclaim them, and someone will take them back and make them into new stuff. And if you really start to dig into it, it's really frustrating because it's extremely hard to close that loop, especially around carpet and ceiling tile, which, again, manufacturers have been claiming, choose and specify this product, put it in your buildings, we'll take it back at the end of life. We have a take-back program. And the boots on the ground experience of actually making that happen is costly, it's timely, it's time intensive, and it's really unnecessarily burdensome on the teams that are just trying to do what they were told was possible. I think from a business case perspective, I think you're 100% right. Making an expectation of the project early is the key piece of actually it being incorporated into budgets and being incorporated into contracts so that you're not getting a change order afterward in your experience in the premium. The other piece I would say, there's a few others, there are opportunities right now, especially with glass, where it's cost neutral to do this. If you get it in early, you get it in the demo contractor spec, it doesn't add time or cost, and the material is valuable. The manufacturers want it. It helps them. It saves them money on making stuff. So because this is a valuable material now that, again, a couple years ago wasn't, it actually makes the business case work, and you're going to get a better product in terms of insulation that's being manufactured for any embodied carbon goals for a future project. So that it's a system that's kind of set up to succeed from a business case perspective. We just need people to be hitting the targets at the right time in the project. The other pieces that do not work, which are extremely frustrated, is furniture. It's the bane of my existence, office furniture. Continually to try to solve this. And then the other piece I would say, I'm trying to push contractors hard on some of these take-back and manufacturers that they need to hide this cost better. It's not just an owner that takes this on. Come on, there's a full supply chain of people that are invested in trying to make this work. It cannot be borne only by me.
Back to the ecosystem.
Mm-hmm.
Yeah.
Mm-hmm.
Yeah, I think just to stay along these lines, what was really eye-opening and helpful for us in the early days of implementing circularity on our building projects was just there actually has to be a market resale value for these projects, for these products. We have to, we might have to consider a scenario in which we're not perfectly deconstructing 100% of what is there, but are rather doing selective salvage modeling to say what is actually salvageable here based on who our off-takers are. And so I'm curious, in talking about either facade or enclosure or around particular interior materials like glass or furniture, how much that weighs into your decision to even spend your time and focus there.
Well, so I'm going to go back to Spark because I think it's a good case study that kind of grabs all of these different materials that we're talking about, from materials that were sort of easy wins to materials that you're going, what do we do with this? How do we make sure that this does not end up in landfill? And so I'll focus on the brick for a minute, because the existing Spark building is a brick building. The cladding is mostly brick, punched windows, and the sort of first thought is well, can we use the brick in a wall? Can we just use it in the same way that it's used now? And the reality of the situation is sort of that brick doesn't meet one, the aesthetic requirements of the project, and two, there are lots of questions is it actually suitable to reuse in terms of its mechanical performance, all of that kind of technical stuff that's on top of it. But we started thinking a little bit more about it, being okay, well, what is this brick? Well, this brick it's it's a clay material, so we started talking to terracotta manufacturers, and this was sort of happening at the same time as the early deconstruction conversation. We're going, okay, what do we do with it? And the terracotta manufacturers, similar to the glass manufacturers, were going, well, we can use that as a base for reducing the amount of material that we need to extract in terms of raw clay. We can grind it down, and we can use that as a way to reuse this material. It's not a one-to-one, so it's a significant additional embodied carbon cost, similar to the glass. I'm just imagining these guys scraping the film off of that glass. But it means that it's not ending up as landfill. So you're above your minimum threshold, but you're not at the point where it's a perfect one-to-one. And I think that's going to be true for a lot of materials that are in the facade, just due to their performance and due to the sort of changing aesthetic desires or needs.
I think the resale sort of, we don't not think about opportunities of really who wants this stuff afterward, because I think you have to understand an end of life scenario and how you're going to make that end of life scenario work. However, I do think the primary driver of any kind of selective deconstruction we've been doing, whether on exterior or interior, has been primarily how do we innovatively treat this stuff so that it isn't being wasted. I would say the other piece we're starting to think about is how do we, as an owner with a lot of tenants and residents in our buildings, how do we incentivize the procurement of materials that have been refurbished? So, for example, Human Scale is trying to scale up a program where they are taking back 3 lines of task chairs and they're refurbishing them in an intentional way that allows for the acceptance of the condition. Like, it's not perfect, but it is it's acceptable, meaning they'll replace sort of the high wear backs or the arms, but maybe the leg, the stem has a little bit of scratches, and that seems fine from a user. And it saves about 65% of the embodied carbon of producing new. So if that's something I could help scale and offer this to as a procurement option, either when I buy task chairs or to tenants who are buying furniture, I feel like that's the other end of this, where I can try to figure out my role in helping augment the larger ecosystem. And actually, I would put that back on you guys as well. This idea of specifying a reclamation or a post-consumer percentage in the materials. Again, non-toxic, very important, but for you guys as designers to think, are there refurbished options that might fit within the project? How do I get them into the project as part of the design? And how can you play a role in making sure the demand aspect of what we're discussing is also illuminated as part of circularity for the full ecosystem?
When I think about that's really helpful. When I'm thinking more broadly about like technical and financial feasibility opportunities and where we tend to spend a lot of our time, I'm thinking about 2 key considerations. One is outside of financial feasibility, it's storage of these materials and like logistics. Yeah. And then it's also assessing quality of these materials, like whether they're going to a facility to be remanufactured or whether they're going to be reused on another site. How much are you guys thinking about this, and how much does it impact what you presented to us today? Maybe specifically within New York City's unique, dense constraints. Like Sydney, I'm thinking about the picture you showed of like all those float glass panels. They maybe had like 2 feet by 5 feet, are all like stacked against what looks like a really busy commercial corridor in Manhattan. And so how do you stage this and think about this?
Yeah. Storage is the number one solution piece we are missing here in New York City, because oftentimes what you need is space and time when you have deconstructed and you have materials available in order to sort of find their future homes. Even with the glass pictures that you showed, we have been trying to find a kind of aggregation point that works well in the city. in order to be able to take smaller projects glass that don't meet like a minimum 30-yarder threshold for collection, because there's so much opportunity, but you really do need to lower transportation expenditure in terms of embodied carbon you're using to just frankly move something around the city or to the recycling facility. It's better to have a local aggregation point and then move it. Although I will say they're opening a facility in Newark because there's so much demand now out of New York City, and it's going to be amazing. So much closer.
Who's opening the facility?
Infinite Recycling. So after 1 year, they've had so much growth in terms of demand from stuff coming off buildings. Told me it's going to be open early next year. I'm very excited. But time, space, critical. The critical pieces to making this work. Sorry to jump in.
No, absolutely. Like, I think I'm like harping on Spark, but
It's okay, we love Spark, but they're also sort of our problem child.
The space is like the make or break portion of this, because you can talk about, structural members. It's like it is relatively straightforward to reuse steel structural members. They can be measured. You can understand their material properties, their strength characteristics, all of that kind of thing, which makes it relatively easy to say reuse a beam in another project where it's been designed that that's the size that you need. Then the question is like, okay, well, the time scale and like the timeline of all of this sort of rears its head. And you're like, okay, well, that beam doesn't need to be used for another 18 months. Yeah. And so everybody, the building that it's coming from, all of the stakeholders in that building are going, wait, you want to leave that on our site for 18 months? No, that's not going to work. But they're like, well, we don't know where to put it. So it becomes this logistics sort of like hot potato. There's a project in Boulder, Colorado, where I'm from, where this is a case study that I saw presented, where they demolished, well, they built a new hospital, and there was a hospital that they deconstructed, and they ended up reusing all of that steel in a firehouse. And there are these kind of overhead drone shots of them taking this hospital down, and it's like it's a big site, so they had like a pile of concrete aggregate over here, and then they had a pile of steel stuff over here, and they had a pile of glass cullet over here, and it was like, oh, you have space to do that, and there wasn't this major logistical challenge because they did have the space. And I think that is in New York City with a new building project, with a deconstruction project, is always like a huge issue. I mean, you were talking about loading docks, and it's like, when we're talking about loading docks, there are space issues. Yeah.
Yeah, and I think that's true whether it's going to a recycling facility, whether it's going to be reused on site, and there's like an awkward 18-month period where it needs somewhere to go before it can be refacilitated. EDC is also, and I know these folks too, are thinking about how do we share materials across sites? And so then sometimes you just have projects that are like ships in the night. Like you need to carefully coordinate, like when can I offtake this material at the exact time that a project needs it? And I think that's happening in a lot of informal ways right now, and that people are forming relationships. Like it's a pretty tight-knit community. And so people have a general sense of who is it who's interested in doing this type of work that I might be able to build relationships with to do this sharing of materials. That sort of feeds into questions I have around like partnerships. And so what have success stories been like for you within New York City's unique constraints in figuring out partnerships and creating infrastructure where not necessarily a ton of this currently exists?
I will put a shout out to Deconstruction Dave on this, because he's been, I don't know if everybody knows Dave Benning, but follow him on Instagram. But he's kind of a guru in terms of knowing about all of the different players and what has up until this point maybe been kind of a obscure network of smaller organizations and people that are like doing this work. So he's come into our office. He was part of all of our materials audits for the Spark, for the existing building on Spark, and helped make connections. So I think that for us, just because we're all learning this, was a really successful partnership. I think EDC being on board and being like, we're doing this thing, we wouldn't be doing this without that. Without that as being a requirement of this project. But now we're thinking about it. It's in our heads now. We've done this on one project. We can start implementing these same ideas on other projects. And maybe you say, well, it didn't work quite how we wanted it to, So we're going to introduce a new aspect to it, or we're going to talk to some new people about it. But yeah, I think for us, a big part of the success is just learning about the ecosystem and having it in our heads.
I'd say probably something similar, where I think this notion of if I am using my project to demonstrate, especially to the contractors and the subs, that this is possible and they can learn from how to do it, that it is infinitely repeatable. So that means the design team can learn about what needs to be in place in order to get it done. The demo contractors, and actually this has happened, is that Waldorf, who was the demo contractor on our office project, is now being hired over and over for these interiors projects that want to reclaim the glass, because now they know how to do it, and they have done it successfully on, I think they're at six or seven projects now, and they're just starting a new one. I just got told like now. They're like, yeah, sure, we've done that before, no problem. And again, it doesn't need to be the same means and methods, but you have de-risked it in a way that there's a familiarity with process. And so it allows somebody to now say, okay, how do I do this on every project? How do I try to take that forward, and without, again, all the additional hemming and hawing or the additional cost, be able to at least approach the problem and say it's solvable in a way that's knowable without being like, oh God, it's going to take forever, right? But I think also, again, my pitch to the architectural community is that even if owners are not asking for this, I think there is a way that you can start to put this into every one of your projects that makes sense. I like sneaky sustainability, and I would encourage figuring out ways to replicate some of this, maybe on like really boring stuff, like your fiberglass insulation, or maybe it is just a line in a product specification that's not a finished product that no one is going to care if it changes and it's a more sustainable product. Excuse me. So I think ideas like that we can proliferate this and make the standard practice is the key. And I think having good partners that are willing to be like, oh, we could solve that problem, and then be like, yeah, we solved that problem. Let's do it again, is really, really important.
I think that the construction, I put the slide up that's like, we built buildings the same way for, forever. And so there's, the construction mindset is like, well, we're just going to keep doing it that way. But what you're saying is that it doesn't take very long for new practices to become status quo. Yeah.
Maybe just given the amount of hands that were raised in the room of like people are thinking about this for the first time in terms of incorporating it in your projects, how do we offer some feedback on how to not have to reinvent this wheel? I think that's something we're dealing with a lot on the deployment of our guidelines. Like we have this primary deliverable that's called a circular design and construction plan. And there are a lot of like repeatable deliverables in that. It's about identifying who your partner map is, who are your ecosystems, doing like selective salvage modeling for particular materials. How in your projects are you figuring out how to take a learning and then scale it more broadly so that you don't have to work with the same contractors again and again because they're the only ones who know how to do it? Or is that still a question mark for you? Sydney, I know you have your float glass group, and that's been a really great way of scaling learnings. I know Borough Happold has been hosting events akin to this one.
I mean, I talk to a lot of people. I basically share everything. I try to share as much as we have learned on projects like this. Like I'm on the like big road show of like, guys, it's super easy, figure it out. But I think it is, every time we take on a project at Durst, whether it's ground up construction or a new demo project or a new tenant fit out or a capital improvement, we don't work with just the same contractors. And so every time it's an opportunity to teach someone a new way to do things, especially because I'm lucky, I'm in a position of leverage where I can mandate something on a job. And so I think it's important that I take that and I really set expectations, but I don't set them up to fail. My goal is to set them up to succeed and figure out how it's replicable, to see that it's possible so that the next time somebody asks them to do it, they're like, oh, Durst made us do this already. And they were not impossible, but that they asked a lot. And so what you're asking is totally within the realm. That's frankly, that's my answer, I guess.
Yeah. 10 years ago, there was no discussion about this.
Mm-hmm.
and now that we are having a discussion about this, we're all in the room together.
This may be one of the biggest themes during Climate Week, which I was really excited but surprised by.
Yeah. And so I teach at Pratt as well. I've been teaching there for about 16 years. And in the past 5 years, unprompted, we've had students in my my sort of building construction methods class like be asking about, well, what do we do with these materials? So this is something that's making its way, into the young professionals. They're thinking about these things, and whether it's because I don't know where they're hearing about it, or they're just, they're more sustainability minded than maybe I was when I was that age. I wasn't asking about what we were doing with materials, but I think practitioners, you're gonna start hearing more about these maybe from the bottom up, and we try and do everything we can to support that. Because if we're having conversations in our offices and in our practices, that's going to start to translate into how we're approaching projects. Whether our clients are totally plugged into the ideas or not, if we're having the discussion, we can be proactive about that. We can bring that into our designs.
That's great. And maybe just one last question before we open it to audience Q&A. What can professionals in this room do to better be part of this conversation?
Specifications. Definitely think about both demo and how your role in showing demand in the market is so key. I would say those two things. And also, you have a lot of power, even if, again, an owner doesn't request something or mandate something. And I think thinking creatively about how to use that, again, sneakily, is really, you guys are good at it, right? Designers are creative. I think it's an opportunity for you to get these in there without it making a substantial impact. With it having a substantial impact, without it making a substantial impact on bottom line or in terms of schedule.
Yeah, I think that those are the levers that we have as designers to use, is how we specify and how we design. But similar to energy codes are focused on operational carbon for the most part, but they weren't always. And we as practitioners started making decisions to use better performing window systems. We started making decisions to use better insulation. And then the code has been somewhat behind that, but now that's mandated. I think, embodied carbon is sort of the next thing that's going to happen and be mandated. So I think if we try and be on the forefront of that as practitioners, it makes bringing our clients into that sort of regulatory space easier.
Awesome. Well, thank you so much to these amazing speakers today for contributing your time and expertise. I think we have some time for a couple of questions folks want to ask. Be right up here.
This is a wander into education for a moment, because this is possibly the most interesting presentation I've seen at AIA this year. It's November. But and you're nerdy, and I'm going to buy you both a really nice silk scarf and show you how to throw it over your shoulder so that you'll fit in the architectural community. But are there textbooks? This is fascinating as all hell, but it would be fun to. Thanks for pointing out. It would be fun to be able to replay it a little bit. There's a lot of material, and you walk out of here saying, "Damn, that was good." But now, literally, step one, when I get out that front door on LaGuardia Place, I'm not going to know what to do. I mean, I'm retired; I don't have to know, but I want other people to know. So, can all this find its way into some sort of summary thing that can sit on your desk, or in what my friend calls his arm library? He's a merchant marine officer, and he has a group of books that he would take with him if he had to abandon ship. And I'm wondering, how do you get this knowledge into really digestible form for us idiots?
Yeah, I mean, I have a really self-serving recommendation in that EDC, which has been referenced a few times, has put out a set of circular design and construction guidelines, which is a 30-page implementation roadmap that sort of like set the stage for why this is important, what the city's priorities are, particularly around driving embodied carbon reduction, and then a series of strategies, steps throughout a project's life cycle, material focus areas, and deliverables that we're leveraging to help make this a success. And so I would be happy to talk to you about those deliverables or anyone in this room, but I would say those guidelines plus other guidelines that were referenced in these presentations are a great place to start.
And I skipped 2 slides at the end of my presentation. One was related to jurisdictions worldwide that are mandating embodied carbon caps and circularity requirements for buildings that are either owned by those jurisdictions and being reused, similar to EDC, but also another slide with places in the U.S. that are doing the same thing. So reading reading that legislation or those regulations is another place to start, just to understand like what are they actually asking here. And then I would just say for our learning process has just been an enormous amount of talking to people. I don't know that there is a definitive one-stop shop or like the intro to circularity that it's like, oh yeah, idiot's guide to circularity. Maybe, I don't know, I feel like
I gotta write it.
Yeah.
I mean, Arup has a really great guide on like intro to circularity in the built environment. If what you're looking for is more of like an introduction to a lot of these concepts, if you're looking for direct implementation guides, there are several entities, not just the city, but also in the private sector that have put out like actual implementation roadmaps. And so I think it also just depends on how you're trying to interface with it.
Let me say in my high school physics class, considered by some to be a very technical subject, and someone had the audacity to print on the cover of a textbook, hardcover, physics. And I'm wondering if that, the field that's been going on for thousands of years in some form could somehow be condensed into a book that says physics on the cover. And one thinks that, I mean, almost no book called architecture, but that seems to me like something that you could, you need. People are so skeptical of religion, but you do need Bibles.
Let us know if you write one. Let us know if you write one with all your free time.
Oh, you're right.
So I have a question about, I think this is the second time I've been to a thing here at the AIA, and I feel like I always bring up the same thing that architects don't like to talk about, which is money. And buildings are products, and architects don't like to talk about that, and they certainly didn't talk about that when I was in school. I applaud you guys for the talk, the things that you're pushing, especially in your buildings and in school. But my question is, so with the Durst organization, you said developers, owners, operators, you're holding your properties. You're not harvesting your properties, right? So you have, aside from whatever the financial benefits are or are not relative to the circularity of those materials, you are thinking, and you mentioned it in some of your notes about durability, et cetera, how you're cleaning it. You have, you're thinking about the full life cycle of the building. Also something we didn't talk about in school when I was in school, which is very frustrating. I work for a major property management company that is involved in a lot of capital improvement projects. And I can't tell you how frustrating it is for me now being on the other side, because I worked building buildings for 20 years. Oh my gosh, nobody thought about how do we get the pipes out of this building? Wait, we have to tear open how many kitchens to replace the gas valves for the riser replacement project, whatever it is, right? We don't think in that way. Owner operators do, because they're thinking about the long-term operating costs. So my question for you is, how can we, and sort of on the back of his question is, how do we find a way to get this information in the hands of those developers who are harvesting properties? How do we sell it, or how do we either make it money neutral or make them save money in the process? Because in my experience, if you can't put a dollar to it, they just don't care. And it's just the way of the world. So we have to talk in terms of money.
Such a good question. And I wish I had really good answers for you. I think I think you have to speak their language a bit when you talk about it. So I'm gonna use a line that's not mine. When we talked about the exterior facade discussion about how do you set yourself up to be able to actually recapture facade glazing in a way that makes sense. The term one of the fellow panelists used was design for maintenance. And I think developers, to your point, even if they're going to sell it, they still understand maintenance requirements. Like you've got to clean glass. Stuff is going to break. I hear you. If it's like a 5-10 year hold, you're not thinking 50 years down the line, but you are probably thinking at least 5. And you still have to be able to get someone in there, again, to get their hand around the glass and be able to clean it, or to be able to replace seals or whatever you need to do, right? There's a maintenance component that I think everyone understands. And if you frame it as a maintenance conversation where it's easier for you to upkeep your building, like replacing a carpet tile easily because you're not putting down broadloom, or thinking about how your window assembly works so that you can easily clean it, or if it breaks, it is easier for you to be able to take that pane of glass and put in a new one. I think that's language that a building owner understands. So I think it's the framing of it that maybe it's the shift of just understanding the considerations that the owner has and trying to fit this into their language. Maybe change the story. Yeah. Like, I don't care how I have to talk to anyone about this stuff. I will use whatever method I need to, and it's not the same outcome as what I'm looking for. And if I have to shift that with a manufacturer of how I'm talking to them, I will, because it doesn't matter how I need to present it. It just matters what the outcome needs to be.
I think an interesting thing with dealing with different kind of clients that have a different time horizon for their project is a real challenge. And I think, Sydney, you're right. You have to be able to tailor your language. But I think for any building owner, whether they're going to hold their building or tenant, they're going to hold the property for 5 years, 10 years, 30 years, 50 years, whatever it happens to be. Maintenance is always something that everybody's like, I get it. You're like, okay, what do we do with this window? Oh, you have to be able to detail this thing so you can pull the glass off, so you can maintain it at least at the very at the basic level. I don't have a perfect answer for that other than to say change the language and put it in terms that that your audience can sort of grapple with in a tangible way.
At the back?
Oh, Todd's gonna come. Todd.
Yeah.
Assuming, you guys can tell me if I'm wrong, I would assume that reusing materials is probably less carbon intensive than recycling materials. Prioritizing that. This question might be for Ben or everybody. Recognizing that codes are changing, a lot of products are taking off buildings are old, as you mentioned, brick, and trying to understand the structural properties and materials. Are you guys seeing movement in product passports as far as, as we move forward, if we want to reuse a fiber cement panel as opposed to recycle it, knowing what's in that material and feeling more confident as a design professional to actually meet code and meet the current code with that material? I'm just curious where the industry is moving on that.
Yeah, I think that's a really good question, because just to sort of dig into kind of the implication there, especially for existing buildings, is when we pull stuff off of these old buildings, the first question is we ask is it toxic, right? Does it have PCBs in it? Does it have asbestos in it? Does it have something else in it that makes it hazardous to deal with? Not to mention breaking glass is literally hazardous. Okay.
Sawdust toxic?
Yeah, exactly. So, okay. I see people running around. It's going to be okay. We're okay. I think for what we're doing now, we need to be able to leverage the documentation in the future. So I don't know how many existing building projects that I've gone to and said, "Hey, can we see the documents for the project?" And you take you down to some storage room in the basement, and they open up a file cabinet, and they're like, "Well, we have this one drawing." I'm like, "This is a 30-story building. You have one drawing." We have different tools available to us today, and not saying that in 50 years I'm not going to ask the question, "Oh gosh, do we even have that version of Revit to open up this model anymore?" But there is so much information that we can embed and then potentially certify through passports and things like that, that I think technology can help us in those cases to be able to say, "Oh, this material that they used when they built this building in 2025, it doesn't have toxic materials in it. It's certified not to have toxic materials in it. Oh, we can potentially reuse it in these ways because it has these components in it." But I think that leveraging our digital tools and leveraging the way that the industry is working now, both the design industry and the construction industry, to embed that information in a really accessible way.
Do I have time to do like 2 seconds? No?
No,
Okay. So actually, Todd, one of the best partners we have right now in me better understanding what is in my buildings from an interiors perspective is actually our carpet manufacturer, because they, even without me knowing what a tenant might be specifying, they can tell me where their product is. And I think actually this is an interesting conversation for you and I, because I think there's probably a symbiotic relationship where I need to tell you that I'm buying your product and how much of it, and making sure you know that I bought, $20 million worth of insulation, and that here it is, and here's where I put it. But the same, I think, would be reciprocal from a manufacturing standpoint. I think you're right in that the documentation you have about the material that you've sold me, and certainly the quantity and this kind of verification, which we ask for of the exclusions, the chemical exclusions, and any LCA info, I think it's a mutually beneficial thing, where if we both have that data available to us, I think we can leverage that data for future reclamation. Yeah. It's not happening.
It's not. It's new.
Yeah.
Easily pulled off. Yeah.
Throw it into the vintage cladding store, and architects can go and prioritize using products that are already used first, right? But if they don't know that product meet
Exactly.
requirements or VOC requirements, then every project we're doing today with these materials is a lost opportunity for 30 or 40 years from now. So just trying to put those pieces together.
Yeah. We can actually take one more question before we break for coffee. So, anyone in the audience?
Giving us an opportunity to
I would
nerd out a
like
little more.
to know what you see as the possibility or the mapping of getting small projects hooked up with you big projects, because my problem is I can't do this because my projects are small projects. I work for a big organization. It has maintenance requirements, all these wonderful things. We even have a little leverage, but I have 6 windows and 20 windows, not a curtain wall to get rid of, or, and so on. I couldn't even get rid of some granite pavers the other day in a decent way, because it was all about getting it off the site, and it has to be done now. If there isn't a database of projects that I could find, I know that granite paver has a potential buyer somewhere or user that would like to have them. I just don't know where they are.
Yeah, I mean, the city is spending a ton of time thinking about the concept of materials marketplace, whether that exists as physical infrastructure, digital infrastructure, likely a combination of both, just given storage is like a very unique constraint. And so I think it's very likely that the city props up something to help facilitate implementation like this so that there can be aggregation for smaller projects, whereas like larger projects also have the benefit of having portfolios and can coordinate across them, which I think is currently EDC's approach as we figure this out as well. What I will say is that we're talking to a lot of technology platforms that exist today, like platforms like Reaplease and others that are trying to plug what is some of this gap. I think what's tricky about it sort of feeds into the previous conversation that a lot of data about those materials is self-reported. And so there isn't necessarily a way to like standardize consistency and quality of those materials unless everybody is already collecting really smart data about them. And so to the extent that you can be doing that and leveraging those platforms as best as you can. But otherwise, I think it's about joining these types of conversations, joining these types of groups that are looking to aggregate and just seeing if you can capitalize on some economies of scale by building partnerships until there's broader infrastructure online.
Yeah. Nothing to add. I think that's perfect.
Happy to talk more about it though.
Excellent discussion. I guess we'll have to break for coffee right now. But thank you so much.
Thanks for having us.
Thank you for having us. Yeah.
Thanks everyone.
Welcome everyone to session 2, which is called Affordable, Zoned, and Technically Built. The theme of this panel is the City of Yes zoning overhaul and the challenges and opportunities for affordable housing. As Chris said, I'm David Levine, a senior associate at Datner Architects and a member of the Building Science Committee, and pleased to introduce our 4 panelists. Howard Slatkin has generously offered to moderate today's discussion. He's the executive director of the Citizens Housing and Planning Council, a venerable nonprofit research and education organization focused on housing and planning in New York City. Prior to joining CHPC, Howard served as the deputy executive director of strategic planning at New York City Department of City Planning, where he oversaw long-term planning, housing planning, development, and a range of citywide initiatives to promote housing supply, affordability, economic development, and sustainability. And at DCP, Howard was the director of sustainability and led the Zone Green initiatives, a set of zoning and legislative changes that promote green buildings. So he's a great fit for the panel. We're also joined by our panel. John Wolfling is a partner at Datner Architects and is committed to creating sustainable and resource-efficient designs using a holistic approach that reduces impacts on the environment and positively affects the health and comfort of building occupants. John's expertise and passionate enthusiasm for zoning, construction, building systems, and passive house principles help him guide the design of sustainable multifamily and mixed-use housing at the firm. We're also joined by Carmel Pratt, founder and principal of ZAZ NRG and a senior technical advisor at Bright Power. Carmel provides expert guidance on building performance and sustainability for new construction and rehabilitation projects. She specializes in sustainability services, including certifications, energy modeling, and building decarbonization consulting. Throughout her career, Carmel has actively volunteered with industry groups to advance policy, program development, and open source resources, and is generously committing her time today too. So we appreciate that. And Nicole Vlado-Torres is also joining us. She's the director of capital projects at the Public Housing Community Fund. Nicole is an affordable housing architect and strong advocate. In her role at the fund, she supports the creation of open space and community center projects across NYCHA's portfolio. Nicole also wears other hats, such as being the co-chair of the AIA New York Housing Committee, the NYCOBA NOMA Cultural Facilities Committee, and also serves as an adjunct faculty member teaching professional practice at Cooper Union. So with that, I'm going to hand it over to Howard, who's going to make some introductory remarks before the panel.
Hi. Good morning, everyone.
Good morning.
Thank you for having me here. I have to say, I enjoy coming to the Center for Architecture despite, perhaps because of my complete lack of architectural training or credentials. I am a city planner and I speak zoning, among other languages. But throughout my career, over many years, the center and exchange between the architectural community and planning practice has been immensely important to my work, and I think to the success of zoning and public policy initiatives within New York City. So I think this is a great opportunity today to talk about the latest. There's been a lot of change, and I think it's a great opportunity to take stock of what has changed, what its significance is, and what lies ahead of us. I don't have to tell people in this room that zoning is an important force that helps shape the city, but it's really important for it to always be in an active dialogue with the architects and other practitioners who are doing the daily work of shaping our buildings and our built environment. What sounds like a good idea to planners or to other decision makers and participants, elected officials and others in the process of writing zoning only produces good results if it's technically feasible and financially achievable. Over the years, I've had either the insight or the good fortune, maybe a little of both, to lead a number of initiatives that reworked New York City's zoning to better respond to the challenges of the moment. And each time we did this, it was essential to understand the perspectives and the experiences of the users of the zoning resolution. The projects that I've had the privilege of being part of include several generations of the city's inclusionary zoning regulations, efforts to stimulate, encourage, force at times the creation of affordable housing in conjunction with new housing development. There's Zone Green in 2012, which was the first effort to go through the entire zoning resolution to align regulations with the city's sustainability goals. I'm proud that that initiative won the American Planning Association's National Award for Environmental Planning, and it's led to more continuous thinking over the years since. There was zoning for quality and affordability. If you were part of any of these, feel free to applaud or not. There was a zoning for quality and affordability in 2016, in which city planning began trying to unknot the straitjacket that contextual zoning envelopes had begun to put on housing in particular, which had unfortunately made enemies of quantity and quality. And then, of course, there's the City of Yes, which over the past several years has unfolded what you might call a boxed set of 3 rezonings, citywide zoning changes focused on issues related to sustainability, economic development, and housing. I was fortunate enough to be at the Department of City Planning when we launched these initiatives. I was on the sidelines when they were going on, sort of shouting and cheering them on, and finally at the finish line, welcoming them after their successful adoption. It was, they're probably in this space, you've heard people say many times, this is the most significant zoning change since 1961. I think I couldn't count the number of times I've heard that. In fact, this probably was. If you take these 3 changes together, there was a dramatic rewriting of a lot of the zoning resolution. There's a lot of technical detail to it. When I say rewriting, the restructuring of Article 2 of the zoning resolution that deals with housing was a big part of the changes. It wasn't what was most talked about in public, in the public debate, but there was a lot of reworking of the zoning to try to make it work more in a more straightforward manner and to address all the housing supply challenges that the city's facing. So I'm not going to try to inventory what the contents of these initiatives were, because I want you to hear from our panelists. But suffice it to say, the objective was to see more housing built, more energy efficient buildings, more cost effective buildings, a wider range of housing types, and generally, beneath all this, to free up architects to design better buildings for their clients and the building users. Today's panelists are going to take an early look at the results of these changes and what they have accomplished, what they mean for scaling up the delivery of high performance, high quality housing, what the technical implications of them are, what has become possible and easier, and because we're always striving to do better, what isn't yet possible or easier, what's still elusive. And I think that's probably where we'll aim to conclude today's discussion. So, and I haven't advance the slide, which summarizes much of this as well. But to lead this off, the discussion off, I'd like to invite up John Wolfling to give the first presentation.
So I think Howard actually did. So I think Howard exhibited a great deal of humility there in his various roles, and specifically at CPHC. He has really advocated for some of these major changes. So before I met you, I always wondered, how does this work get done? Who is behind the scenes making sure this work is done? And Howard is one of those people. So, yes, thank you. So I want to show you a project. I'm going to show two projects today that are started before City of Yes went into play. And if we all remember back, it's a little easy to forget, but I was actually not sure if City of Yes was going to be passed. I think there was a lot of resistance to it. We used to be on my community board, and the community board was like hair on fire. This is going to destroy the fabric of our neighborhood. They might be right. I think they're wrong. But there was a lot of concern about that. I wasn't sure if it was going to pass given all the resistance. But this is a project that's in East New York. It actually got rezoned through the ZQA. It's the East New York rezoning. The council member lost his seat because he voted in favor of it, Espinal. This is pre-City of Yes. Post-City of Yes, we were actually able to add a whole other floor to this building and add 28 units to the project. This is an all-affordable project. It's being developed by Phipps Houses. It's going to be passive house. It's going to be geothermal. So the significance of City of Yes is major for a project like this. I just want to go back one more time. So we get to add a whole floor, but is the design that much different? So community board members kind of like, temper your like fear of what's going on here. So this is one example that we were really able to benefit with just like a stroke of the pen with what happened with City of Yes for housing opportunity. This is a project in Coney Island. We actually had a slightly different outcome on this one. We were able to add a lot more density to this, a whole other floor again. But this is a senior housing project that's using the SARA program. For those of you that work with HPD, you know what that means. It's a senior affordable term sheet. This was a big project to begin with. At this size, it was 248 units. When we did this, we added, I think, 27 more apartments, and it didn't fit into the SARA box very well. It was way beyond what our developer thought that HPD would be able to finance. So we ended up with, So we ended up staying with this. But what we were able to do is do something that was very beneficial to the project. This is also going to be a passive house project. So we have a lot of systems in this building that the more standard affordable housing building might not have. We have ERVs, energy recovery ventilation, which means we have both supply and return to every one of the habitable rooms, which means a little bit more ductwork. The way we've done it here is we have a centralized ERV, we do that because it's much easier to go into a 250 unit building and replace filters in one location as opposed to going to 250 or 248 ERVs in individual apartments. So it's a maintenance benefit to have a centralized system, but that means more ductwork. So what we were able to do with the City of Yes changes, and you can see on the right-hand side here, a couple things. The green is the post-City of Yes values, but you can see on the far right-hand side, 65 feet, the maximum base height for the R6 district did not change. And I think that was primarily because of a kind of a strategic presentation of City of Yes to community boards. And stakeholders, that's your maximum base height's not really going to change, at least in an R6A district. But you can see the maximum base height in an R7A, and we're in a split district. We're partly R6A, partly R6A, R7A. So the maximum base height in R7A went from 75 to 85. You could add a whole other floor. That's why that rendering showed a whole other floor. Maximum building height in the R6A, that did go up. It went from 85 to 95. Another thing for those in the room that are zoning enthusiasts, there is the pre-City of Yes zoning resolution reference, Article 2, Chapter 3, 664, and the post-City of Yes reference, Article 2, Chapter 3, 432. This is a much more simple way. What Howard was talking about with the residential regs changing and being simplified and consolidated, this is one of the benefits. Now you can go to one section of the zoning resolution to find all of the building heights that are permitted in contextual districts. In the old system, you had to go to 662, 664, check into the commercial regs. It was a mess. The maximum building height in R7A is also changed. Another 20 feet has been added to this volume. Now, we didn't take advantage of all of this for the additional units, but what we were able to do is give ourselves a little bit more breathing room at the top of the building. We were able to add 8 inches at each one of these floors, which is where we have a lot of these complex systems transferring. We have dropped slabs where we have accessible terraces. So there's a lot going on at the top of this building that's very complicated, that City of Yes really benefited us in this building section. It's going to ease our coordination efforts down the road. So even if you aren't able to take advantage of the additional heights for a unit count change, you could definitely take advantage of some of the height changes for better coordination and better building heights and better building performance as our buildings get more complicated. So that's it for me. I will hand it off to Carmel.
Thanks, John. It's great to see some tangible examples. I'm wearing my Bright Power hat today, and I'm going to be quickly reviewing some of the specifics of the new regulations and how they impact affordable housing, energy, and building performance, and importantly, how to pursue that ultra-low energy building 5% floor area ratio exemption that John covered in the first project, which did end up taking advantage of that exemption. Just a warning and an apology, these slides are very dense, and for the sake of time, I am going to be running through them, so if you want to reference them afterward, you can find them through the committee for the granular details. So, you know, the City of Yes covered many areas, and Howard kind of summarized that beautifully, and it's important to remember, you know, that these cover different parts of our city, right? We don't have the time to dive into each of them, but it's important to remember that they go well beyond buildings, and they aim to decarbonize energy, transit, waste, and water as well. And many of the updated regulations overlap nicely, as Howard was saying, right? They took away, removed some of the obstacles that were getting in the way from each other, and one area impacts another. For now, I'm just going to be focusing on the 3 buildings-related regulations, as well as touching on rooftop solar. So let's get into the building section, literally. One key update removes the floor area ratio hurdle that made high-performance facade retrofits difficult or impossible in some cases. Essentially, new walls that comply with energy code will no longer count against your FAR. They allow thicker, more robustly insulated and thermal bridge-free facade upgrades. So that's great on the retrofit side. Similarly, on the new construction side, it was difficult under Zone Green to calculate and qualify for the wall thickness floor area exemption when designing thermally robust envelopes. And even then, this exemption only afforded up to 8 additional inches of wall thickness. Whereas now, instead of focusing on one wall area and U-factor calculation at a time, the new regulation prioritizes whole building performance through the new flat 5% floor area ratio exemption. And these high-performance buildings are designated as what we call ultra-low energy buildings, or ULEB, if you've been throwing that term around a lot now to condense it. So that's what I'm going to be diving into in more detail. And just a quick snapshot of what was in place previously. Ignore the today. I also failed to mention, although it's written on the slide, that many of this that is branded as NYC planning is directly from NYC planning during the proposal phase. I'm going a little bit back in history. So what is shown as today was actually yesterday, and these were the proposed pathways for that ULEB 5% exemption. Landing on an agreed definition of ULEB, of an ultra-low energy building, was a very difficult part of that proposal process, as I'm sure Howard can speak much better to. And it changed several times before the actual final zoning text language was amended. So just a brief history. At some point in the proposals, it was suggested that ULEB designation required a building to be 50% better than code, better than ASHRAE 90.1. And this was pretty aggressive and unrealistic for many buildings, even those designed to passive house. So that was reduced to 15%, which is in line with current Energy Star program requirements as an example. And an additional pathway was proposed for projects meeting energy certification standards that were better than code, like Energy Star or Passive House or Enterprise Green Communities, which requires some of those co-programs. Unfortunately, that proxy energy certification program pathway was quickly blocked, primarily due to proprietary energy modeling softwares that are required for some of those programs, which conflicts with the New York State Department of State Division of Building Standards and Codes, which essentially limits compliant energy modeling software to open source like DOE2 and Energy Plus. So instead, an alternate pathway was proposed to meet flat site energy use intensity, EUI, targets based on building height, like you see in the red text there. Those targets that you see in this version of the proposal came from an ICERTA study that was done to compare modeled site EUIs between different modeling softwares. And here's an excerpt from that comparison study, which compared ASHRAE modeling using eQuest to passive house modeling using both PHI, PHBP, and FIAS-WFI softwares. It was decided that setting specific site EUI limits was still problematic due to different modeling methodologies. And so ultimately, we had to ground ourselves back in this, moving away from the debate of energy modeling software and accuracy. It was important to note and remind ourselves of the reality that passive house buildings do outperform conventionally code-built buildings by a healthy margin. This now pretty outdated report proves that and confirmed that that healthy margin is well above that 15% better than code threshold, which was the intent of the exemption. Nonetheless, it was difficult to come to an agreement on that alternate pathway option, and ultimately, the zoning text language as amended and shown here requires buildings under 3 stories to be net zero using on-site renewable energy, and buildings over 3 stories had to meet that 15% better than NYC current code, energy code. And it also enforces that the modeling methods are per the energy code, which essentially requires ASHRAE modeling. Now, when you're looking at affordable buildings that are also either by voluntary or by required subsidy pursuing other certification programs, in addition to the ASHRAE modeling and supporting calculations and documentation that are required to meet that ULEB, there's also the additional modeling required for Passive House or for Energy Star. And on top of that, buildings over 25,000 square feet are additionally required to complete a COM check. So there's this duplicative, effort and documentation, especially for projects pursuing Passive House or other certification standards. So this duplicative effort creates bottlenecks that increase soft costs right now, especially early in the design and development timeline. And it does negatively impact overall project timeline, which slows down our collective ability to create more affordable housing, right? That is the intent. While these new regulations are great in so many ways, right? When we saw those examples in real life that John showed, this continues to be an iterative process of learning what pain points come up and how to reduce the code review cycle and avoid lengthy and costly redesigns when you're not sure whether you're going to meet that FAR exemption and you have to balance your other certification programs. And I'm sure we'll get into some questions and discussion later about other pain points and what we think might be coming in the future. So briefly looking at this process hurdle through a real project example, I'm going to show a 21-story, 341-unit affordable development pursuing Passive House, Energy Star, Enterprise Green Communities, and that ULEB 5% FAR exemption. Again, due to the commercial building designation over 25,000 square feet and following the performance compliance pathway that I know is very hard to read on this screen, but it's basically telling you what you need to do for modeling based on the building size. So the building had to do both ASHRAE and ComCheck for envelope backstop compliance, as well as the Passive House modeling. So Bright Power was contracted to do the code compliant energy modeling and prioritize that endeavor in order to support the time crunch of the design timeline, right? The architects need to know whether they can add that extra floor. Building massing is just this very important gateway to get through design development. And so that was prioritized in the later half of 2024. And the building as designed complied with that 15% reduction. As you can see here, this is from the compliance report, so you can get a peek into like what the submission is to DOB. Now, based on the envelope backstop with ComCheck, I just want to make, again, a little note on how it's not perfect yet, and we're learning some of the hopefully next iterative additions to the regulation. But right now, the building envelope was only coming up as 5% better than code based on that ComCheck envelope backstop. And it's allowed to be up to 15% worse. So when we're looking at the intent of better buildings, there's still a bit of a gap there, and maybe some hidden, prioritization of systems over envelope, for example. We know that ASHRAE and IECC energy codes have been successful in incrementally reducing building energy use, right? They're effective standards to point to, especially for setting further reduction goals. They're typically what we say, to use as a benchmark, and then whatever percent better as the goal. But the reality is that passive house standards also work towards that same goal, and it's evidenced by actual building performance data that I shared previously. So this is just, again, good historical to see how far we've come on the code side, whereas passive house programs, Energy Star programs, they're doing the same thing. Every time they come out with a new version, they are making sure that they are 15% or more better than current code. So this is an example, and I think we'll talk about it later, about how there's still some of these obstacles of code versus certification program versions, design guidelines for affordable housing from HPD and HCR, and how all of these things can work better together to kind of get out of our ways of creating more housing. For this example project, because the focus was on getting through the ULEB compliance review process first, it wasn't until months later that Bright Power was able to start the passive house modeling for the project. And that modeling and the targets to achieve passive house are shown here. There's the as designed, which was based on the design that was submitted for compliance with ULEB. And then as a best practice approach, Bright Power always recommends that we aim at early design for achieving 15% under our passive house target threshold. That way, between design and construction, we don't have any surprises in achieving those targets. And so, as designed and compliant with ULEB, the building wasn't meeting that 15% buffer. And this is just, case 2 you're seeing is one of like 7 or more cases where we recommended further reductions to the building. That process and design is essential, right? It's making the building better. And we were able to use the passive house model to do that, and the targets helped us to create that framework and those goals, whereas the ULEB side didn't. That was just kind of like this paperwork exercise to get through the compliance. So, there was a need to further improve the performance beyond that ULEB compliance. And ultimately, this process is resulting in PA filings and redesigns because of that kind of timing issue and modeling issue. Beyond the building, very quickly, City of Yes is focused on decarbonizing our energy grids as well. So I'm just going to touch briefly on solar PV that is working towards that effort. Looking at renewable energy generation on the roof, solar PV arrays on rooftops used to be very heavily limited by setback requirements and other things. So similar to how John showed a before and after, right? That is after the passing of City of Yes, the new regulation removes many of those restrictions and allows essentially full coverage of solar, right? So there's that back and forth. And then just once more to reiterate how this change looks like from the ground level, we are getting out of our way of providing much more renewable energy on site. So again, just to recap that the City of Yes had many great updates that work together more collaboratively towards that carbon neutrality goal, but there are still some further refinements needed to help make the actual process in practice less cumbersome for us as practitioners. Thank you, and I'm passing it on to Nicole. I hope you all remember that for the quiz later. Good morning. Let's see. Some of you may have already heard me say in different spaces and time that what I love about City of Yes is that it doesn't just increase housing opportunity in high-density districts, right? It's considering the entire city, which offers us the chance to think about projects beyond those that we've seen just now and look at things that maybe aren't so term sheet friendly and approach this notion of gentle densification throughout New York. I'm excited about that. But I'll also preface this by making it clear that I'm not an expert about any of the things I'm going to talk about with you right now. I'm really speaking today as the co-chair of the Housing Committee, where I get to share a brain with so many different architects and housing experts, and together we have a lot of technical experience on these topics of housing at all different scales and project types. And we do a lot of advocacy through our work, just like Building Science is doing such a great job today by bringing us all together. You know, we put together meetings and events where we really get to sort of tease these ideas out. And that was especially the case leading up to City of Yes, to trying to really explore project types that maybe we're not also familiar with, or some of us are, but not everyone, right? Office to residential conversion projects, ADUs, and mid-density housing. So I'll talk a little bit about those odds and ends just now. And really thinking about one of the things that we do as a committee, similar to Building Science's advocacy work, right? So it's not just about producing design and celebrating great design, but really thinking about how to help push the agenda and use our expertise. And one of the things leading up to City of Yes was really working with the council to help alleviate some anxieties that particular districts were having around densification. I'm just going to show you an example that Dara Borowski and Rick Ekstrom did from Area Architects in Jamaica, Queens, where we were looking at a particular site to really understand what an ADU might look like. And this was they were very smart. They looked at a 35-foot wide site in an R2 district, which per the previous zoning, couldn't even have a new house built on it. So they started by looking at, you know, sort of how ordinary that house might be if added to the site, and that the new City of Yes zoning provided that opportunity, right? We could now put a house on this site. And then looking from the street view at how sort of let's say, not that exciting, right? Seeing this ADU in the back, whether it's attached or detached, it wasn't disrupting a sense of the neighborhood character. So we get past advocacy, right? Now we've got the opportunity to implement, and that's a lot of what we're thinking about today in the symposium. And what I think is really interesting after all this sort of anxiety around something like ADUs to learn, and this is images from the Regional Planning Association study that they posted in September of this year, that 12% of 1- and 2-family homes in New York City will be eligible to become ADUs, right? Really small number. And at best, maybe that's 3 or 4% of new housing stock in New York City. And a lot of that is because of eligibility criteria that's baked into the zoning. You know, we can't have row houses or townhouses or other attached building stock have ADUs. It makes sense, right? You can't get to them. But I think there may be creative solutions, but that is really restricting the majority of units or opportunities on sites. And the other is dimensional requirements for the sites themselves, which were made a bit more conservative by the modifications that the council required for, say, lot coverage on these sites. But really, I think, you know, what we've been talking about in terms of technical challenges for these projects has often been concerns around administrative burden. And we had a little bit of a sort of hiccup right at the end of last year until very recently, where the zoning allowed us to have ADUs, but the building code didn't yet. We just recently, at the end of September, passed rules, which are now in practice, and we can pull permits and build these projects. But it wasn't super clear. And sometimes that happens when Carmel was alluding to that, where our zoning and our code and our various agency regulations don't necessarily align. And sometimes we have that similar problem, as John was suggesting, where maybe our zoning and our codes and our regulations don't align with our actual practices for design. So if we're thinking about, you know, new technologies, if we're thinking about mass timber, if we're thinking about passive house design, can we actually achieve that within the envelopes that we're looking at today? Thankfully now these projects at Staten Island can go into construction. The other administrative burden we've really been thinking about, or technical challenge, is cost, right? And administrative burdens to what these developers for these projects might be, which are homeowners, right? Not our usual developer. And so the city is thinking about this and has been for some time, and you may have contributed ideas for pre-approved plans that might go into a library. I think that's a very new thing for us in the city to imagine. What does that look like? How do we implement it? And then what is our role as architects if we're sort of not necessarily involved in these projects as directly as we might have been originally? And I think that's okay. I think there's still a lot of advising we're going to do. There are a lot of gray areas still. I think there's a lot of confusion within, folks working in these typologies around the difference, say, between basement ADUs and basement legalization projects, and whether or not all of these projects actually need independent electrical service. I think there's still areas that we're going to be able to sort of tease out and help support and advocate for allowing these projects to move forward. And I think possibly working to unlock some of that potential for more eligible sites. And then we move up in scale, right? Now we're thinking about what the zoning offers in terms of mid-density housing, which is something that I think we all love. We have, commercial with residential above, sort of vibrant, rich streets, things we used to be able to build in the 20s through the 50s, and we haven't been able to for a few decades because of more restrictive zonings. I think reminder that City of Yes is not only forward-thinking, but it's a little bit of a sort of repair project on some of our more conservative zoning practices of the last few decades. I think that here, the technical challenges are really financial. How do we make these projects pencil out? This is not a challenge to New York alone. Thankfully, a number of other cities in the country are really thinking about this as their maximum density type of project and are beginning to sort of help push the agenda on really sort of reforming financing and lending practices. And so hopefully these things can start to align to help unlock these projects, which are likely to be developed by smaller developers. And then once that financing really gets unlocked, is there the opportunity to make greater risks and do really fun things with this smaller typology? Can we think about modular and prefabricated design for these projects just as we might for ADUs? Can we think about mass timber, passive house at a smaller scale? I think there's a lot to come. And it dovetails really nicely with our transit-oriented development, where we can, increase capacity on sites within, particular sites, larger sites, 5,000 square feet or more, within a certain half or quarter mile radius from transit, and with the possibility of IBX coming to the city, unlocking more and more of that potential across. And so again, when we can get everything to align from zoning to code to financing models, can we innovate really exciting things for this typology without really changing neighborhood character? That's kind of an amazing thing about transit-oriented development. And then really, I think we love to build new buildings. Architects love empty sites. But we know that one of the most important things that we can do as architects for housing in the city and for, the climate is to really think about preservation and adaptation of our existing building stock. So just thinking about adaptive reuse. Here I'll show examples of office to residential conversions. We've thought a lot about this within the committee. This can extend to hotel conversions and other project types. And this is a place where we really get to innovate. I think this is where building science, can really be explored, because we have these unique parameter challenges of the existing housing stock or the existing buildings that we're transforming into residential housing. So we have to do new things with structure, right? We have to do very new things in terms of MEP, practices and design. And I think that we also get to be innovative about program. We have to think about the facades. There's so much here that we get to sort of solve, and we can learn from these projects and sort of apply these things to different scales and even new construction potentially. But this becomes like the incubator. And I think one thing we get to also innovate is program, and we're doing that already, right? These floor plates are not really intended for residential use, so we have to be creative about residential use. And I show an image of the Barbizon at the top here as a reminder that some of these things that we're thinking about, like co-living, we've done before. So they're not so radical. We should maybe not so be afraid of them, and we can take from lessons learned, both the good and the bad, and move forward on what we do in these spaces. And the impact can be really great. I show 25 Water Street on the left here. John Cetra from Cetra Ready, who's a committee member, shared these images. I understand this to be the largest office to residential conversion in the US currently. Over 1,300 units, 20% of those are affordable. The impact is great. So it's a sprinkling of everything. Maybe we'll get a couple of ADUs. We'll get some increased density in town centers and near transit. And then possibly, hundreds and if not thousands of units with some of these conversions in addition to our new construction. So lots for us to think about and explore. Thank you. I'll go back to the first. first slide? Here, I'll do this and just go back to the first slide so you can see our beautiful faces.
Great. If you have an obstructed view, you'll have a good view of our faces.
I was thinking we could leave it on the energy code. It's amazing how much it changed in just like a short period of time.
Use the microphone.
Okay, thank you.
The waterfall chart here.
This is open book, so.
Okay, keep going.
It was the.
Is that graph?
There, yes, thank you. I think what's amazing here is like 75 is the baseline, and it was kind of stagnant. I mean, there were a few blips, but then, and I guess it corresponds to energy cost increases and people becoming more aware of what it takes to live the way we live and the impact on the planet. So I don't know. This is an optimistic slide.
So, John, thank you for opening it up. We're going to start with that topic then, because there are a few topics that I thought we could dig into. They're topics that you all covered in your great introductory presentations, but this gives us a little opportunity to probe into them some more. And I think there's 4 areas that I want to talk about in terms of what becomes technically possible and what still remains technically elusive under the City of Yes changes. There's quantity of housing and affordable housing. There's the variety of types of housing that are possible and what makes that possible or elusive. There's the quality of the housing, which I think is the most under-discussed topic when we talk about a lot of these issues. It always comes down to how much can you build, how much can you build, how much does it cost. Those are really important things. But how are you meeting the needs of the residents? How are you serving the wide range of different types of residential needs? I think is really important too. And performance. So we can jump in maybe with performance because of the striking chart that shows us how far we've come and highlights this question of how do we, as you pointed out in the regulations, Carmel, the goal of the regulations was to say, well, we know we have increasingly stringent energy codes and that new buildings are going to have to comply. That's not on the table. But how do we continue to nudge things forward? How do we reward people for doing better? And I think this gets to all the procedural and wrinkles and the multi-layered process challenges that you described. How do we do this in a way that actually does encourage it, so that the incentives that are put out there are actually do make it easier rather than become a kind of another procedural tax that you have to pay for doing an innovative project. So I have like years of background in trying to dig into this from a non-technical expert point of view and asking probing questions to technical experts to try to get to a standard. In Zone Green, there was this standard that you mentioned, which was sort of a percentage of in exceedance of code for the exterior wall assembly, which was seen as the most important thing at that moment to innovate on, and not to prioritize only systems improvement. A more holistic approach here under City of Yes. What's good about it, and what things are possible, and what things could be made easier? You highlighted doing one review, doing one energy code analysis would be great. I'll come back to that. But what's good and what's not there yet?
Yeah, I mean, I think you touched on the good, right? We're looking at the building as a whole, and we're looking at this like iterative kind of getting better and better than what is current, and pushing buildings towards that. I think we were talking about this before, but it's this chicken and egg kind of process with the design that if, let's say, a developer isn't sure what certification programs they're pursuing at first, and they're just trying to understand how many units can I get on this lot, and does it pencil, right? Like, it's those very early decisions that I think having a clear, just a clear North Star of, okay, we are going to meet ULEP no matter what. We're also going to pursue Passive House no matter what. Which one do we need to do first to get our pro forma together and to understand the building massing and to just move forward past that like first major gate of design development? I think hopefully, in the future, maybe we can retry that proposal of the proxy program alternate pathway, because we know that those programs, or we can rely on those programs to stay ahead of code and to be meeting that same intent. I think it's a learning process. I think that it's the experience of going through this that will make it better for just working within this current system, or for iterating a update to the regulations. And I think lastly, it's also a, again, experience, but making sure that everybody on all sides understands, like for us to get an answer from the DOB on what physically we needed to submit for documentation for this new pathway, right? It was a bit of a hurdle this time around, but that'll go away. And the architects that we're working with that are going through this process are going to understand each time better. So I'm keeping the optimistic view that we're just in the early process of implementing this. It will get better, and we'll understand what the right pathways are through some projects under our belt.
And can I add something to that? I just think it's actually phenomenal that we're here at the moment where you're like, we're going to do ultra performance or passive house. Like 10 years ago, we were not doing that. And so the sustainability agenda, I think, is an exciting one to follow and to think about, other areas in terms of, design and code and zoning opportunity to really sort of follow the lead of where we are going there. I'd also love, and I'm sure other architects would too, the moment where the required model and design can feel like they're connected and not like you're getting through that box, checking that box and getting through that hurdle, but in fact, there's a little more synergy.
I'll also add, just to augment that, what we now do when we're talking to a developer at the beginning of a project, we tell them, if you want to get this ultra-low energy building deduction, you should do passive house. We can not guarantee it, but this is a tried and true path to get to that level of performance. So it's a way to, stack the deck for passive house. I don't like to take away choice from my clients, but I think it's a very powerful argument to get them to make that leap with a little bit more assurance that there's a back-end benefit.
Right, and that's the perfect example of you decide from the beginning, let's do the passive house model, let's use that to help push our design to the best it can, and then know that we'll meet ULEB no matter what, and we can just get through that checkbox after we've developed our design.
Also, one of the things the 8 inches of deduction versus the 5%, it's like apples and oranges. But one of the things that we did on a project that David and I are working on is when City of Yes this was it economic opportunity? No, it was the carbon neutrality. Yeah, carbon neutrality is the one that introduced the ultra low energy building deduction. We quickly looked at that, and on this project that's about 250,000 square feet, it was an additional 10,000 square foot of deduction, because we were using the old 8-inch deduction. We were able to use the ultra-low energy building, and we were able to add 10,000 square feet of gross floor area that didn't count as zoning floor area. So the building got not bigger, and there's actually something else I want to talk to about quality and quantity. So this building didn't actually get bigger. What we were able to do, and believe me, I feel a little bad about this, is we were able to take away windows into corridors, which is another zoning deduction. When you've got daylight in corridors, you can deduct half of that corridor floor area. But since we had excess floor area, we could grab that floor area at the end of the corridor and put it into an apartment. And then it then reduced our amount of zoning floor area deductions, but we were able to use that. We were able to use the ultra low energy building and what were quality housing deductions for corridors and kind of balance that, make the building better for that one resident, maybe not better for all the residents on that floor. So there is kind of this constant push and pull about quality versus quantity, and I won't say we don't have it perfect, but I think we now have more flexibility.
Yeah, I think I want to come back to that idea of more flexibility and more options to solve the design problem before you for whatever your client's needs are, right? It's not one type of building that the zoning should promote, like the double-loaded corridor with corridors extending to the perimeter of the building. It should be, you can balance that against other considerations. I'm really appreciative of the back and forth over the process of reviewing the ULEB standard, because the origin of all these provisions was, how are we going to create an incentive or a reward for people to do something that goes beyond what code does? And one of the principles that when I was at city planning we tried to adhere to was let them make a decision about what they're trying to accomplish and stick with it, because you know that knowing what your FAR is not something that you can go back and rework later in the design process. You have to know what the size of your building is that you're permitted to build. So this idea, though, that the zoning provides, the standards referenced in the zoning provide a signal that architects can deliver to their clients, or that clients can walk in the door with to begin with, about what the expectation is if you want to use this standard. I think that the clarity of that has a lot of value, and I think that, you know, as you've highlighted, close but not quite in terms of being able to deliver on the clarity of that standard. I remember asking people, so how can you write this without, you know, saying passive house? How can you say passive house without saying passive house? You know, I think earlier drafts were an effort to try to replicate that, but it will, I think, be a work in progress.
It's ULEB.
It doesn't roll off the tongue quite as nicely. We've at CHPC, we've recently coined this term called UHA, for unpronounceable housing acronym.
Is it also known as UHA?
Yeah, that's right. But pronouncing it defeats the anyhow. I want to move into this question though of codes talking to codes, and the multiple layers. I'm always, as somebody who, you know, was a city planner and not a building code expert, I'm always struck by the number of codes that you as architects have to walk between in order to ensure that your building is achieving compliance, and sort of understanding in advance what are all the different filters that you have to run your design through. We described how energy code and zoning do or don't speak to each other. What are other aspects of either City of Yes or things that remain outstanding? What are ways in which maybe the codes do speak to one another, or I should say, as an alternative, try not to talk over each other. Maybe the codes shut up a little bit every once in a while so that you can just design your building. But what are some ways in which the codes may be aligned a little bit better today? What are some outstanding questions about ways that the codes don't speak to each other? Anyone?
I mean, I'm not really an expert on this big picture, but, you know, I think one of the things that we often talk about in the Housing Committee is our dear friend, the multiple dwelling law. And, you know, I think that it's an interesting layer where we have city control over our zoning, city control over our building code. We may have shifting attitudes around building codes that, you know, are aligned with other parts of the country or internationally, but that's, you know, to be determined. But this multiple dwelling law, the process of amending it is such a challenge. And I think we've seen, you know, even though we were able to align some modifications to it to help support the City of Yes, you know, for housing opportunity around office to residential conversions and the FAR cap, you know, there's still more. And I think that there's a lot of hesitation to say, like, we could potentially do even better on conversions and adaptive reuse if we had a little more flexibility. But no one wants to take that on, and the time cycle is challenging. And so that's one piece that I'm, you know, deeply curious about, you know, reform and process. And then, like, you know, that example that I gave is just how can we streamline, or what risks can we take as we know, you know, we have something in the pipeline that's changing. How, you know, we rely on local laws for so long, or bulletins for so long before they actually get codified. And sometimes they don't. I'm always curious about that. But I don't know if you guys want to sort of speak to, in addition to that, these overlays, because I think, again, from project to project, there is the design guidelines from, you know, lender A, and review checklists from lender B, and, you know.
Agency requirements.
Yeah, all of that.
I do have, is anyone here from DEP? Oh, good.
This is a safe space.
Yes, okay. I got to say, one of the things that drives me crazy, well, actually, let me give you a little bit of background. Electrification is part of ultra-low energy building, ULEB. So that, you know, unintended consequence of that is that we have much more demands put on rooftop spaces. At least that's the way our work ends up getting implemented. You've got heat pumps that are electrified. Those often go on the roof. You've got PVs that every project wants to maximize, at least the way we practice with affordable housing. And you've also got Local Law 9294, which says either PVs or stormwater. You've got DEP requirements. This is where I'm going to get maybe a little mean on DEP. There is this rigidity with DEP, and I get it because they're trying to manage stormwater and their infrastructure. But they do not recognize that there is a lot of demands on these roofs. And they're basically saying to our developers, you can't do PVs. We want to see everything green roof that's potentially green roof. And yes, there are systems that can be PVs over green roofs, but that's more expense. So I think that's one of the ways that it's not just maybe it's more the agencies not talking to each other and having some sort of balanced approach for these areas of our buildings that are having so much demand put on them. So I don't know if you want to add to that, or you're probably nodding in agreement.
Yeah, that's just such a great example. And I ended up taking these slides out, and you're welcome, because there's already a lot of slides. But one of the regulations did loosen restrictions on mechanical equipment on the roof, similarly to the way that they did with the coverage of solar PV, and added additional requirements for screening that, right? So it's thinking about the holistic, what's going on in the roof, how is it benefiting the building, but how are people impacted on the ground? And I wholeheartedly agree with your example. I'll use the other example that comes to mind with battery storage. So there's this conflicting fire, FDNY restrictions that don't allow certain size or location of batteries. There's where are you going to put the batteries if they're not on the roof, because there's so much other demand on the roof. And so that's one example where right now that is not possible for every project can only get so far in dancing with the idea of battery storage until usually the fire code takes that off the table.
I think there are a couple of points. First of all, thank you for mentioning the multiple dwelling law at the start of this, because this is, I think this is maybe become a hot topic in the next couple of years with the advancement of the existing building code, and which introduces another layer of, I would say, redundancy in a good sense, in that these regulations that have been in the multiple dwelling law for many years become largely unnecessary. Even the ones that have that haven't already been unnecessary would become unnecessary, and there are opportunities to streamline. I want to share a moment when we launched the residential conversion task force that city planning launched a number of years ago. We were talking to people about changing the multiple dwelling law to allow more flexibility for conversions, which did happen through state legislation. And there was a question at the table, which was, well, which state agency is responsible for implementing the multiple dwelling law? And there were chuckles around the room, and then we answered, there is no state agency. The state legislature writes it, but there's no state agency that implements it. It's the Department of Buildings.
Self-regulate, yes.
And the disconnect there between there's a municipal building. The municipal buildings department is implementing this and has no formal recourse to inform the legislators who are making all these decisions about what's in the multiple dwelling law or not. It's a terrible system. And returning control of that to at least a local government that can, in a best case scenario, talk to itself makes a whole lot of sense.
Sounds so reasonable, Howard.
And I think that a lot of the issues that you described are sort of good intentions colliding with one another, often on rooftops, which is dangerous. You need a parapet for that. But I wanted to also highlight this question of, one of the good intentions in City of Yes was expansion of perimeter screening requirements. And what are some of the implications of that? I think the idea was, we'll let you put more equipment on the rooftops in more places, more flexibly, no limitations on solar PV coverage, et cetera. But you have to, except for solar PV, you have to screen everything on a rooftop, regardless of where it is on the rooftop or what the height of the building is, et cetera. There has to be screening. Has anybody grappled with that one yet?
Yes. And I got to say, I wish there was. I think this gets dangerously close to the judgment and aesthetics of what's beautiful, which I think zoning and building code should just be mute on. They should just stay out of that. So this whole idea of screening equipment, I don't know. It seems like a little bit of an overreach. I've seen a project on the west side of Prospect Park. I think it's actually Chuck Schumer's building. And they've got like the International Space Station on top of that building. And I don't know, there's some...
It tells a story.
It tells a story, yeah, thank you. And obviously that's not gonna get screened. So anyway, I wish there was more freedom and maybe staying away from the aesthetic judgments from our agencies.
And in terms of maintenance, access, operation, I think it introduces a lot of challenges. And I think we were overhearing a little bit from session 1, those concerns around implement this, build it. If we're just drilling a bunch of screens into the roof, we're probably inviting some problems for ourselves down the road.
Yeah, it's a great point. And also, the cost that you're putting into that as opposed to a slightly more efficient system that you're then concealing. And there's nothing wrong with telling the story of how a space is heated and cooled and generates energy, I think, from also like a public education perspective.
So I think we're going to have a few minutes for questions from the audience in just a sec, but I wanted to take one more round or a question for this panel here on process. And Nicole, you mentioned particularly for homeowners or other small clients, process hurdles or access problems in terms of being able to utilize all these code provisions that are well intended out there in order to try and encourage these good outcomes. And you mentioned this idea of like, what are some things that designers can do? What are some other things that maybe other resources can do in order to make those hurdles surmountable? I wanted to ask, what are some ideas about, you talk about whether it's accessory dwelling units, which is the ultimate kind of DIY level project in another city. What can we do to make those processes more navigable, like lower the sort of transactional costs of doing them?
I mean, I think one thing is making the language accessible. I think it's really wonderful, the work that your team does and RPA and others that are, making an effort to translate. You wouldn't know last night me reading aloud the electrical requirements for ADUs so that I could understand them. It was like a riddle. And I can't imagine what a homeowner would have to do to be able to face that. So I do think that finding ways as a profession and with our allies to create just very clear glossaries and how-tos is a first step. I think that we also just have to be mindful of bureaucracy and like how much are we willing to loosen up. I mean, I think that sometimes it's hard for us to look at other states or cities that are doing this because there is so much freedom and we have anxiety about that, right? We don't want a lot of self-performed housing stock in New York City. That makes us nervous.
It's bad for architects.
It's bad for architects, but I think when we showed, there's plenty of work to go around. I mean, I think a lot of us who are used to waiting for the RFP to do the 100-unit building can now think about what does it mean to work with a different set of clients on 5 to 8 to 60-unit buildings. Like, that's a totally new thing for us. And I think there's a lot of interesting work there. That doesn't quite answer the question. You guys might be able to expand on that.
I don't know. I have something to say, but I'll let you go if you want to go. Okay. So I don't know if it might have been in the Architect's newspaper. There was something recently about Canada making this catalog of homes that could be done. It's kind of like the Sears, pre-built homes, but pre-designed things. I think that would be a big help for ADUs, is to have some sort of, and it's a lot like what you were talking about, just
library. I mean, let's
it.
see what comes out of that library, and then how do we implement it? That's the big question I'm curious about.
So just to be clear, the city has brought on a consultant to generate a set of pre-approved ADU designs or pre-approvable ADU designs that, and also open the door to prefabricated detached ADUs. I have some questions. I have skepticism about how many cookie cutter detached ADU situations are going to work in New York City's small lots.
I think none is from what we could tell with the,
But there may be other frequent, we have building types in New York City. We have rows of houses that are built as cookie cutters. The solution for one building is probably going to work for that whole row of houses. There are other ways to maybe do this at another scale that we can look into.
Yeah, that's exactly where, well, first my mind was going to the place that architects don't love to hear, but it's like, cut the design out and just give you the.
We need design.
We need design, but just to have those like off the shelf kind of products, right, as options. But on the side of like implementation and understanding when you do need design and what can be feasible in design to meet these requirements, something that we do, when a project does decide, all right, we're pursuing passive house, we are barely in schematics. Where do we start? We have design guidelines that give you ranges that say, windows from a U value of 0.14 to maybe 0.20, and give this kind of package of what would be, so instead of a passive house design guideline that says, well, generally these ranges of values work, it's and we do this for, let's say, projects that are pursuing 30% better than ASHRAE because they get higher incentives or subsidies for that. We have a table of, this is code, this is 15% better, this is 30% better, and if the city had those resources and you didn't have to hire a consultant and know that you're already trying to pursue these things and it was just out there, I think that's the hill that I die on at all of these conferences, is like open our resources, share with each other, create documents that are legible to a homeowner, that are legible to a resident that could speak up and say, hey, I want this in my building, and make it accessible, digestible, understandable, and replicable, with the notion that, a professional has to take it home, right, and has to implement it and balance it, right? It's trade-offs. It's still a process, but it gives you a starting point to understand, well, what is 15% better in my, wall, windows, roof, et cetera.
That's great. I think maybe now do we have microphones for the, good, questions from the audience? Thank you.
Hi. You talked about conflict between codes and, how you implement one without the other. And with this push for higher insulated buildings, we've also gone into the insulations that meet these requirements are highly toxic. So what we're finding is, while we're trying to meet one goal, we're sort of, they're very toxic to manufacture, they're very toxic for the people who install them, and God forbid there's a fire, it's very toxic for the firemen as well. So that's one thing. And then the first seminar here had something about, we were focusing on operational carbon, but embodied carbon increased as a result. And metal is one of the highest elements of embodied carbon. And with ERVs up and down the building versus a filter, the amount of metal that goes up and down a 250 apartment building versus, changing filters, conversations we could have in making these determinations, I think.
I just want to say thank you for that question, because we were talking just before the presentation of should we mention embodied carbon? They already just had a session on it, and that is a perfect example of when there are these conflicts of decisions, right? The amount of R value you can get for a less toxic product versus a more toxic product, those are all considerations that impact that design and impact, to the very inches of the wall, how you're going to meet that requirement. I don't have an answer to it. I just very much agree that it is a conflict, and that I think it's something that's being recognized at least more and more. And again, I go back to that hill that I die on, and that's to create more open resources of 15% better walls need to achieve this R value. This is the best way to do it from the lowest embodied carbon, right? Those resources should marry all of those concepts together.
I think you're right. And, I think many of us familiar with, enterprise green communities checklist or LEED checklist. And sometimes you're looking at materials as a totally isolated, sort of section of criteria that you're trying to meet. And you're not necessarily thinking about it for some of the bigger decisions around building systems, structure, other things. So, it sounds to me like finding a way to allow us to see those relationships is really important. And embodied carbon, I'm excited. I didn't mention it because I want to see incentives, really built into the city to support preservation, to really help us think about adaptive reuse, and for there to possibly have financial support to make these projects even more durable. That could also help with some of our lower density projects if we're, building into and upon the fabric and, town center or transit-oriented, development neighborhoods. Maybe we're not tearing everything down to get there, but you need incentive to do that. And it's not just goodwill, unfortunately.
I will also add that, I share your concern. And I often wonder, would it be better? And so the buildings that I work on, there's a lot of steel, a lot of brick, a lot of concrete, a lot of materials that are very intensive with embodied carbon. I often wonder, would I make a bigger impact on the environment if I just stayed in bed and didn't go to work?
Your greatest contribution, John.
That's a tough morning. I've had those mornings too.
I don't know. Maybe it's the architect's conundrum. I don't know.
You're staying cradle to cradle in that way.
Maybe, yeah.
It's been a long year, yeah.
But I think that this awareness that it sounds like we all share, it does make me question what I'm doing today. And many of our projects at our passive house have used VRF as their form of heating and cooling. And I have really reconsidered that as the right way to do a passive house building, because it is miles of copper piping, a lot of refrigerant that has a great deal of global warming potential. So we're looking at improving that by using PTHPs or less systems that have less refrigerant. So I think this healthy skepticism that I think we all have about what we're doing now is a good thing. So that's the only way that I can see to answer your question and your concern, is that just be willing to reconsider what you've done in the past, and is there a better way to do it? I don't say that centralized ERVs is the ideal solution for every building. If you've got a 2 or 3 story building, maybe individual ERVs is the right way to go, because it's less ductwork and the maintenance isn't as intense. So I don't know, healthy skepticism is maybe my answer to that.
If I could just add one more thought, it's actually a combination of your question and your ending question about like how do codes get in the way of or help each other. And to the point of embodied carbon, I've been sitting on the IECC development of a lot of proposals that are trying to add embodied carbon to our energy code. It's a very interesting world of interested parties and non-interested parties, and and this, like, just we can't even get past the conversation of, does this belong in this code? or do you point to another code, and then how do you start to understand, where you're layering references to different codes and requirements the same way. This is how I'm thinking about it, future looking, the same way that HPD in their latest design guidelines that they put out, they have, requirements, recommendation, or reach and recommendations. Like, let's just start to think about this. It's not required yet, but let's think about it and let's point to where the reference is so you can start to read about it. And it's not law yet, but there it is, and it's there for you. And maybe eventually it'll get added to the design guideline, or it'll keep pointing to that other standard that is. So in an ideal world, the next phase of energy code or zoning code could point to the IGCC green code and say, by the way, we recommend meeting the embodied carbon appendix of this in achieving that 15% reduction. And then maybe at some point it becomes law and it's not just a reference point. Sure.
Yeah. Okay, good. Hi, I'm Josh. I'm an architect. Thank you so much for being here and sharing your ideas. Super inspiring. I think this question of how we incentivize carbon performance, and in particular embodied carbon performance, is one of the central questions in this current zeitgeist. I think the disincentives, for example, Local Law 97, find that these are important to help create maybe like the onus do the project, right? But they don't necessarily help with execution. They don't necessarily help make the project pencil out. And I think we have had for a long time some great incentive programs around operational carbon. We need those, and we need to expand that 100%. But in terms of how we incentivize embodied carbon, I think there needs to be a little bit more innovation. And the city of Yes, with the expansion of FAR to incentivize carbon performance, I think is phenomenal. The challenge with incentives, I believe, is always, where does the money come from, right? Like, you're competing for, those dollars could go to something else. They could go in any way, in any direction. But using FAR all's thoughts on, what is the current thinking around this? Is there energy or are there conversations around increased FAR to basically help carbon performance in the law?
I can take a swing at that as the former regulator. And I think that I just want to start with, I think you raise a good point that I just want to build on a little bit, which is that there are all these different codes and regulations, and it's really important to understand what the function of each is intended to be. Is it a minimum standard? Is it a permissive standard that allows a range, that's intended to allow a range of different things to happen? Is it intended to put a thumb on the scale and encourage a particular set of practices? And don't confuse one for the other, which is often what happens, right? There's often I'm a fan of the use of zoning for good and for sound purposes, but when you use incentive zoning in a particular way, you can unintentionally create an alternative set of standards, right? Like what the energy code requirements are, they're creating a second process for you to do a second round of energy modeling on your building if you want to utilize that, which is not what they're really intended to do. They're intended to encourage a better practice, better performance, but not to make you do 2 cycles of work. I think there's also a limit on what you can give floor area for, and maybe City of Yes has really sort of emptied its pockets in terms of, the 5% deduction for amenity space, the 5% deduction for the ultra low energy building. At a certain point, something has to count as floor area. But I think that the other element that's missing here that's non-regulatory is funding, financing, financial resources behind these things. And I think that that's often underappreciated. An incentive only works, as you pointed out, if you can make it work. Floor area helps if there's value to that floor area. On an affordable project, there may or may not be. Expanding the project may go beyond the sort of financial capacity, the lending capacity of the program that you're working in.
One of the things that we're finding with the very lucrative deductions in the zoning resolution for what doesn't count as floor area anymore is that we are now height limited. And we're maybe not using all of our floor area because what counts as floor area is a lot less. So your gross building is bigger. So sorry to interrupt your flow there.
No, but that's crazy. Again, I think that the zoning's supposed to be designed for a maximum envelope, right, which has intentions in height often. So I think that there's still that slippage that we've been talking about.
So I think, it's about how can public policy, private investment, finance, and, public support of those look at each of those things. Minimum standards, flexible general regulations, maybe incentives that favor best practices, ideally by referencing clear standards for those best practices that can be modified over time as practices evolve. And then looking at what makes buildings work financially. I think a topic that we're not going to dig into today, but it's a big important topic that we're digging into at CHPC is the costs inflicted by codes on a kind of accidental or unintentional basis, and the cumulative effect of that on the cost of housing in New York. We're beginning to advocate around this idea of why don't we make explicitly a goal of public policy reducing the cost of construction.
Amen.
Make that a target as much as right there alongside public safety, not to sort of compromise public safety, but unless you make it explicitly a goal, what you see is this constant spiraling upward of incidental costs from all these different conflicting codes and regulations.
Yeah. And there are unintended consequences. No one's trying to just collect admin fees and strange consultant requirements, right?
Right. And I appreciate the question because it just made me sit here and think, well, what is a tangible incentive for specific to material? Just that one example of embodied carbon, is it that you get a tax break if, or the material itself costs less because there are tax breaks? You don't have to pay congestion surcharges for transporting that material to your site. There's so many different ways that we could think about interesting dollars to throw at certain things. And I agree that should be the next, just what you said, Howard, is that how do we get the cost barrier out of it and the administrative barrier out of it and truly create carrots instead of the sticks?
Great. I think we have time for one brief question. The final one.
Hi, yes, thank you. I just want to amplify a point that this woman here had made about doing the best that one can to make sure that the materials used are safe in the moment and in the future. Because not just when there is a fire, it can be hazardous to the fire to the people who respond. It also can be hazardous to the air in the community. It also can disseminate all sorts of peculiar things far and wide. And including when there is a disaster, managing the disaster material when there are unknown contaminants or unknown weirdnesses in it makes it even harder. So I know that there's all sorts of complications and cost and efficiencies, but I would just like for people to please take that into consideration as well. Thank you.
Kind of unrelated to that, this move to electrification, I think, has a real immediate benefits. Well, not immediate, but when these buildings start to come online, we're no longer going to be burning fossil fuels on site. There's no longer going to be those byproducts of combustion on site with these new buildings. So when I was on my community board and trying to advocate for carbon neutrality, that's one of the things I was trying to tell my fellow community board members. They were focused on how ugly the solar panels were going to be. And it just missing the real bigger picture. This is going to benefit communities because you're not going to be having all this on-site fossil fuel use. So your question maybe wasn't exactly that, or your point wasn't exactly that, but I think there are a lot of things that are going to come out of this that are really going to be beneficial to communities.
Well, I want to thank all our panelists today, and thank you all for coming.
Thank you.
As you know, in New York, a key challenge for the design and construction industry is retrofitting existing buildings to decarbonize our communities while preserving their historic integrity. This presentation is going to explore the technical and regulatory issues and innovative solutions behind the interfit targeted retrofit of NYU's landmarked Rubin Hall, demonstrating how historic buildings can be transformed into energy-efficient, high-performing spaces. So we're going to have 3 speakers today, and they're going to speak, and then no moderation for this session. They'll sit here, and then so please think of a bunch of questions to pepper them after they speak. So first speaker will be Jenna Rimkus, who's my colleague. I didn't introduce myself. My name is Michael Busing. I'm at FX Collaborative. I'm a principal, and I'm also on the Building Science Committee. My colleague, Jenna Rimkus, who is an associate at FX and specializes in large-scale projects with complex integrated systems. Her work spans multifamily residential, educational, and urban projects, including for NYU and Columbia University, where she combines artistic vision with technical precision to create meaningful, impactful architecture. We also have Tim Hanna, who's an assistant vice president of mechanical engineering at WSP, specializing in healthcare infrastructure and historic renovations. His leadership and technical expertise are reflected in landmark projects such as the Yale Schwartzman Center renovation and the Trinity Church Master Plan and the Highline Maintenance Building. And we also have Aris Tsiopoulos, who's an engineer specializing in building envelopes with experience spanning new construction and historic reservations from design through construction. And he's led passive house projects and actively advances building performance through research, simulation, and industry presentations. So I'm going to turn it over now to Jenna to get started.
Thank you for having us. We are here to talk about Rubin Hall, one of my favorite projects. Happy to have Aris and Tim here. We worked together closely throughout the entire project. Tim heading up the MEP team and Aris on all things envelope. And of course, we were part of a much bigger team, including Stephen Winter Associates, who we'll reference a few times, given this is an interfit project. And then Tishman was the general contractor for the construction portion of the project. And then they had a bunch of consultants, subcontractors, not all of them listed here, but interestingly, all of these were part of the envelope, were involved in the envelope and the air tightness of the building. So this is eligible for an AIA point here. Course description, which I'm sure you all read previously. So we're going to talk through the mechanical systems, the envelope, all within the context of landmarks and EnerFit. So Rubin Hall is one of 200 buildings that NYU owns and operates. NYU covers 15 million square feet in New York City and is responsible for hosting tens of thousands of students and employees. So they take their impact on the environment seriously and their sort of impact on people who use their spaces. So they have a robust climate action plan, which includes meeting a reduced greenhouse gases by 30% in 5 years. They have an ongoing additional reduction due for this year, 2025, and then an ultimate goal to be carbon neutral by 2040. So part of figuring out, how they meet their goals here is to do a feasibility study on their building. So they enlisted FXC with SGH and Stephen Winter's help to look at 3 of their dorm buildings from post-war and pre-war era that really represented most of their building stock. And the goal was to see if those projects could meet Passive House criteria, which I'll talk about a little bit later. And they found they could. So the next step is to implement that feasibility study in a real project. So NYU Rubin Hall is just up the street on 5th Avenue and East 10th Street. You can walk by after this if you want to see it. It was constructed in the late 20s as a hotel. NYU bought it in the late 60s. They painted it, they replaced the windows, and they opened it as a dorm. It's a really big building. It's 155,000 square feet. There's 650 students and 260 rooms. And it's in the Greenwich Village Historic District. And similar to much of the building stock in New York City, it's steel construction, concrete, and cinder fill slabs. And then the exterior is brick on terracotta and sometimes brick, what I just called mystery masonry, backup wall. And the way you heat this building is you blast it, as many of you I'm sure know, you blast it with steam heat, and periodically throughout the day, if you get too hot, you open the windows. And if you're cold in between those, you're just out of luck. And I know this firsthand because I live in a building like this that was built 60 years later. So as we know, there's a lot of buildings like this in New York. So the first goal of the project is add air conditioning. This is the last of NYU's dorms that did not have air conditioning. And to add air conditioning, it also means replacing the aging mechanical systems. And it means improving the building envelope. It means replacing these steel encasement windows that they had put in, NYU had put in. And then do it all in 14 months and also maintain the bed count and abide by their these goals to meet their climate action plan, like the baseline of LEED Silver certification, which was quickly bumped up to LEED Platinum. Ideally use all electric systems and ideally maintain the Passive House criteria. So a little bit about Passive House, or EnerFit in our case, because EnerFit is the retrofit version of Passive House. Passive House, if you don't know, or EnerFit outlines criteria for improving building efficiency, energy efficiency, and also comfort, the user comfort. And defines things like mechanical system efficiency, building air tightness, and the insulative value, excuse me, of the envelope. So to meet Passive House, passive house criteria through PHI International, which is the international organization, or the PHUS in the United States. There's two methods, prescriptive or performance. Performance is really hard to meet for a renovation because of the heating energy that's required due to like the inability to add a lot of extra insulation. So we went with a prescriptive method, which defines the criteria for different elements like the insulation, the glazing, and ventilation. And then the criteria that's like infamous for EnerFit is the air tightness criteria. For our project, our goal was between 0.6 and 1.0 air exchanges per hour. So here's a great photo from 1926 on the left, and from 2021 on the right, when we started the project. You can see the original double hung windows on the left and the steel casement that was replaced, and everything else looks pretty much the same. So as I mentioned, this building is in the Greenwich Village Historic District, and the construction phase was fast, so was the design phase, and our goal was to get through landmarks with just a staff level review. So we thought initially our biggest challenge would be fitting all of this new mechanical equipment on the roof, but it turned out it was finding the right window. So these windows are huge, they're 6 by 6 for the most part. Like I said, double hung, or as you can see, double hung. So we had all of this criteria that we needed to meet. We decided to revert back to the look of the double hung window. And there was also performance criteria, of course, that we needed to meet. NYU's baseline criteria, they had baseline air infiltration criteria for windows, and then Passive House, of course, had an additional criteria. There's also thinking about ADA accessibility of operating the windows, and then how do we maintain the window. NYU really wanted to be able to wash the window from the inside of the building instead of having to drop baskets periodically. So we looked at many different manufacturers and many different configurations, weighing the pros and cons of each. The one on the right, I believe it is, could be approved at a staff level with with Landmarks Preservation Committee. Then we narrowed it really down to two manufacturers that could meet our performance criteria, Wausau and Schuco. And in the end, only Schuco could provide the window that met all of the criteria we needed. One of the challenges was that, if a window is 6 by 6, half of it is 3 by 6. So there was a big challenge with being able to operate a 3 by 6 panel at a location that's accessible to everyone. So we went with a full tilt turn window, took that to Landmarks. We also provided this flow diagram, or choose your own adventure, which really only has one path to the Schuco window. So that was helpful in illustrating why we went with an overall tilt turn, which was a challenge for them. So here's the system we started with Schuco. They had already started this lower light offset. It's kind of a simulated double hung window. You can see that they have a thermal bridge and insulated frame here. And then on the right drawing, you can see we asked for a triple pane window, and working with Landmarks, we added additional trim at the top to really emphasize that double hung look of the original window. And in the profile of the proposed window in the middle, you can see we're still really close to the original wood window on the left as far as the thinness of the profiles and maintaining the most glass we could. So here's the window being manufactured. We went to the facility and ran through the different steps with them. You can see the insulation, the thermal bridge, the thermal break. I said bridge before. Thermal break, the black material. We're showing the middle photo, how you fill the corner with the location where you fill with sealant, and once it comes out the other hole, I think it was it, that means they're done. And then we also were witness to a water and air test in the factory of the first window they manufactured. So we figured out our window. How do we support it? As I said, the steel casement window was there in place when we were doing probes and walking the building. It's got a very thin profile. We actually never found through probes how that window was attached, but we did find that the jambs were hollow terracotta, and we found many different conditions at the head and sill. So we knew that we needed to figure out something that could apply to many different conditions, and also we knew we couldn't rely on this terracotta block without a lot of work to fill those cores. So we proposed this sort of secondary structural system to support the lateral load on the window, and this is in line with the furring that we were going to put for insulation anyway. We needed to comply with current building code wind load, so that's what sort of initiated having the secondary system. You can see these plates here that reached into the building opening, window opening to support the lateral load. And then it's dead loaded down onto the sill. And so here's the side-by-side of the original windows and the windows installed as they are today. And some of these windows, like this one, and this one are in operation. I forgot to mention that for students, they tilt the window in only, and then a key can unlock the window to turn it in so that NYU can clean it. So in operation, it's a pretty subtle change.
Fantastic. Thank you very much, Jenna. Wonderful. We have a window that LPC will like. That's great. And it will perform very well. What about the rest of the envelope, right? Tim has done a fantastic job to design a building system that will condition the air and heat it up. It would be a shame if we dropped the ball and we let that air escape, or we let that heat escape the building. So let's make a robust envelope. So we'll start by selecting which volume of the building we want to be within our certification volume. Think of it as a building within a building approach. Not all of your building has to be Passive House certified. And for us, if you look at the section on the left, you'll notice on the bottom left, there's a little part of the building we've kept outside the yellow highlighted volume. If you look at our floor plan, all around the cellar, we have these back-of-house spaces. They house mechanical equipment, they're back-of-house storage spaces, and they're really not important to the client to keep within the certified Passive House volume. So why bother with trying to make all of these spaces airtight? It's going to be tricky details. In fact, the one down there looks like this from the sidewalk. It's a vault underneath the New York City sidewalk. Why bother trying to air seal this? It's not important to NYU to have it within the Passive House envelope or boundary, so let's keep it outside, simplify our lives a little bit. On top of that, you will have noticed that I have a yellow highlighted volume, but also what's that pink volume up there? Well, that's a penthouse that a lucky faculty member gets to occupy on top of the building. And we've highlighted in two different colors because the client wanted this to be a phased approach. First, you'll work through everything that's yellow, then you'll get to work through everything that's pink. So we want all of this volume to be certified at the end, and EnerFit allows you to do that. You can construct and test yellow, then construct and test pink, and then combine them into one volume. Okay. We've selected which part of the building is going to be within our Passive House boundary. Now it's time to detail our air barrier. If you're building a new building, this is quite simple. One continuous line all around the perimeter of your structure, ideally on the outside. But of course, as you know, this is not new construction, and we can't touch the outside because it's landmarked. So we have to work from the inside only. That means that every time we meet a demising wall, every time we meet a floor slab in section, every time we meet some kind of unique existing condition, we have to jog back and accommodate it because we're not planning to demolish all of those demising walls that have been there since the building was a hotel, separating the hotel rooms between them. So every time we meet one of those unique conditions, we jog back. And on top of that, look at our note on the top right there. That's a lot of responsibility all in one note. Any kind of penetration through that air barrier, mechanical penetrations, pipes, sprinklers, electrical back boxes, all sorts of things have to be airtight in order for us to meet our qualitative air test criteria. Okay? With a rough idea of our design in mind very early on, because FXC, they are rock stars and they coordinated really well with the client, we get to go into 2 dorm rooms and test our preliminary design. And we learn invaluable lessons doing that. So you're looking at what the dorm room used to look like before we got to do things in there on the left, and then what we made it look like after we tried out our design a full year before construction kicked off. 3 invaluable lessons we took away from here. First, you saw we had hollow terracotta block from the probes that Jenna showed us. On the interior face of that hollow terracotta block, there's plaster. It's about 1 inch thick. We think it's original to the building because there's horsehair in there. Mind you, you can reinforce plaster today with fibers, all kinds of fibers. Back in the day, they used horsehair. There's a wire mesh there at the corners that was pretty corroded, looked old, and about 3-4 coats of paint on the interior face of that plaster. So when we first found out there's plaster there and that it would be kind of a pain to demo all of this material, add a lot of time to the schedule for the contractor, and again, this is a very tight timeline that NYU is asking for, we thought, what if we can use it? It's an airtight material, it's already there, let's keep it on there, let's patch it and make it airtight. Any cracks, any hollow areas don't sound good. So we sent our contractor to go do that, and they actually told us every time we found a crack, when you want to patch a crack in plaster, you want to tap, tap, tap until you find good, well-sounding plaster that is still adhered. So every time they would tap, 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 they would find out the entire wall is hollow. So down would come all of the plaster on the demising walls or the exterior enclosure, and they would then install new plaster because that's what we had sent them out to do. And that was not really efficient. That was not a sustainable thing to do in 500 different dorm rooms, right? That was not the approach we wanted to take. So lesson number 1, can't trust the plaster. Number 2, we had these air barrier transition membranes that were reinforcing weak points in our design, anywhere where there's risk for air leakage. And we'll look at details a little later to help you understand where those are. But we learned that the uncured EPDM membrane we had specified did not want to stick to the plaster very well, and all kinds of other surfaces that are existing in Rubin Hall, like the masonry surfaces, the flooring, etc. But an asphaltic membrane with even a water-based primer, because we needed low VOC materials for this project, would stick very, very well. So you get to learn what materials you can use. That way you don't have to have an awkward conversation the first few weeks that, hey, the materials you specified actually don't work here. We need a change order. And number 3, we learned that we would prefer to use a different kind of insulation than what we had used in the mock-up. So what you're looking at here is closed cell spray foam. This type of foam will do 3 things for you. It's vapor closed, so it's a vapor barrier. It's airtight, so it's an air barrier. And it's also insulation, provides thermal value. It's a thermal barrier. So it's very, very quick to use a material like this, especially for a project like Rubin Hall, where you need all of these 3 barriers. You get to install it and then keep running away towards the next few dorms. But the kind of failure that you're seeing here is very important. It's okay for us to lose a little bit of thermal value, let's say, where the foam is separating from the substrate there or there. And what has happened here is the foam shrunk as it was curing, and it pulled away from the surfaces that it was adhering to originally. So as it cured, it shrunk a little bit and pulled away. It's okay if you have a little bit of thermal bridging. Your insulation is not continuous. But if you're also relying on this to be your air barrier and vapor barrier, in the wintertime, warm, moist air is now able to get around it and touch cold masonry. And that's a bad recipe for condensation. You don't want that happening. 3 very valuable lessons that we get to learn very early on and iterate on our design because we facilitated early mock-ups. Unbelievably important. So I'll jump right away into what the dorm room looked like before we insulated. I told you that we wanted to use the plaster and we couldn't. What you're looking at is sheathing boards. So exterior sheathing you would normally see on the outside on a lightweight structure with cold formed framing and sheathing, now installed on the inside, fastened through the plaster into that hollow terracotta, and white strips of membrane, our air barrier transition membrane, covering all the joints, all the fastener heads, and any kind of transition or change in substrate where we're going from the sheathing to the ceiling, the existing ceiling, turning 90-degree corners, etc. So that's our asphaltic membrane that we saw earlier. We now have given ourselves a nice, robust, well-fastened substrate to install insulation against. Okay, here's the details I promised you. You're looking at a section on the left. There's that air barrier transition membrane going from the wall to the ceiling and from the wall to the floor and jogging back, a plan detail at our demising walls. So here's a door that used to connect to luxury hotel rooms. We're also jogging back to the interior plaster there. The eagle-eyed among you will have noticed that I gave away, we ended up using open cell spray foam. 4 5/8, give or take, depending on where we were. And an interior, on the interior side of that open cell spray foam, a variable permeance vapor retarder. So that's what we chose to use, but how did we get there? When you're insulating on the interior of an existing mass masonry wall, you want to be careful because that wall has been used to seeing heat wash on the inside during winter. You've been keeping it above freezing temperatures, and it has been able to dry towards the inside. So if you now take both of those options of drying towards the inside and getting warmed from interior heat in the winter, you create a condition where the brick can be wet and cross into freezing temperature. And that activates a deterioration mechanism called freeze-thaw. High water content, brick freezes, the water expands, and it causes it to spall. So we wanted to make sure we would not be activating a mechanism like that when installing interior insulation, air barrier, vapor barrier at Rubin Hall. So what we did was take brick samples from Rubin Hall, actual brick that was there, at some of the areas like Jenna was mentioning where we had mystery masonry, not the interior hollow terracotta block, but oops, all of a sudden 3 withes of brick. And where the interior withes of brick looked to be salmon brick. That's a term, slang term, used to describe brick that is lighter in color and softer, often used on interior withes because it's expensive to spend heat firing it up to high temperatures. So if you spend less heat, you can potentially use it on the inside. That brick's been fine for hundreds of years, but now we're insulating. So let's check it's still gonna be okay. That's what we did. We did a hygrothermal analysis, a woofy one-dimensional model. Hygrothermal means you're modeling both heat, so temperature. That's the graph you're seeing on top. Red is temperature, and water. So you're seeing relative humidity in green and absolute water content of materials in blue. This graph is basically a section through the existing Rubin Hall wall. So you're seeing an exterior brick withe, middle withe, interior withe, plaster, and the paint on the inside. We modeled these 4 cases, and we determined that yes, we would be activating freezing temperatures with basically any kind of insulation installed on the interior face of the brick, but with an open cell spray foam and a variable permeance vapor retarder, the water content that's in the brick during those freezing events is low enough to where we feel comfortable doing it. So we ended up with open cell spray foam. Detailing it is, again, the same lesson we learned with the air barrier. Every time you meet a unique condition, demising walls, floor slabs, other existing things that you will not have found, no matter how many probes you do, then you have to detail around them. On top of that, most of the exterior wall here, or a decent amount of the exterior wall here, is not going to be able to be insulated because of what we're describing. So 15% of our wall is floor slabs, and those we can't insulate in front of because the building is landmarked and they interrupt us on the inside. A lot of the building is window, even though it's an old structure, it actually has a decent amount of daylight openings. And then a lot of it is also those columns happening between windows. So those are the demising walls. You will have noticed that we wrap our insulation back on those columns in the plan detail I showed you, but it's still a thermal bridging effect there. This is what the envelope looked like before we insulated. So I'm hoping this shows up well enough so that you can discern between green and yellow, but even if you can only see red, you will see that these are the steam risers Jenna was talking about earlier, lighting up like Christmas trees. You see the floor slabs telegraphing through, dumping heat out into the cold winter. And a little bit of the demising walls there, a yellow spot and a yellow spot there. So significant thermal bridging effects, really large temperature gradients through this envelope. Some spots are really, really hot, dumping heat outside. A reminder, this is what we've prepared for ourselves. Nice, continuous, well-fastened sheathing into the terracotta block, all airtight with our air barrier transition membrane. And this is what it looks like when we spray our open cell spray foam on it. Hopefully, everything is well protected to where you just pull the plastic off and your window looks amazing. Same thing with adjacent conditions there, demising walls, and the other side. An important point I want to make here is that we were able to afford 3 inches of space between our interior face of plaster, so the interior most plane of the wall, and where we placed our studs. So what you'll see in this very useful graphic there and there is that we actually have continuous insulation, a layer of 3 inches of continuous insulation against the wall, of course interrupted where it meets the rough opening and demising walls, etc. But that way we get to diminish the thermal bridging effect of the studs. They're not spanning through the full depth of our insulation. A myriad of other things that you can see in this very useful graphic is the brackets that reach into the rough opening, like Jenna was describing. Of course, the continuous insulation we talked about, the variable permeance vapor retarder over there, and mechanical systems that came in later. And speaking of mechanical systems, Tim, take it away.
All right, so just a kind of a quick touch back on Jenna's earlier slides. NYU's goals for this project from an MEP perspective were to provide air conditioning to their last unair conditioned dorm in their portfolio, and to pursue an all-electric building. So looking at that, whenever I look at providing new mechanical systems for a historic building, the first thing I really want to look at is the existing conditions, because they're not changing. Unlike new construction, when you're dealing with existing conditions, especially in a historic building, where you have even more limitations due to landmarks, what you see is what you get. And in this case, it's not a lot from my perspective, because I'm looking at places where I can put big boxes. Introducing air conditioning means I now need to provide outdoor equipment to do heat rejection. You can see here, there's actually a very tiny chiller plant on this setback roof that just served a small portion of the second floor. So if you look at the size of that, I need significantly more equipment to provide air conditioning for the entire building. So limitation-wise, we kind of had to avoid these lower setback roof areas here. These were patios and terraces for those penthouse apartments. Very nice. And then we had to avoid around the perimeter of the high roof because of visual setbacks and avoiding issues with landmarks. So that kind of really pushed us into the middle of the top roof in the penthouse and in these areas here. So we know the space we have to work with on the outside is fairly limited, but it's doable. Moving inside, we want to look at how we're going to do our distribution. Because this is a historic building, it was designed as a hotel, the deck heights aren't very tall. We're keeping the interior partitions, so really all of our vertical movement has to happen in these existing red blocks. If we're going to move air up and down the building, we don't have large central shafts, so we're not going to be looking at an all-air overhead system, both because of the deck height and because of the limited vertical transition. So we're now looking at a fairly distributed system where all of our vertical transitions are happening either at roof level or basement level, and then we're doing short runouts on the floors. And so that really helps to kind of define what sort of system we're looking at on the inside of the building. So we took a look at some 4 fairly basic systems that met the requirements for air conditioning equipment on the roof and local distribution on the floors. Right now, we're really just kind of dealing with cooling. We'll touch on ventilation a little bit later. So our 4 basic systems are a cooling tower boiler system, very run-of-the-mill for residential buildings, especially in New York. You get a nice compact footprint outside with the cooling tower. The existing boilers in the basement would fill the same kind of space requirements that you would need for hot water heating in a future system. So it's something we're fairly confident can work. The downside is it's a fossil fuel fired system. It's not going to get us any benefits for energy efficiency. It's not going to get us any benefits for LEED. And it's not going to meet the design requirements for an all-electric building. So the next 3 options, 1, 2, and 3, are our all-electric options. We're looking at a VRF system And then 2 options using air source heat pumps on the roof, and then water-cooled chillers or water-cooled heat pumps in the rooms, local water-cooled units, and fan coil units. All of these meet the all-electric requirements. They will generally, so if we have the all-electric requirements met, we're looking at the footprints of the roof. That's really now our big critical thing. Because we have a tight area to fit on the roof, we need to make sure it fits, which is the next step. So the cooling tower, again, fits fairly well. It's nice and compact, fits in that nice little corner. The risks here are that it's a tall piece of equipment, which means we might run afoul of landmarks, in addition to all the other drawbacks. With the VRF system, we have a much larger roof impact. So we're looking at basically 15 VRF air-cooled condensing banks. So we have like 11 here, 2 more over here, and we wind up having to stick 2 of them in a roof setback on the 2nd floor. And it's both because we've run out of space on the penthouse roof, and because VRF systems have they have decent length limitations for the piping runs. But this building is tall enough that by the time we got down to the 1st and 2nd floor, we were really at the very high-end limit for what a VRF system can do for piping distribution. So VRF system, and the final 2 options are the air source heat pumps. Both options 2 and 3 will effectively have the same outdoor equipment volumes because the heat we're moving out of the building, the heat we're pulling into the building is the same in all of our options. So the outdoor equipment is always going to look about the same capacity-wise. And again, you can see we can fit most of our equipment on this smaller roof setback, which is good. We still need a 3rd bank to kind of sit somewhere else that we need to find a home for. This one was on a terrace. Not great, but potentially usable, especially given our constraints. So now that we know that all the options fit and we don't get to eliminate anything, we can look at secondary characteristics to find out what works best for all the other project requirements. So this is aesthetics, this is energy, this is end use in the building, this is other fun things that we'll get into in another slide. But aesthetics-wise, cooling tower is good, but doesn't meet some of the design requirements for an all-electric building. It also has a tall tower, and you can kind of see it's not very pretty. I don't think anyone's gonna love, miss not having cooling towers in the building. I've never seen a cooling tower, and I'm like, dang, that's a nice looking cooling tower. So the next options are a VRF system, again, multiple condensing units on the roof, a lot of piping distribution. Option 2 and 3, air source heat pumps. But again, like all of this works aesthetically. Options 1, 2, the baseline option 2 and 3 would also require additional space in the building for pumping distribution. The nice part about the VRF system is all of your major equipment goes on the roof, and then you just have to worry about the distribution of the floors. So if you have a lot of limitations for interior space programming, a VRF can potentially be a good option. Looking at energy and other situations, again, the cooling tower system, minimal potential for incentives. It's kind of a business as usual. It has the cheapest first cost, but that's really all it has going for it. The VRF condensers have the cheapest first cost of any of the electric systems. They have pretty good efficiency and pretty good carbon reductions. The downside is that you still need to find another system that'll do your domestic hot water, which could be an issue if you're looking for space. And the kind of incentives are good, but not great. And the lifespan is on the shorter side. You'll probably be looking to replace this equipment in about 15 years. On top of that, NYU had installed some VRF systems in another, I think it was a dorm project. And they reported some facilities issues with operations and maintenance. The biggest one was if there's a leak in a VRF system, it's really hard to track down. And if you've got this piping running for 15 stories in a building, it can be really hard to track down a leak that's in a shaft. Additionally, again, for each and every one of these banks, you'll have at least 2 pipes, maybe 3. So even though the VRF line sets are pretty compact, you're talking about an inch maximum, you'll have 2 line sets per bank. So you're talking about 15 banks, 30 lines. You can really quickly run into like a 2-foot, 3-foot bank of piping that you now have to find a route through the building for. So that kind of pushed us to these last 2 options, options 3 and 4. These were both pretty similar from an outdoor perspective. Indoors or a carbon perspective, they were both very good for reducing carbon emissions. The big differentiators on these 2 systems were the initial first cost of the water source heat pumps inside versus the fan coil units. Water source heat pumps are a bit more complicated. They have a compressor in them. They're a bit louder, and they require more maintenance. Those 3 things were kind of concerns for NYU. It's difficult to get access to student rooms to do maintenance on equipment. They're also, again, a little bit noisier, so it's harder to mitigate that noise in a student space. If you're looking at, say, a residential building or condos, this system might actually be a good option because it pushes more of the equipment space onto the tenants or the condo owners, and it provides a little bit more controllability on an individual unit by unit basis with a 2-pipe distribution system. So it definitely has its applications, but for our purposes, it wasn't the best choice. Really what we wound up with is the air source heat pump with fan coil units. I should actually mention, one of the weird things we found out was even though these systems are nominally doing the same thing, the air source heat pump with water-cooled AC units had the highest annual energy cost of any of the options we looked at. And we think that was largely because of all the distributed compressors in the building. That like slight inefficiency increase from a smaller compressor drove up the cost of energy usage. So it's just kind of a weird circumstance that we didn't expect to come out, but was kind of interesting to see later. So anyway, we wound up with this 4th option as kind of our preferred choice. And so taking that, we started doing a whole lot of iterative roof planning. Again, you can kind of see how tight this roof got with all the equipment we had to fit in. And once we started looking at all the distribution, we actually wound up doing a lot of iterative load studies for this to try to figure out the highest quantity of air-cooled or air source heat pump units we could physically fit on this roof and what that looked like with respect to SGH's envelope. And we actually had to kind of do an iterative envelope design approach to make sure that the envelope was good enough that we could fit the equipment, which is a little bit backwards and kind of fun. And it's kind of one of those weird things you wind up doing in a historic building because I can't just ask for more roof space. It's there. So the other thing we had, and I said we'd talk about it later, is we have these ERVs for ventilation distribution. We've got 4 of them. Each of them are hitting one of the old exhaust towers. So where we had just in a single masonry exhaust shaft, we're now running down ventilation and exhaust air shafts into that same footprint. We were also able to squeeze in an emergency generator in the old fire pump tank room. And we'll talk about that a little bit later. But that was a late addition that actually provided us a little bit of extra benefit to the project. Looking at a building level, we have our system distribution. We are really running a completely separated HVAC system. So our ventilation system is completely separated from our heating and AC. The nice part about that is one isn't necessarily dependent on the other, and they could live in different spaces, and so it minimizes the amount of distribution space we need for the heating and cooling to something that's a lot more efficient space-wise to move energy around water. The other fun thing you can see is, so our air source heat pumps, we were able to use one of those large shafts that had been existing to drive a direct route all the way down the building. So we were able to separate out our systems into an exterior glycol loop that we needed to maintain the water in our air source heat pumps for the winter to keep it from freezing, and separate that to a clear water building distribution loop. So we could separate those 2 systems out, which gave us a lot of abilities, well, it basically kept us from running glycol to the building. Glycol's gross, don't do it. And finally, we have water source heat pumps doing our domestic hot water. And that also ties into our HVAC hydronic loop. So water source heat pumps pull heat out of our HVAC hydronic water and use that to heat domestic hot water. So this gives us all of our mechanical and plumbing systems, all electric, no fossil fuels on site, except for the emergency generator, which we'll talk about really quick. So I talked about the major cooling systems, which are kind of the big step. The next part is the ventilation. Ventilation really is kind of the rule of thumb now. You have to provide it. With recent revisions to the New York City Mechanical Code, you're no longer allowed to use operable windows as your ventilation source if you're providing mechanical cooling. And from an energy perspective, I'm entirely all for it. From a job security perspective, I'm also all for it, but that's beside the point. From an energy perspective, the worst thing you can do for building energy use is give us a tight building with low infiltration and then tell the users that if they want air, they have to crack the window. Like, that erases all those benefits. But if you have a nice high efficiency ventilation and exhaust system, you can balance your ventilation intake and exhaust so that you can keep your building pretty close to neutral, which our envelope consultants love. And you can make sure that you're recovering the energy from that exhaust air so that you're minimizing that waste use. If you have conditioned air, if you have to get rid of it, you can at least take the energy out of it. And so these energy recovery units were great for that. It's also a requirement in Passive House and LEED. So if you want to pursue them, you got to do it. But finally, it actually helped us add a layer of resiliency to the project. When we were working on the design, NYU came to us and requested we put in an emergency generator. A lot of this was kind of driven from their experiences with power outages during Hurricane Sandy, where they had long periods of time with dorms without power. And they wanted to make sure that if this dorm lost power, it would still be occupiable. It didn't have to be perfectly comfortable, but it needed to be occupiable. And the tricky part was we didn't have a lot of space. Again, we kind of had to shoehorn this emergency generator into a fairly small box, which heavily limited the amount of available power we had for extraneous loads like mechanical systems. Compressors are notoriously power hungry. So we weren't going to be able to put all of our air source heat pumps on this itty bitty emergency generator. But what we could do was put the ERVs and their associated VRF units on emergency power. And what that let us do is provide tempered air year-round, regardless of the status of the building's power. If we're on emergency power, we could still provide 70-degree air in any given condition. And so if we did a quick study, we could see here, this blue line is the building temperature without any mechanical conditioning. I will say, like, this peak here is a little scary. This study kind of assumes no operable windows. Windows aren't open because it was a first order study and we were really concerned with the winter conditions. So in reality, you probably would have temperatures significantly lower in summer. Should be fair. But the red line here is building temperature with just tempered ventilation air. So supplying 70-degree air in event of a power outage. In the winter, we went from a negative or a 55-degree interior temperature to a 65-degree interior temperature with about 20 CFM per room, which was really, really, really nice because it meant we didn't have to put 400 tons of chiller on emergency power, and we could still say to NYU that if power was out for a week, this building would still be habitable. Like, it's not going to be the most comfortable place, but there's a big difference inside between 65 degrees and 55 degrees. And that, again, added a bit of resiliency and added a bit of like depth to what we could offer the client. So now we can talk about carbon limits. With our building system, cue the HVAC. With our building system, all electric air source heat pumps, we are able to tell NYU that they can avoid carbon penalties under Local Law 97 through 2034, which is really pretty significant. You'll also see that while we are looking to incur some penalties based on the current systems, these 2035 step downs are somewhat contingent on greening the grid. And so how far this step down occurs, like how much additional or how much reduction is required, is going to be somewhat adjusted based on how green the grid gets by 2035. So we can say confidently the building won't have any carbon penalties by 2034. We're pretty sure NYU will be able to avoid penalties from this building through these 2035 step down as well. And finally, some basic metrics. With our all-electric system, we were able to get 16 energy points, partially from the all-electric system, and partially thanks to the excellent envelope. I cannot stress enough, the best way to reduce energy in a building is a good envelope. I can't put it in, but boy howdy, if you give me a good envelope, we can cut energy costs a lot. Additionally, we have about 45% reduction in carbon saving or operational carbon, and a 56% reduction in the EUI. These are based on Con Ed benchmarks. We are again avoiding Local Law 97 fines through 2034. And we were able to earn the project some pretty significant incentives from both NYSERDA and Con Ed to help offset the initial upfront cost for this slightly more expensive system. So all in all, I think it was pretty successful. And it's kind of pretty. I like it.
So a little bit about the construction phase, and I'll go quick here because I think we're wrapping up. But the one of the key components during the construction phase and the key members from the contractors team was a building envelope construction manager. This is a role that's defined through a spec section that SGH provided for us. And this is a person that's responsible for all things airtightness and around the perimeter. So we're showing a couple diagrams in our team. The team member's name was Bob. So Bob put together these diagrams for his subcontractors. And the one on the left is really illustrating all of the different members from their team, the different contractors that were involved in the building envelope. And then on the right, we would have these coordination meetings and talk about the sequencing of installing all of these different elements. So Bob was really good at pulling all the team together and keeping everyone in line. And he also was responsible for setting up the testing that was required through SGH's spec. We needed to test the first window and then a window at 25%, 30%, 75%. The construction sequence was to renovate from the top down. So the very first window that was installed was on the 13th floor. So that meant that the spray rack was hung from the floor above. You can see the chamber was built on the inside, and that not only encapsulated the window itself, because we wanted to test the window after it was brought to the site and make sure it was still as performing in the way it did when it was constructed, but also it captured some of the adjacent material or the seal around the window so that we could test the construction of that and the quality of that. And another significant test, of course, is the air barrier test, because we need to meet that 1.0 air exchange at the end of the project. So we were able to do a full building blower door test before construction even started. This took 12 fans in 4 different openings in the building to be able to get to a level where we could test the air tightness. And we found that the building was at a 6.0 air exchange per hour. So we essentially needed to make it 6 times better. And during that test, we were inside the building running around looking for areas that were leaking. You could do that by feeling air moving, or we had a little smoke device and you could see the smoke trailing off. if there was an issue. There's a significant portion on the first floor that wasn't going to get renovated because it's the existing lobby, for example, or classroom spaces. So we were also checking those areas to add extra scope to the documents if we needed. Then during construction, the first test was a chamber test of a dorm room. After the window was in and the air barrier that Aris was showing was in, they installed plastic sheeting, as you can see, a couple feet away from the envelope, put a fan in it, blew air in, drew air out, and tested that difference. And when it failed, they filled it full of smoke, so we could see where that smoke was getting out. We also went outside the building to look obliquely at the window, and we found that there were areas where there wasn't sealant installed, or there were fish mouths that were picked up in field reports, but it really took this test for the contractor to see that they needed a little more QC. No one's here, right? The other test was once all the finishes were in, the first major dorm that was completed, that included tile, lights were installed, outlets were installed. They put a barrier at the doorway and tested a full dorm room. And in this case, they brought all of the different contractors in to witness it. They were stuck in here for a couple hours while we performed the test. The first one failed, so we filled it full of smoke and went outside to see and around in adjacent rooms. This is actually an adjacent room. So this is how much smoke is traveling from this room to the next room. And we went oblique to the window, and you can kind of see some of the smoke coming out above the window. And then, so we were standing, that window being tested was this one. So it's two rooms over and one floor down. And we actually found that there was smoke coming out right in the jamb of the window in front of us. So it was really traveling through that porous, those demising walls, and along that mystery masonry back up wall to up through to the exterior envelope, really illustrating the importance of the bubbles of each dorm room that Aris was talking about. And so then it was time for the final blower door test. This test only took 4 windows and 2 doors, so you can tell we've already made it a lot more airtight. I forgot to mention Stephen Winters was the group that performed these tests, and this was the biggest building that they had tested. So here's a scene of the day. We're set up in the lobby, and as the contractor is trying to close out the building, they had to stop what they were doing. This is an all-day test. It ended up being a 2-day test, and they were there as well, witnessing the test. So we found things like there was some sealant not installed, which we're running around the entire building, and we were able to find like a few items that they needed to pick up, wrote them a list, came back the next day, they had repaired it all, and we were able to meet our 1 air exchange per hour and stay on track for ENERFIT certification. So here's the photo similar to the one we saw before construction. You can see a very even tone throughout. We don't get that Christmas tree anymore, but you can see a little bit of the slab edge here, but more or less very smooth. So here's the building as it stands today, looking very similar, a very good example of New York fabric building, representing much of New York City, but performing at a very high level. Tim and I's favorite view here of equipment. Well, I guess mine. Here's is the actual equipment. Here's the inside. The example of a hallway cleaned up, tried to improve the vertical nature of a very low floor to floor. The dorm rooms look very similar, but students can study. It's very quiet and is very comfortable. The student space on the second floor this used to be a dorm. It used to be a hotel floor. It's a very low floor to floor. We moved their main space along Fifth Avenue so students can look out onto Fifth Avenue and stay connected with what's going on outside. And then in the lobby space, the historic lobby, we maintained and actually added some additional wood paneling and then a very simple intervention for the desk and security. So,
Key takeaways. We spoke about mock-ups and how invaluable the lessons we learned were. Do them early and get you someone who can communicate their importance to the project.
and then the single point person for the building envelope was really key to making sure that the contractor stayed on track for the air tightness criteria that we needed to meet.
And team coordination. This building doesn't work without very close coordination.
You guys are both my favorite, you know.
Right. But yeah, there's a lot of very tight spaces, there's a lot of very finicky, and a lot of very iterative processes, and without a good collaborative good coordination, the process is much less pleasant, and possibly just doesn't work. The buildings are already tight enough without trying to do it all alone.
All right, thank you.
Thank you, Jonathan and Harris. That was very detailed and informative. Does anyone have any questions for our speakers? I see a question here. Pass the mic.
Thank you for the great case study. I think this is like all the strategies that we would want to pursue when it comes to a retrofit renovation project. I'm curious how you arrived at the EnerFit as a goal. Was it like a conversation that you started with the client early on as like a goal that they should have, or did they come with that preset goal to achieve EnerFit passive house standards? That's my first question. And then I have a few more. When it came to window selection, obviously having European windows manufacturers have that really high performance standards is kind of hard to achieve in the North American market. So did you have other conversations with other window manufacturers around North America which could achieve that kind of high performance targets? And did you come across any challenges trying to find any? And the last question is related to the insulation material that you chose. Given the toxic emissions and impacts that are associated with spray foam insulation, did you consider mineral wool as an alternative? And given how thick your wall would have already become with like the sheathing and the insulation and the chunky window, like was mineral wool like a good alternative, or did you think it would have made it thicker?
I'll take the first two. I think so I think I couldn't hear you completely, but EnerFit was they were what I was calling EnerFit curious throughout the project design phase. They were pretty sure they wanted to meet it, but we needed to look at all the options, and if there was a point where we thought that it didn't make sense to comply with the EnerFit criteria, we would bring it up. But it really never was, because we always needed to insulate, we always needed to replace all the units. And so it just made sense to take it a little bit further to meet EnerFit. Hope that answered that question. What was the second one? Windows. Windows, yes. So yeah, we wanted to use a window manufacturer that was in the United States. So NYU, if there's an issue with a window, could quickly, they would have somebody that they could reach out to and quickly get it replaced. We didn't look, to be honest, I wasn't in that initial study of the windows, but or one of my colleagues was really focused on that. But we really found that Schuko and Wausau were the two that really could meet the energy efficiency criteria. And so that's where we focused and went through different iterations with them.
Yeah, and if I were to, can you guys hear me okay through this? Yeah. If I were to unpack that a little more, we could have explored using different materials for windows, right? This is an aluminum window, which in our case we want because we want something robust that can take the abuse it will see in a high-rise student dorm. We could have gone with something that had better thermal performance, but will last a little less, so shorter lifespan. Like think PVC windows or that kind. So really the only one who could meet that and not get shipped from Europe, which is not very passive house, shipping windows across the ocean, was Schuko at the end of the day. So we ended up with a window that required a little bit of modification to meet the profile that we needed, but was kind of already there for us, only a small iteration. And yeah, Lizzie, Jenna's colleague, did a fantastic job. Probably learned more about windows than she would ever want to. Insulation-wise, so I am far from an expert when it comes to foam off-gassing, and I haven't studied it. To my understanding, it is mostly related to the blowing agents that are used to install the foam. So the foams that we were looking at here all had water-based blowing agents, which is a more environmentally friendly approach to spray foaming. But yes, mineral wool was definitely an option, and it would have performed similar to an open cell spray foam insulation approach. We would have still had a variable permeance vapor retarder on the inside of a vapor open insulation like the mineral wool, but it would have taken significantly longer to install, and it would have been a more expensive option. So it was easier, all things considered, to go with the open cell spray foam. It was faster, it was more efficient. I will say there's a product now available, of mineral wool product, that comes with the variable permeance vapor retarder that we used integrated on the board. So it kind of accelerates that process. You only have to tape the joints between boards and perimeter conditions. So it's become easier and faster to use mineral wool in this kind of application here. And yes, it was something we considered, but ended up going with open cell instead.
My question, I guess, is for the mechanical engineer. I'm curious, and it seems like earlier in the last panel we were talking about conflicts between agencies, and I thought there's a conflict between LPC and all the equipment you have to stick on a roof, which I deal with a lot. Did you think about the roof? Meaning, when you stick all that stuff, how are you going to replace that roof in the future? And then the other question I have is just in general for all of you guys, for architects that are looking to sort of beef up their knowledge of just building envelope science, not necessarily passive house in particular, but just some resources they might go to sort of speed up their education on that.
Yeah, so there is definitely a conflict. There's a tension between the push for all electric buildings and the local law 97 restrictions, which also apply to landmark buildings, and restrictions on what you can put on the roof. Like that there is a tension. There will likely have to be some sort of compromise, just because you can't if you're going to be introducing air conditioning, you have to have heat rejection on the outside of a building. So it's either you significantly modify the facade with louvers and have that equipment inside, or you put it on a roof. So there is a tension there. It's something that's going to have to be resolved, but it's also something you kind of have to address on a case-by-case basis because a lot of these buildings are fairly unique. The solution for Rubin isn't going to work for a solution where you have a building with like a peaked roof. I can't put a cooling tower and air source heat pump on a slope. So it's going to have to be applied, but it's definitely something that the mechanical engineers of the city are cognizant of, and it has been kind of brought up as a potential pinch point. As far as considering re-roofing, Jenna's colleague Lizzie will attest, we definitely considered that. What you can't see from those very nice screens is that all those units are actually mounted about 3 feet off of the roof deck so that there's clearance not only to put a membrane underneath, but to actually get a person to move the membrane because, again, these things have a fairly significant footprint, so we got to make sure that we're providing enough space for a physical laborer to get in there, apply a new membrane, and then water seal it. So that was definitely something we were considering.
If you don't mind, building science education, shameless plug. SGH does monthly seminars. Not all of them are going to be on building science. Sometimes we cover other topics, but we would be delighted to see you there.
I have a question about electrification. So this building, existing building, is with no air conditioning, no ventilation, steam systems, full brand new electric system on it. Could you talk just, I think, about how much increase in electrical service you have to go for, and how was there any sort of challenges when it came to sizing all of that, spatial response as well? And part two was about surface water heating. We keep hearing that surface water heating, especially heat pumps, and with such high usage, can be challenging about sort of getting the temperature of the water correct, and lack of heat sources, or maybe have a lot of storage. So you can talk about that a little bit.
Yeah. Let's see. It was electrification. Okay. Yeah. So the electric service did get bigger. We had a fairly significant review with Con Ed. I believe there was also like a service, they had to do a service line increase to the building, which was contingent on upgrading the service in the street. So like the timing of that got a little bit stressful given our tight construction deadline. But yeah, so we did have to increase the service. We wound up having to provide a new electrical room, both for logistics, to provide a new electrical service while we had the existing one up, avoided temp power. So logistically for the contractor, it worked out well. But yeah, the service size had to increase. The building distribution got more significant. The loads in the building get bigger because you're moving all of that energy that was being done by fossil fuel burning onto the electrical service. So that's something that we're also going to have to deal with both on a building basis, but also as a city and Con Ed basis, because the electrical service is getting bigger. And it's not just to the point where we're increasing to match, like winter loads are matching summer loads. Winter loads are actually looking to get higher than summer loads. So resiliency of the electrical grid and making it more robust, increasing its capacity is something that has to be done on a citywide level if we're going to fully electrify all of these buildings. Again, something to consider for a wider perspective, and not necessarily on a building by building basis, but for example, like if you're going to have to deal with rolling blackouts in the winter, it helps if you have some resiliency in the building and can maintain temperature. And that's the envelope and the ability to maintain at least some portion of the heating system on emergency power. As far as the surface water heating, on the mechanical side, yeah, current technologies for heat pumps for the mechanical aspect, really for New York City's design conditions can only provide about 120 degree water effectively. You can do 140 up to, I think now about 0, but the COP gets really bad. So there's a couple of options you can look at for dealing with that. One is to provide supplemental heating for your HVAC water. So once you start getting below the about 12 degree ambient, you can have an electric heater that kicks in to help boost your hot water temperature. Or what we did was we just designed the system around 120 degree water. So the buildings are designed for the lower temperature. The coils are all larger to handle the lower hot water temperature. So it's worked out pretty well. Actually, right after we finished the project, we had a run of about 8 degree overnight temperatures at Rubin, which was 4 degrees closer below our design conditions. I was very concerned. But the reports from the dorm were that everyone was comfortable, warm. It maintained its temperature largely because of the improved envelope. On the domestic hot water side, again, it's about tying into the system. As long as you're sizing your heat production equipment for the right capacity, the domestic hot water, we had to provide a significant amount of storage, but that storage, I know a lot of the domestic hot water systems recommend like a small electric boost heater, just in case. I'm not opposed to it. It just kind of depends. But yeah, if you have that little boost heater, it helps with the resiliency and it can help reduce your storage volume.
have time for like a couple more and right before the next session.
Thank you. I love the way you all presented that, starting with the ethos and then every component and then the construction as well. I was just wondering a little bit more about the ventilation. The reason I asked, I recently moved out of a dorm in Edinburgh, in Scotland, that was passive house, and you have very small ensuite and then a very small bedroom. The moisture builds up super quickly, and when you would open the door, everything in your room would also have condensation on it. And it had an always-on ventilation system, but it was low velocity, so you kind of had to open the windows to get the moisture out quick enough for the room to be comfortable. So I was just wondering, given the small spaces, what your strategy was on getting the moisture out quickly after showering.
That's a great question. It was a two-phase approach. One was we had all of our exhaust coming directly from the bathrooms and the en-suites, so we were always pulling that air out. The vapor barriers were generally around the entire suite, but the door ceilings for all of these doors were fairly tight. So moisture wasn't migrating out into the rest of the room. It kind of stayed in the bathroom and was pulled out that way. And the second one was, and this is the reason why we have tempered air instead of just an energy recovery ventilator that does passive tempering. We're cooling the air down to 55 degrees in the summer to wring out the moisture and then reheating it to 70 with the ERV and the VRF system. And that allows us to provide neutral temperature, dehumidified air into the dorms so that when we're introducing this air, we have that extra moisture capacitance to help absorb that moisture from the showers to help reduce the total moisture in the building.
Thank you.
You said the project would avoid local on 97 pipes until 2035. The ones, did you look at what would it take to get to 2050 and what's the cost of that? And that, and also thinking about the life, what's the lifetime of the systems? Should you at least get to the plans for that period of 20 years?
So I don't think we directly looked at what would be required for 2035 past, partially because, like I said, those reduction targets are largely contingent on greening the grid. I don't think there's any technology available today that you could put into a building that would meet those requirements without some very significant detrimental impacts to the rest of the project. As far as lifespan, all of this equipment that we put in, the fan coil units have a lifespan of about 15 years, maybe less given college kids will run them hard and put them away wet. But for the major equipment, so the heat pumps, the heat exchangers, the pumps themselves, they all have a lifespan of somewhere in the ballpark of 20 years. So by the time we hit 2035, we're not quite at the switch over point, but we're getting pretty close.
Hi, I was wondering if you could, I think this question is for Janet, if you could please tell us about the building envelope construction manager role. It makes perfect sense, but I've never heard of that. Yes.
Yeah, I'll take it. You can add it because it was a. Oh no, it was okay. It was a spec section that SGH wrote that we included. So it defined his role and his responsibilities, which included a daily tally of the work that was completed, as well as those coordination meetings, overseeing the coordinated details at the window, for example. That included all of the trades, so we could review it in total. Yeah, Tishman was sort of skirting around the person a little bit as well, but we we decided it was Bob.
Yeah, really you want one singular point of contact that has all of the context of what is happening in the envelope. You don't want the air barrier submittal reviewed by Bob and the thermal barrier submittal reviewed by Alex, because the two of them might never talk. So you have one person both reviewing everything, being aware of everything, but also delegating the tasks to their subcontractors and then keeping them in check, because we're not, even though we all had CA scope, we're not there to review all 500 dorm rooms, right? You want to be on top of those people. And really the best way to do that is to concentrate all of the responsibility in one person. That way, when we do show up, we only have to talk to one person to find out what's going on.
Thank you. Just as a quick follow-up, is that person typically working for the GC or for the design team?
GC, we want them on site, yeah.
That can also be an undergrad too, couldn't it?
Absolutely. When you have the GC being that person, though, you have the power over the subcontractors directly. That's, they're in direct contractual agreement. If you have that can definitely be the owner doing it, but they're not going to be on top of the trades as much as your GC will. There we go. Okay. I would love to meet them.
Thank you very much, Jenna.
All right, welcome back from that super short break. My name is Cheryl Saldana. I am a member of the AIA New York Building Science Committee. I work at Simpson Gumpertz and Hager. I'm a senior project manager there. I also lead our building science and passive house practice for the company. And then relevant to our session today, Energy Codes in Motion, I have had the privilege of serving on the New York City Energy Code Technical Advisory Committee for the last 3 code cycles. And it's been a very rewarding process. If anyone wants to talk more about it after, I'm happy to share my experience on that. And today I'm joined by 3 awesome thought leaders in this space as well, who are doing a lot contributing to sort of the policy landscape in New York City and New York State. So first, Gina Bokra, she's a vice president at WSP with 3 decades of experience advancing sustainability and high performance building design. She's a former leader at New York City Department of Buildings, where she helped shape and enforce the city's landmark climate and energy laws, including Local Law 97, which has the aim of driving resilient and low carbon building innovation. Next, we have Louis Cole, Director of Sustainable Design at Hendel Architects, where he leads initiatives to advance the firm's mission of industry leadership in sustainable, high performance, and passive house design. Louis is a registered architect and certified passive house designer, and he's worked on some pretty notable passive house projects around the city. And he and actually know each other through New York Passive House Community, as well as on the New York City Energy Code Advisory Committee. And then finally, Danielle Manley from Urban Green Council. She's the Associate Director of Policy, where she leads advocacy and analysis work related to building decarbonization through major policy initiatives such as Local Law 97, 154, benchmarking, Energy Code, and the CLCPA, Climate Targets for Buildings. Danielle, how do you fit all this in? And with her background in climate research and policy, she brings a deep expertise in turning climate goals into actionable policy strategies. So here we are. We're going to have this panel on energy codes in motion. We all know our energy codes are consistently evolving. We have a new set of energy codes that are coming into effect. New York State has announced, December, they're going to have a new one coming in. New York City's will come early next year. And really, we all have to balance this idea of improving energy efficiency and carbon reduction with affordability and cost, right? That's sort of our challenge. So today in this session, we're gonna dive into sort of this tangled web of codes, of local laws, some of the voluntary programs even that are out there, and try to unpack how policymakers, industry leaders, and practitioners, like many of us in this room, have to grapple with these things. And we're going to touch, or our conversation is going to kind of show how we're shifting from this focus on operational energy
and trying to broaden the conversation to incorporate goals like, decarbonization and resilience. So our learning objectives, which are up on the screen here, we want to understand the evolving landscape of energy code and policy development in New York City and New York State, including local laws. We're going to analyze the challenges of implementing energy regulations in both new and existing buildings, evaluate the impact of emerging priorities such as electrification, embodied carbon, and energy storage, and explore opportunities for collaboration among policymakers, designers, owners, utility companies to advance energy policy moving forward. So I just have this outline to kind of keep track of the conversation. So we'll start with a bit of an opening context. We'll talk about energy codes, local laws, a little bit on zoning, and then think about kind of where are we going next with our policy and legislation. We'll wrap it up with some closing thoughts, and then we'll open up to the audience for Q&A. So we'll have a sort of moderated conversation, some questions that I've prepared, and then open it up to the audience. So getting us started, I'm going to start with Danielle and invite you to maybe do some stage setting for us, giving us some context into where we currently stand with New York State and city policy.
Sure, thank you. Okay, everyone can hear me, just want to make sure. I'm Danielle, I'm the Associate Director for Policy at Urban Green Council. We're a nonprofit based here in New York City. Our mission is to decarbonize buildings for healthy and resilient communities. We focus on buildings because buildings matter a lot for the climate conversation. In New York State, buildings are responsible for just over a third of all statewide carbon emissions. And in New York City, burning fossil fuels on site to provide heat and hot water is responsible for 40%, nearly 40% of citywide carbon emissions. And then the electricity and district steam used by buildings is about another 30%. So buildings altogether and here in New York City are responsible for more than 2/3 of all carbon emissions. And so to meet city and state and global targets for climate change, buildings are central to that. And so in New York City, a lot of really exciting things are happening. In New York State, a lot of exciting things are happening. We're a leader in this space. And so, Cheryl, you mentioned energy codes, where I think a lot of people in this audience are familiar with them, but New York State just passed and is about to enact a new state energy code that's going to be 18% more efficient than the previous code. It's going to drive electrification, and it's going to drive efficient electrification by trying to make sure that we limit things like electric resistance heating in new buildings. New York City's energy code, which required by law is supposed to go into effect right after the state enacts a new code, is in the process right now, as I think everyone on this stage knows, of creating what those standards will be, and they have to be even more stringent than the state targets. So there's a lot of work going into that right now. And then, so those are two big things that are happening governing decarbonizing new buildings. And new buildings in some ways, and when we're talking about policy, are easier and also less expensive to electrify. If we're trying to get out of the hole of fossil fuels in our buildings, the best way to get out of a hole is to stop digging. So if we build our new buildings all electric, we're partway there. The other things focused around new buildings that are exciting and happening is New York City has its own all-electric new construction law that went into effect in 2024. I know we're going to get more into that later, so I won't unpack that at all right now. And of course, we have these laws governing big buildings here in New York City. We have Local Law 97 is the one everybody knows about, setting carbon limits on buildings over 25,000 square feet. Those limits go down over time through the year 2050. We also have these other laws that preceded Local Law 97 and in some ways helped to give us all the information that we needed to get there, which are benchmarking requirements, tracking and reporting energy and water use every year. We have auditing and retro-commissioning requirements. And then even further, when we go back in history, there was also clean heat requirements, which phased out fuel oil 6 and now 4 from existing buildings. So those are some of the codes are one driver, but these laws are another. And finally, the last thing I'll cover is the state has enacted what is an acronym, the CLCPA, the Climate Leadership and Community Protection Act. setting mandates for our state to decarbonize the economy 85% by the year 2050. And since buildings are a big part of that, they'll also be a big focus of that conversation. There's few mandates on buildings coming out of that right now. There was none specifically set out in that law, but there were recommendations that came for how do we get there. So efficient energy codes and all electric new construction were two of them. But in many ways, New York City kind of set the standard for where the state needs to go. And so many of these other things are still yet to happen at the state, like benchmarking, building performance standards, and other steps. So those things are on the horizon and very active talking points right now. And so there's really a lot that's happening in our space that affect our building stock. And I think I'll leave it there because I think we'll get into some of the weeds in a bit.
Yeah, definitely. I'm wondering if you can also touch on, we talk about trying to align multiple objectives, right? There's energy, there's carbon, electrification, but we're trying to grapple with affordability at the same time. And so can you elaborate maybe a little bit more on these and what policymakers are doing to try and keep them from competing?
Yeah, so I think you said it before, we're at a transition point where we're focusing beyond just energy efficiency in buildings and energy codes, and even the energy code itself at the state level is going beyond just efficiency by requiring all electric new construction in it. But we're focused on how buildings emit carbon. There are talks about sorry, I have a couple of notes that I'm referring to here, so please excuse me. Embodied carbon was the other one. I didn't want to forget to mention that too, because that's something that we are, is very much at I think the next forefront of the policy landscape here. So these competing timelines are one thing that are challenging to navigate, and just, I think, especially on the city side, trying to figure out how to make all these different timelines work, these different reporting requirements for buildings between benchmarking and Local Law 97. As Gina knows well, there are many requirements on big buildings right now. So that could be challenging, is navigating these different requirements when they happen. A second challenge on the timeline perspective is, when we think about Local Law 97, there are these hard targets that maybe don't, for some buildings they do align, but for some buildings they may be out of sync with the building's capital cycle, for example. So if you have a hard target you have to meet in 2030, but you updated your gas system in your building back in 2020, the timeline for making those new investments to upgrade your building might not be quite in sync with the targets. So that is something that is challenging. That leads into the affordability conversation, but on the affordability side, there's also a different challenge depending on the types of buildings. So I'm kind of lumping affordability and technical support needs together, because for the big fancy commercial office buildings that have really sophisticated teams that have building energy management systems, they are quite capable of navigating some of these requirements. It's when you get into multifamily buildings, maybe you have people who live in co-ops together that make decisions together, that make those decisions just more complicated to navigate, and they need more technical support of what contractor do I need for what work, when should I do it, what equipment should it be, how do I know it's gonna work? And so they just need a little bit more hand-holding, and while that's a challenge, it's also an active point of conversation with people who are kind of in the leading space of what's next for Local Law 97 right now and how to navigate those. So I think those are the timelines, the technical support and affordability are I think front of mind for most people right now.
Yeah, absolutely. Okay, so let's stay with energy codes for a moment and think about operational energy before we broaden to all these other local laws. Louis, I'm going to start with you, and then Gina, I want you to chime in as well. Your thoughts on kind of thinking about energy codes. What should their kind of primary purpose be? Should it be to just ensure, minimum baselines are met, or should we be, stretching to, performance beyond?
Great, thank you. Are we okay? Yes, I'm Louis Cal, as Cheryl introduced me. I'm in addition to being at Handel Architects, I'm also the co-chair of the policy committee at New York Passive House. Very involved in that organization, and pretty active in AIA Coach and a couple of the subcommittees there, decarbonization and policy. So just a shout out to those groups. I'd encourage anyone that's interested in these topics. Those are great spaces to be in, to learn more, and to contribute your expertise. But with regards to energy codes, I think Danielle mentioned that the new energy code that's coming out is 18% better at the state level. So it is a significant jump. We're jumping from model code, model 90.1 for the performance path, 2016 up to 2022, which is a big jump. And so I think we're going to see quite an increase in energy efficiency and stringency, which is going to be challenging for all of us to meet. And I think that does bring about the questions of affordability. How much can we do with the energy code? In my role at New York Passive House with our policy committee, a big part of what we've been striving to do is get the energy code as close to on par with Passive House as we can. Partially just because we find that Passive House is really rooted in building science, and that there's just some really sound science behind that certification, and it makes a lot of sense for that stuff to be required in an energy code as kind of a baseline for what buildings should be. And through the process of being on the technical advisory committee, we got a little inside look at the New York City code, and I am pleasantly surprised to see a lot of the things that we talk about in Passive House are included in that code. Some of it was already included in the past codes, but definitely getting more stringent. And I think things like blower door testing and energy recovery ventilation, are expanding to a wider range of buildings in terms of what's being required there. And then, of course, U values for fenestration and walls, and things like restrictions on electric resistance heating, are all kind of getting packed in here. There's a lot of things that are happening in the code that I think are going to be really encouraging and are driving us towards Passive House. One thing that we talked a lot about trying to incorporate into that code is a Passive House alternative compliance pathway, which is something that we've seen in Massachusetts and is working there to a certain degree of effectiveness. I think some people would say it's more effective than others, or more feasible than others. But I think that does bring up an interesting question of how much can we do in the code? Is the code the place to be kind of advocating for these third-party certifications, or should our goal just be to try to elevate the baseline level of performance as high as we can through these individual measures and not start to incorporate third-party certifications? I think that's an open question that I'm still debating myself. And Gina, with your experience, I'd love to hear you talk a bit more about that and other thoughts on the energy code.
Thank you. I'm Gina Bokra with WSP. We're a global engineering and professional services firm. And as Cheryl mentioned, I've been there only for about a year after leaving the city where I was for the previous 12 years prior to that, and went through 3 code cycles and updates. So spent a lot of time in my career thinking about what was appropriate to do in an energy code and what was not. And thinking about those challenges of, how far do we push what tends to be a minimum standard to close those gaps between voluntary programs and the baseline that we set. And so I think about going back to when energy codes first came into effect following the energy crisis on the heels of that in the 1980s. And towards the end of that decade, we got our first energy codes in the United States. They were really influenced by what had happened in the auto industry and trying to improve fuel efficiency in cars. And we said, okay, we still have that same problem in our buildings and we can do better. So we started to see minimum standards happening. And I think about 20 years ago, 18 years ago in my career as an architect, just practicing architecture and designing buildings and working with engineers, and felt like we could do a lot better, and was surrounded by people who also said, we can really do a lot better. And we started to say, this is not the level that we should be seeing in a minimum standard when we know we can go so much better. And so I ended up going to Department of Buildings because I knew we could improve the code, and worked with a lot of professionals across the city. As Cheryl said, it is a very rigorous process that New York City goes through to bring in professionals from outside of city government to help develop and advance the codes. And there's always this balance of trying to figure out how much farther can you push something forward without beginning to run up against affordability issues that cause trouble in the industry. And so that's always the challenge. But now we're getting to this challenge with the energy code of maybe what we talked about as diminishing returns. Some of it is just laws of physics. and there's still that affordability issue. But I think one of the really big changes that I have seen happen over the course of the last 15 years was that when I started doing that work on the code, it was a minimum standard, and everybody talked in terms of energy cost savings. And it really seemed like that was all it was about, was, over the course of the first 2 decades of the energy code, we spent a lot of time doing fuel switching, setting some standards for, envelope performance, and, making our buildings perform a bit better. But within the last decade, we've seen this switch over away from just looking at cost savings to health and safety impact long term. So I think that's really exciting, and that's how we've seen the policy transition happening over the last 6 or 7 years, that we've begin to see things like Local Law 97, a much more embracing of the energy code, and these gaps between what's mandatory and what's achievable under a voluntary standard closing quite a bit. And so I do know from the last 2 code cycles before this one, the department absolutely was looking at what was going on in those other standards that have informed the energy code. And I think we have to remind everybody that the percentage of savings increase at the state level is compared to the national baseline and not to the New York City code, which the 2020 code was really pretty stringent. And I am really excited to see how many owners across the city and architecture firms, engineering firms are still embracing this idea that we can continue to advance and move forward in the right direction. But I think that is a big change, that energy codes are now seen as life safety codes, whereas 20 years ago they were not.
Thank you, guys. Okay, so let's broaden the conversation now from energy codes and start to talk about local laws, because we can't help ourselves here. I want to start with Local Law 154. So Danielle, maybe you can help us understand a little bit about the differences between the sort of electrification law in New York State versus New York City. And then, is this an effective piece of legislation? Is it working? And then Louis, I want you to chime in a little bit about, in your experience as a practitioner, how's it going so far? How are you seeing it getting implemented?
Yeah, so Local Law 154 for New York City is our all-electric new construction law. So it governs new buildings, and it sets an air emissions standard on buildings. So it's not an equipment standard per se, it's the emissions that can be emitted by any piece of equipment in the building, and in effect, fossil fuel equipment can't meet those standards. It went into effect in 2024, and it's phased in by building height. So small buildings up to 7 stories started in 2024, and then in mid-2027, all buildings and hot water uses will go into effect July of 2027 for New York City. And so that is the city's code. And there are exceptions for certain uses, including some commercial kitchens and laundromats and other uses where, very specific cases where it didn't or doesn't make sense right now. The state law passed a couple of years after the city's law, so I think there's this trend of New York City is really setting the goalposts, and the state is trying to meet them. But that was passed as part of a legislative bill in 2023, is actually part of the state budget bill. That happens in policy all the time. Tons of things are tucked in the budget. But it passed as part of a budget bill for the state in 2023 and required that the energy code implement what is in effect an all-electric new construction law. So it prohibits fossil fuel equipment and building systems, which it defines in the law, but it defines the equipment that can go into buildings, and it says it needs to be implemented through the energy code. So for the past few years, we've all kind of been waiting for what is this going to look like, and these back and forth processes in developing the next energy code for the state, and incorporating all these efficiency requirements along with it to make sure that energy bills stay down, I know, in the energy savings portion of this. But there are differences. There's like a very minor height requirement difference that is I always get backwards, but one of them is up to 7 stories and one of them is over 7 stories, so it's technically 7 and 8. There's the most minute of differences between them. But similarly has some exceptions for certain cases. And again, that gets to the point where for this particular type of legislation, it's affecting new buildings and making sure, if we are going to really meet our state targets, we can't be building more buildings with fossil fuels. And so it starts there. So I'll leave it there and turn it to you.
Yeah, so how's it going electrifying buildings? I think most of our work is new construction, primarily multifamily. We do stuff in the affordable sector and stuff in market rate. And I would say how's it going is very much dependent upon which sector you're looking at. And I would say that the law is, at least local law 154 here, the electrification law in New York City, is definitely a driver, but it's kind of an indirect driver through other things. I think on the affordable side of things, the real driver, we've seen electrification adoption be much more broad on the affordable side of things, and people are much more open to it. I think for many reasons, one of them being that HPD has done a great job of incorporating electrification into their guidelines, both as elements of electrification required side of things and as kind of reach goals within their really, really well-constructed guidelines. So I think the agency guideline is a really important tool beyond energy codes that can be used to kind of encourage these kinds of goals. So that's an important thing to keep in mind. And on the market rate side, we've had a harder time with adoption. People are not as willing to jump to electrifying their buildings before it's being mandated as we might like. A huge part of that is domestic hot water. Electrification of heating and cooling is the norm. People are not going back from that. But hot water is a challenge, particularly in market rate high-rise residential buildings, which is a lot of what we do, just because of space. It takes a lot of space to install this equipment. We've talked about roof space several times here in conversations today, that it requires a lot of roof space to incorporate all these air source heat pumps up there to efficiently electrify your domestic hot water. There's technologies like geothermal and wastewater heat recovery that we are seeing coming into play in a small number of cases, and those are technologies that I think will do a fantastic job of helping to solve this space problem, but they come at a cost. Geothermal obviously has scheduling impacts. Wastewater heat recovery has a cost and some space impacts inside the building. So, I think there's, a few kind of, from a design perspective, a few challenges, space being one of them. Another one that I think is challenging on the market rate side in particular, at least is interesting, is kind of the market demands. For example, so we've encountered, so we have a completed project at the University of Toronto, Scarborough. It's a dormitory. It's all electric building. It's electrified hot water, laundry, everything, all electric. And it uses wastewater heat recovery. And because it uses wastewater heat recovery in a centralized location for the shower water, the building has set limiters on the temperature of the shower water so that you can't turn your shower all the way down to ice cold. So you can't get back from the gym and take an ice cold shower because they want the water temperature that's going into the wastewater heat recovery system to remain at a certain temperature. So you can still take a lukewarm shower, but you can't take an ice cold shower. You'd think that wouldn't be something that a lot of people would have issues with, but apparently it's like one of the biggest complaints at the dorm is that I can't take an ice cold shower. So come home long night of drinking, you want to take an ice cold shower, wake yourself up a bit. So that's an interesting, and we're actually hearing that concern reflected by owners in some places when we talk about wastewater heat recovery, that they don't want their tenants who are potentially paying very high rents to not be able to take a cold shower, which again seems like an odd thing to be concerned about, but it is something that we're hearing. Same thing with like heat pump dryers, right? Taking gas out of dryers. Heat pump dryers, while they do a great job of making your clothes nice and soft and fluffy, they do take a longer time, and that's something that people. So there's small kind of market constraints within that as well, within electrification. And then the last one is just there's this kind of break from expectation where people hear electrification and they hear about utility bills or electricity costs going up, and they think, oh, I keep hearing that our grid is dirty. Why am I electrifying my buildings? There's this kind of cognitive dissonance that happens when we try to say electrify your building with a 20-year outlook. The grid will get cleaner. Trust the government. It's a hard thing to do in these days here, but it's and utility companies. So there is this kind of cognitive dissonance that I think happens there that also makes it a little challenging. But we are seeing people, and there are other mechanisms that I think we'll get into a little bit more that can help kind of push towards it.
Can I add one thing real quick onto your last point on the state of our electricity grid and heat pumps? So I assume most people in this audience are at least familiar with the word or the term, but they are an incredibly efficient technology to heat and cool buildings. And they are so efficient, they're 3 times more efficient than a natural gas furnace, and even more so than a boiler, that even with the makeup of today's grid in New York City, we have less carbon coming from buildings that are using heat pumps, even with today's what some would call a dirty grid, but however you want to phrase it, with a fossil fuel intensive grid, heat pumps still save carbon. So there is this I think, I don't know if the cognitive dissonance you were getting at is like, that's a hard concept to explain to people. Like, we want you to electrify, but we have a intensive grid, but heat pumps are actually still better regardless. So I also just want anyone to leave here today thinking like, oh, well, we absolutely should increase renewables on our grid, but even with what we have now are pretty good.
Yeah, I definitely don't mean to say that that's not what we want to do. I merely mean it's just one more conversation that we have to have in an array of conversations to get people to the point where they're saying, yes, let me spend more money to electrify my hot water in my building.
And don't take away ice cold showers from Canadians.
Yes.
So coming back to the rooftop space conundrum, let's talk about Local Law 9294. The Sustainable Roofing Law. I know its aim is to promote renewables. Gina, I want to hear from you a little bit on that one and kind of again how it's going. And then also let's talk about Local 997 as well. It's just beginning to take effect. Are these local laws sort of the right strategies for long-term resilience and carbon reduction? And just share a little bit about how they're getting implemented as well. So I think, Louis, I'd like to hear a little bit more from you on that.
Thanks, Cheryl. Cheryl's always so nice. She would never say, look at all these ways that the code sets us up for all these conflicts. Conflict comes to mind with Local Law 92 and 94. I love Local Law 92 and 94. I want to start out by saying that, and then I'm going to ask everybody, nobody has any cameras. The photographer went away. No one's going to tell, right? Everybody, this stays in the room. I'm going to ask for a show of hands. If you're doing projects in New York City, how many of you are prioritizing solar systems on your roof? There's a couple of hands. How many of you are prioritizing vegetated roofs, green roof systems? Just a couple of hands. How many of you are prioritizing every way possible to get out of complying with that law? Because there's so much competing for that space on a roof. And we all know, if we step back and we look at the large context of what we need to do to get to Local Law 97, which is, I think there's a formula we all understand really well. We have to drive down loads in existing buildings. Local Law 92 and 94 wasn't about that, even though it's still kind of a little bit of a blur whether City Council really meant for it to apply at all to existing buildings. What I can tell you is, there's not a lot of new green roof, new solar construction happening as a result of Local Law 92 and 94. Maybe a bit, maybe on smaller buildings. But as we move towards all electric buildings, the need for that space on a roof is going to really transition to space for heat pumps. And so those two laws really kind of are a little bit in conflict with each other unless you get creative and you have a client that wants to really try and double duty the roof. And you could, as we heard in that last panel, we had to elevate the heat pumps so that there was enough space to work under them and install a new roof membrane. Over time, roof membranes have to be replaced, right? We all need to be thinking about those things. You could create a frame that supports your heat pumps maybe and also supports solar over the top of that, right? So there are other solutions that we can think of, but I think Local Law 9294 also was trying to hit at the energy resiliency issue partially. It is about carbon, and green roofs do also have a carbon impact, but in addition, in that formula, we have to drive down loads. We have to make buildings as efficient as possible so that we're not wasting energy anymore, because that's the challenge that we're trying to solve, is that a lot of our existing buildings unnecessarily waste a ton of energy, right? And so everybody talks about, our grid isn't going to be able to keep up. What about our grid? Well, if we stopped wasting so much energy, our grid wouldn't have to work so hard. So if we close that gap, we have an easier path forward in what is going to be a huge transition for our energy grid. And then we have to electrify everything. And then at the end of that formula, we also have to figure out ways to make it very resilient and robust so that we have distributed generation and storage. And so Local Law 97, we don't know how it's going yet. Right? I left the department right before first reports started coming in. But I can tell you that a change that we saw happen with the suite of laws that we have in New York City came with Local Law 84. And that was because Local Law 97, for the first time, made it necessary that owners really challenge what they were submitting in their Local Law 84 reporting. They had to really scrutinize it and think about, is that really the right number? Is something missing? Is something, so there actually was a recorded deduction in greenhouse gas emissions across our city since Local Law 97 passed, which we anticipated came from a number of things. It came from better data being submitted under Local Law 84. It may have come partially from COVID, because we saw the way we were using energy shifting. And some buildings, the energy went down where we didn't really increase the energy at our homes that much. But then we anticipated it also was coming from owners doing those things that we needed to see them doing in their buildings. So I think absolutely there are some owners that are responding. And in the last 2 months, we've actually gotten more inquiries from owners who have said, I submitted my local law 97 report and I'm beginning to think about 2030, which is so important right now. So we really need to be messaging to building owners that they must start planning now or yesterday. And that they should be paying attention to a decarbonization plan that maximizes those energy efficiency opportunities that they have on the table now. A lot of owners have a local law 87 report where they did their commissioning exercise and they fixed those things that they knew were wrong, but they never implemented anything from their audit report. And so many of them do have a small assemblage of some ideas of what they could enact and move forward on. But I do think that we have to be messaging with owners. Really important to start planning right now for 2030, because as we march closer to that, there's going to be strain on the workforce. You might not be able to get equipment. So you need to be doing that investigation of how am I going to get to 2050 and eliminate all of the greenhouse gas emissions from a building. And so doing decarbonization planning that is supported by U.S. Green Building Council, Urban Green, NYSERDA, and starting to make those plans is really important right now. And then really messaging to owners that, the law is a trajectory and we are not on the trajectory we need to be on right now. This first compliance phase is a warm up. And when you get to 2030, those emissions targets drop a lot and it's going to be painful. So you have to have a plan for incremental change that really is looking at your capital planning, life of equipment, and starting to do all of those things that you need to do.
Yeah, Danielle, it's what you were kind of touching on earlier with the timing sometimes of, from an owner's standpoint, their capital planning is not necessarily on par with the timeline of local law 97. So you kind of have to be planning ahead. Maybe you could touch on a little bit about, on your end, what Urban Green and others are working on this stuff.
Yeah, Gina, you talking through some of these things just now, like we've been doing some work in the past few months that we don't get to work with Gina as frequently anymore because she's not at the Department of Buildings. But we looked at the most recent benchmarking data that information is available for, so it's 2023. And you make a very good point. There's definitely differences in some of the data. Some of that comes from just better reporting, and some of that comes from improvement. So one point you said was part of it was COVID. We put out a post-pandemic analysis a couple of months ago that showed that surely part of the way through COVID, when people left or changed their habits or weren't commuting into central Manhattan anymore, energy patterns shifted and energy use dropped in some buildings. But what we also noticed was since people have started coming back, energy use has stayed down. So that's actually a really positive story. We've spent a bit of time talking as a team. We're like, well, what is this? And it really led us to believe that there really were some work in some buildings that was happening that was the cause of this, not just better data, although that I think you're right. And the second thing is we looked at 2030. So when Gina brought up 2030, just for those of you that don't know, so local law 97 carbon emissions limits are the highest that they'll be, the easiest to reach this year in 2024, and then they'll get more stringent in 2030, and then you might hear us say 2035 or 2040 or 2050. Those years are the times where the emissions limits drop again. And so we all know in this room that buildings aren't going to change that overnight when 2030 hits and all of a sudden have lower energy use and fewer carbon emissions and different equipment. They have to plan. And so from the 2023 data, about half of all covered buildings, half of all covered multifamily buildings are meeting the 2030 target. So half of those buildings have to do some work, and half of them are still going to be in compliance and have an even longer runway. It's the portion that 50% beyond their 2030 target. Some of them really can just get by with basic efficiency improvements, things that they should already be doing that are deeper energy efficiency improvements in their building and fixing steam traps and optimizing the use of their steam systems. And then we found there's about, I think it's 15 or 20%, and I forget that I'm sorry that I don't remember exactly the statistic, but about 15% of buildings are the ones where they need the most help. They need to do the most work by 2030. They're more than 20% beyond their carbon emissions limit right now compared to what their 2030 carbon emissions limit is going to be. And so when we talk about the challenge, it's like, how do we zero in on those that need help now, and how do we focus on that 15% now to help get them moving, because they will need a few years worth of work. They don't need help in 2029, they need help in 2025.
One of the things I've heard recently is sort of the workforce development that's needed with this, contractors, building operators, training. There's this concept of bulk procurement. I'm wondering if you can touch a little bit on that as well.
Sure, yeah. So this is an idea that's been percolating for a bit now, and is gaining traction in terms of focusing on these buildings that need the most help. A lot of people like to think that their building is a snowflake and is unique and has its own unique needs. But many buildings are very similar and need the same types of work. So something that we've been thinking about, and a few others in our space, is how can we work in the concept of aggregation into tackling retrofits in buildings. We know there's a lot of so many multifamily buildings that have steam systems. They're from before the energy code began. They're inefficient. They all need very similar types of work. Can we aggregate that across those buildings and have a few contractors who can say, okay, we can work together with the workforce to plan things at scale, and you also bring equipment costs down in order to make those retrofits more affordable? And can you pair that with a technical assistance program, maybe like a Accelerator 2.0 that comes in and helps you not only tell you what retrofits are good, or here's a contractor you can call, but helps you plan the work, finds the contractor for you, and then does it. And so that is something that we're working on. It's not something that's prime time right now, but knowing that 2030 is coming soon, how can we get it there quicker? That's what we're working on.
Well, we can't wait. Okay, so let's now shift to thinking about zoning and City of Yes. This really was intended to overhaul outdated zoning rules, removing barriers, and enabling more sort of climate-aligned and affordable housing solutions. So I'm curious a little bit more on opportunities that it's presented and kind of how we're seeing it rolling out.
Yeah, so maybe I could just introduce what it was, and then I'll pass it over to you to talk through some of the specifics. The City of Yes for carbon neutrality was a very aptly, it's not descriptive of what it is, but it's the zoning regulation that has passed through the city that I'm sure a lot of people are familiar with here. And the first set of, that was City of Yes for carbon neutrality, was essentially about making the things that make electrifying buildings that are inhibited by the zoning code, to remove those barriers. So the zoning code was just designed at a time that we didn't have heat pumps. We didn't need solar on our roofs. We weren't trying to incorporate battery storage. We weren't trying to do these deep efficiency improvements. And so it was taking those barriers out of the way and making it easier to site some of this equipment and do some of this work in the zoning code. There are other things outside of the zoning code, but that was a major barrier. So it's helping to increase our ability to site heat pumps both around and on buildings. We talked a lot about at that time in the competing territory for roof space. I think two big takeaways that I got from the City of Yes for zoning, carbon neutrality, was it drastically increased our ability to site battery storage around the city. So prior to that, you couldn't site battery storage in residential districts across the city. And now, at least from the zoning perspective, you can. And it wasn't standing in the way of that. And it also increased our ability to install solar panels, both on roofs, different heights that you were talking about, and also over parking lots and garages. So those were two big things that came away for me, but I'll turn it to Louis, who I know is really active and involved in the process too.
Yeah, so City of Yes, I think those two things that you mentioned there at the end are maybe two of the most impactful elements from a renewables electrification standpoint. Another one that I think, at least when it first passed, seemed very promising was the ultra-low energy building deduction, which I'm sure some of you have heard of. It's a 5% floor area bonus if you exceed energy code by 15% and electrify your building. When I was speaking about some things that are motivating owners to electrify their buildings, this is definitely one of them, much more so than Local Law 154, at least at this point. They will be compelled legally to do it at a certain point with Local Law 154, but they're doing it actively now to get this 5% floor area bonus. It has been more challenging than I think people realized, particularly for high-rise buildings and the market rate. I think and affordable, it's a lot more straightforward, but on market rate buildings, people want very high glazing percentages. There's a lot of different market constrictions that make it more challenging and more expensive to achieve that 15% better than code. And I think one issue that we'll be dealing with here with the relationship of City of Yes to the new energy code, when the new energy code is passed, is that I think that deduction is going to become very difficult, if not impossible, to achieve for multifamily buildings. So hopefully that means it opens up an opportunity for a different kind of floor area bonus or something like that. Something that came up in a conversation earlier, there was a little bit of discussion around the City of Yes in one of the talks earlier that I found interesting was the discussion of using floor area as a bonus, and have we kind of reached the limit of doing that? And I think City of Yes, there's the carbon neutrality aspect of it, but there were two other rounds of zoning updates with City of Yes, economic opportunity and housing something. So I don't remember the titles of all of them, but all of them included, or at least the housing one and the carbon neutrality included several different opportunities for increasing your floor area bonus for doing certain things, adding amenity space, increasing the percentage of affordable housing, which is all fantastic. But one of the challenges that we have actually seen in practice, and was mentioned in the earlier talk, is that we've kind of come to a point with some places where we have too much floor area. And we are running into height limits or zoning envelope constraints that there's nowhere to put that floor area, particularly as we electrify and we have so much more gross floor area that is being dedicated to mechanical systems, that is no longer able to be zoning floor area that could be used for occupancies of any type. So that's an interesting conundrum there within the City of Yes. But ultimately I think the City of Yes was very productive in taking down a lot of the zoning hurdles to doing things like batteries and in PV, and I think that'll be one of the biggest legacies of it, and also increasing the ability to locate affordable housing in different areas of the city. And then the final one is rezoning areas to make office to residential conversions a lot more straightforward and kind of within as of right zoning, which I think is a huge thing for certain parts of the city. So I think it's going to have some significant benefits, both from solving our housing issue as well as addressing electrification and carbon neutrality.
Okay, so we've covered a lot of ground, right? We've talked about energy codes, our local laws, now zoning a little bit. I think in some respects, it may feel like Gina kind of touched on this, that we're hitting this point of diminishing returns with the sort of existing legislation we have, and we need to start thinking about, okay, what should the next frontier be? It was already brought up, embodied carbon is one of those, and I think that's kind of the one that I'm hearing about a lot these days. So curious thoughts on sort of what future regulations might look like to take on this challenge. And should we be continuing with sort of the enforcement view? I know there's this talk of carrots versus sticks. So should we go with the enforcement in the sticks? Should we be focusing more on incentives out there? Louis, I know you've done a lot with COAT, the Committee on the Environment. Maybe you could give us a little summary of what's going on there with embodied carbon.
Yes, I can't take much credit for the actual output, but I can give a little update on some of the things that are happening there. The AIA Code Policy Committee and to some extent the Decarbonization Committee as well, along with partners like the Carbon Leadership Forum, have been, and with the state AIA, they've been doing a really tremendous job of advocating for embodied carbon policies at the state level. And actually this past year, 2025, they managed to get 3 different proposals to actually get a bill number assigned to them in the state legislature. I don't believe any of them made it out of committee, but we're hoping that next year they will and actually be voted on. But these 3 different bills do kind of a little bit of everything that you mentioned there. They try to take a carrots out of sticks approach. One of them was an incentive for manufacturers to produce EPDs, particularly concrete manufacturers. So just offering funding to get more of that transparency data available. That's something that we see a lot of in New York City, but I think statewide is not quite as has not taken on as much statewide. The second one was to put into law the executive order that was passed in 2022, I think, that Kathy Hochul passed, that required all state projects to use low carbon materials, low carbon concrete in particular, and to actually codify that into a law for state projects, setting the stage for that to ultimately be something that could apply to all projects. And then the third one was to adopt something that we've seen in the Cal Green Codes in California, and that is to implement within the building code I think there's kind of 3 pathways for compliance with embodied carbon standards. One would be to use a certain percentage of the existing building. Another would be to use low carbon materials and document that. And then a third one is a whole building life cycle assessment. Hope I got that right. I see maybe a nod out there. So I think I'm here we go. So I think there's a lot and a lot that's happening in that world, and I'm excited to see where it goes. I'm glad to see that it's both carrots and sticks, and I think that there's some other creative mechanisms that I'm looking forward to see kind of how those can be explored in this topic, because this is a whole new frontier of carbon that I don't think is very regulated or talked about. I mean, we talk about it a lot in these rooms, but I don't think outside of these rooms it's being talked about enough. So be really excited to see where that goes in the next few years.
Another interesting sort of policy opportunity I wanted to hear about is this idea of energy storage, and just how does that fit into the decarbonization picture. Gina, what are the main barriers to scaling energy storage in New York City? Is it technical? Is it regulatory? I've heard about safety concerns as well, so maybe you could share some insight there.
Thanks, Cheryl. I think all of the above. The conversation around energy storage in New York City started in 2014. So here we are more than a decade later. I'm really excited that the city introduced new rulemaking that went into effect about in the last 2 weeks. And it provides some really exciting opportunities. So how many of you have been involved with a project where there's been energy storage implemented? There's one person raising their hand. And so obviously, as we move into a different type of energy grid with clean energy and what we can all assume is mostly generated by solar and wind, those are variable. And I don't know how many people in the room know this, but I heard this from Con Edison, and as we were doing work on Local Law 97, they were very clear. We have the most reliable energy grid in the entire United States. Like they bend over backwards to make sure that New Yorkers' energy doesn't have anything happen to it. And that is much harder to manage with renewables. So they're very concerned about it as they're charged under the CLCPA. And I'm so glad you brought it up, Danielle, because Local Law 97 rolls off everybody's tongues. We are all very conscious of it, but we're also part of the state of New York. And CLCPA also has that carbon neutral target for 2050. And it is economy-wide. It is not just buildings. And so the energy grid under that act was meant to decarbonize to basically 70% clean electricity in just a few years. And we've seen a lot of change happen in the last year that's going to impact that, the last 2 years, to be fair. But when we do have that transition of a cleaner grid, we're going to have ways to store energy. And we're also probably going to have more distributed energy everywhere. So back to that Local Law 92, 94 competition for all of the rooftop space that we've got in the city. If we do see owners installing solar panels, mostly across New York City, we need to be able to store that energy. And that helps us to manage peak events. There was someone who was talking in the last panel about, okay, well, we're going to see the peak shift for electricity from summer to winter. So the really exciting change in the rulemaking is that up until 2 weeks ago, you could not install energy storage systems over a very limited certain size and certain technologies in New York City inside a building. It had to be installed outside. So I don't want to color this as them removing all of these barriers. There's still going to be many hurdles that a building owner will have to go through, but you can now install energy storage batteries in a building. Cannot be in a basement. So how many owners are going to want to put this equipment? And I didn't check all of FDNY's requirements, but FDNY has to be able to put out a fire. So this is something that they have to easily be able to access. So I think there are still technology changes or challenges. Technology right now, predominantly lithium-ion batteries. We've all heard about the fires that tend to be related to unregulated small batteries for individual transport. There have also been issues with batteries used for electric vehicles. We want to make FDNY really uncomfortable. You can remind them that we're going to have electric cars everywhere, and they're thinking about, oh my gosh, what do we do with them when they're parked in a garage? So they absolutely present a hazard right now. So I think there's a lot of research happening to move us towards safer battery technology. But I think right now, there are very few owners that are going to be willing to make the space and the investment to install them in buildings. But we've just had this transition point. So for smaller buildings, it may be a time where an architect and engineer can sit down with an owner and say, hey, you might want to have a room somewhere on the first floor or on the second floor where you plan for this, because someday you're going to probably want to install it when the batteries are smaller, the technologies are safer, or you might want to do it now. Local Law 97 actually creates a pathway where you can get credit for it, either subscribing to a battery system somewhere else in another building or installing it and hosting it on your property. So that's a huge incentive under Local Law 97, and I think we'll see this become a conversation that we're having with more owners in the very near future.
I think thermal storage in general, or energy storage in general from batteries and also thermal storage, definitely something very exciting. And we do work all across the country, and I'm seeing in a lot of places where these conversations are being had in a different light than we were seeing a few years ago. And there's places, we do some work in Austin, Texas. They have the utility gives an incentive for installing ice storage in your building. That's a recent addition there. So I mean, there are, this is a new technology that's heading in a good direction. I think one story I want to tell, just because it happened fairly recently and I think it's funny. A lot of times when in past years we've brought up batteries as a source of emergency backup on several projects, just to kind of take the temperature and see what we can try to accomplish. Always a flat out no. And there's a lot of reasons: expense, regulatory. Obviously these are big hurdles to overcome. But one of the big reasons that we hear about is they're just not as reliable as gas. And I think that's like a hilarious thing, because, gas is a physical thing that's like coming through a pipe, right? So we had this great experience recently in Miami where we studied batteries for backup, we studied diesel generators for backup, we studied natural gas generators for backup. This very large building needed a significant amount of backup power, and they were going to have a certain, the amount of energy that they needed, to run fire pumps and things was significant. So there was going to be a fossil fuel generator just from the amount of output that it needed. But there were a lot of other lower loads that could have worked from a battery. And they ultimately we just couldn't get them over the idea that like a battery would be a valuable thing, because they were saying, it's just not as reliable as diesel or natural gas. And then so we get down to the point where we're bidding the project, and we're talking to these electrical subs, we're talking to the utility company. The utility company tells us we can't get the amount of gas through the line to supply the generator. It's just not enough. We can't get the amount we need. Okay, well so now we've switched back. Let's look back at this diesel generator. Okay, yeah, we can do the diesel generator, but diesel comes on a truck. This is in Miami. Miami's flooded for a few days. How are you getting that truck there to make sure that you have your diesel? And those trucks that are getting through are not going to your building. They're going to hospitals. They're going to critical infrastructure, right? So, I mean, how are we saying that is more reliable than a battery that is hooked up to a solar array that's already on the building, that could be supplying continuous energy with maybe a small natural gas generator that's kicking on for pumps and things. So it was just this kind of, we have this ingrained idea that somehow fossil fuels are more resilient, and I think I know where that idea came from. But it's not true, and it's getting less and less true as this technology gets better and better. And batteries have all sorts of co-benefits. You can be doing peak load shaving. The battery is on all the time, so when you have an issue with it, you don't have to test it once a month or once every 3 months to find out that, oh wow, our generator doesn't work. I'm glad I found that out because I did this routine test and didn't wait till an emergency. The battery will tell you when there's an issue. So I just think there's a lot of promise in these technologies, but there's a lot of kind of social hurdles to get over. But I think increasingly that's happening. So that's just a story.
Okay, can I stretch us a little bit further with this? Can we ever envision a system where energy is actually shared between buildings going across property lines? So, we're always thinking about, net zero buildings, but maybe we're net zero at a community level. Could we have all these all electric buildings connected to this clean grid and sharing across property lines, or am I completely out to lunch with this idea?
It's happening. So urban thermal energy networks is something that's happening in New York City right now. A few owners are working with Con Edison, and these are owners that find that they're not going to achieve that energy balance in their building. They have some source or some need that is going to generate heat, and they're not going to use that heat. They're going to reject it. How many buildings across our city are rejecting heat on a daily basis? So back to that idea of we all have to change this mindset about, efficiency and, we're going to use less energy. We don't have to use less energy. We have to just reframe the conversation. We have to stop wasting energy. And so when we're rejecting heat, there's probably somewhere nearby somebody that could take that heat and is generating heat on a daily basis. And we could shift that energy loss to an energy gain somewhere else. So there are a couple locations across the city where owners are working with Con Edison, or an owner is essentially becoming like a mini utility, generating heat that they're going to then hand off to Con Edison, and Con Edison is then going to transfer that heat in some mode to another building that needs heat all the time. So we're really excited about that. One of my colleagues at WSP is working on a few of those projects, and I know there's a lot of excitement about them with NYSERDA. There's probably a lot of opportunity in most urban environments for us to be looking at, is there a building where they could generate energy for the building next door, and start removing those hurdles and barriers of, crossing the property line. So that's really exciting.
Okay, so closing question to each of you. What is one thing that makes you optimistic about the future of energy policy? Danielle, maybe we'll start with you.
So I was thinking about this question before, and I think if I had to pick one thing right now, it's relentless advocacy. There are, as wonky and technical as this space is, there's a lot of people who really care about it. And I saw it this year and last year and the year before with the new state energy code, which is not a place where advocates usually hang out. Showing up at this small room in Albany where the New York State Energy and Fire Code Council was having a meeting, and literally 100 people showed up and they were outside the door, and I don't think they had ever encountered that before. And so I think, that is something for me that I think, even with all these challenges, there's people that really care about it and they want to see us moving in this direction. And I think keeping that pressure up it's keeping, I think, decision makers motivated to keep going.
I think the thing that gives me optimism is just that what we're doing in these rooms and with these policies, the fundamental goal of it is just logical. That's what we should be doing. It makes sense to make buildings that are more energy efficient, that are more resilient, that can share energy across property lines. All these things make sense, and there are hurdles to accomplishing it today. It may not make economic sense today based on the way that our current financial models are structured, and based on the cost of borrowing money and these different things that but all those are structural challenges that can be overcome and creatively adapted. And we are not fighting a fight that is kind of rooted in illogic, which I think the people that are fighting against what we're trying to do are. So it gives me a lot of optimism that what we are doing is, it's the thing that makes the most sense. We are going to be happy 25 years from now that we put all this effort in now. We're going to pay less in insurance. We're going to, there's so many things that we can, put together a long-term argument for to support what we're doing. And yes, there are hurdles today. There are cost hurdles. There are affordability hurdles. But there's a lot of really, really creative people that are really committed to this. And I'm very confident that we'll come up with the solutions we need.
I think for me, the climate that we're in right now politically at the federal level is really discouraging, and we're seeing the same kind of reaction that we saw 4 years ago, 5 years ago. Cities and states, again, are saying, we're going to keep moving forward. The last time this administration was in place, New York City passed Local Law 97. There were few cities at the time that were moving such policy forward, just a handful. Now there are policies enacted, and I lost count, it's either 16 or 17 major cities across the United States. In some places at the state level, there is now a carbon policy for buildings. There are something like almost 50 jurisdictions that are considering it. And so it's moving forward and advancing despite what's happening at the federal level, despite that we have nearly all of the technical solutions, but not every technical solution. And we have all these challenges with making it affordable, but it is common sense. And I think over time, we're going to see that it is the most affordable solution that we fall into this trap of thinking that if we don't do something, it's not going to cost us. And we know that's not true. So I'm still really enthusiastic and optimistic because of the reaction that we're seeing in other jurisdictions.
Excellent, thank you. We're about out of time, but I do want to allow maybe one question from the audience if there's anybody that has something that's burning.
Hi, interesting talk. I noticed that the roof, based on these 4 presentations we've seen, is getting to be a pretty busy place. I'm hearing about rainwater harvesting, energy harvesting with solar panels, now energy storage. We hook together a bunch of bicycle batteries or something, I guess, and green roofs, with or without golf. But I thought I'd add more. If you're an AIA member, we have so many committees, and you can buzz around like a little bee and pick up interesting subjects. So if you talk to the health people, they're going to say, well, somebody might like to actually, next pandemic, somebody might like to actually be on the roof, because then they're not coughing into each other's faces down in the line for groceries. Somebody might say, we want to put equipment on the roof in low-lying areas because we can't put it in the basement anymore because of flooding. We got a whole committee that's very active about that. And there are some people who talk about urban agriculture, urban farming on the roof. I think this is probably more about the bees I mentioned than about winter wheat or grazing cattle, but still there's that possibility. You know, people used to grow wine grapes on the roof. And there's a last one. I would even add tourism. That well, it was a wonderful presentation of the Rubin Building at NYU. Nonetheless, I don't think that the tourist brochures being distributed in Europe and Asia and South America and Africa are showing pictures of the mechanical equipment on the roof of Rubin Hall at New York University. I think they're showing us the Chrysler Building, and people are coming here to see that. And so are all Chrysler buildings dead forever? Can there never again be anything like that? Can there be no design? Are we architects or are we just engineers? With great respect for engineers. So that's my question. And then that folds into a second question, which is, since birth rates are dropping, if you hold up your hand, you got 4.5 fingers. If you count the thumb as a half a finger. China and the United States have very similar land areas, about 3.5 million square miles, but China has 4.5 times as many people. So when I go to China and in a second-tier city, I see an endless field of 30-story slabs. I think maybe they need that. But in that case, we need an endless field of 6-story slabs. So my question is 6 stories or something like that a height at which we can start having a large enough ratio of roof area to people area downstairs that we can consider doing some of these things on the roof altogether? Are we ever going to get enough roof that we can do all that? And then the last question would be, what happens if we get nuclear fusion, which isn't always going to be 30 years away? And will all this blow out of the water anyway?
That was an amazing question. That was like prose. I don't want to take it, but that was.
I think my answer would be, thank goodness that many of us in this room are architects and engineers. I would like to point out that for many of the policies that we've been talking about, their performance approach. So you can do whatever you want if you get to the end goal. And I think that that is part of the success. They have to allow a flexible approach so you can still have a Chrysler building, and it just happens to be an all-electric, high-performance building, right? So, you know, maybe the lovely design at the top now incorporates solar cells, right? You know, building integrated photovoltaics doesn't have to be panels. So I think another reason for optimism is that we have really great creative thinkers that solve problems. And architects and engineers are really important for this one.
Yeah, I mean, I think the to the Chrysler Building point, I mean, there's only a certain amount of money that can go into a building, and a lot more of that money, I think, is going into systems than used to be the case. And part of that is just because we expect more from our buildings. When they were building the Chrysler Building, no one was expecting air conditioning in that building, and now you would be crazy to build a building they didn't have air conditioning. So I think there's cost has to go somewhere, and that has to be distributed. But as I do believe in the creativity of people in our city and in the country more broadly. That said, I think the point you make about density across the nation is interesting. I mean, I think there is a broader national conversation to be had around density and concentrations of people and policies in urban centers, and how can we expand that to a wider range of mid-market cities. I think it's happening to some degree in country or in cities around the country, but not nearly at the pace that we need it to happen. I don't know.
I guess the last thing I would add to that question is, when Local Law 97 passed, so Local Law 97 is the most ambitious carbon legislation for buildings anywhere in the world. We are the first city to do this. It is a massive law that, to Gina's point, people started taking on afterwards. And I have no doubt in the creativity of architects and to design, to come up with new innovations for these designs. But I would say that maybe they're not coming to see, maybe in the future, they're coming to see a Chrysler Building now, and they still will, but maybe they also will be coming to see, hey, like if you can do it in New York, you can do it anywhere, because that has always been what people say about New York City. And we will do it. And I think people will come to see how we figured that question out. So I don't have an answer for that. And I'm also not an architect, so I'm not going to pretend that I have the architect answer.
Thank you, Frank Sinatra.
All right, well, thanks everyone. We have, I think, a 10-minute break before our last session.
I want to introduce our panel. So we have Jeremy Scheinman. It's Scheinman, right? He's a senior architect at WRNS Studios, where he leads performance modeling tools. He's delivered numerous high-performance and LEED Platinum zero-carbon projects, and has overseen whole building LCA plus 50 projects. Wow. Including early embodied carbon tracking and tools like WRNS Studios' Feather platform. We also have with us today JJ Beasley. JJ is a structural engineer at Walter P. Moore in New York City. He's focused on sustainable structural systems, from complex facades to stadium foundations. He leads the firm's embodied carbon tracking initiative, and he's co-leading the Carbon Leadership Forum's NYC hub for the policy working group. And then we also have Lucille O'Callahan. Lucille is a senior structural design specialist at Turner Construction Group, advancing low carbon structural design through optimization, innovative materials, LCA, while serving on the ASHRAE ICC committee, which she'll get into in her talk shortly, advancing embodied carbon policy within the model codes. And then also she draws from experience from award-winning work at Guy Nordison. Yeah, great, awesome. And then I'm Josh Plord. I'm an architect. Some of you may know me from work at Foster & Partners or BIG or Atelier 10. And then currently I'm starting a new venture, which is a synthesis between incubation and real estate development. So if anyone wants to talk about that later, come and find me. I'm just gonna set the table stakes, just to kind of give a sense of where we're at right now. Primarily focusing on North America and a little bit of overseas work. I think this slide, this is about sort of understanding where we're at, and we're pretty far, especially on the embodied carbon side, from hitting where we need to be for a climate-aligned future. So according to GRESB, we're at about 1,300 on average. This is broad strokes industry scale, not particular to any single market, but about 1,300 kilograms of CO2 per square meter. And we need to reduce that by about 93% in order to get within that 1.5. It's a lot. So the policy that we're going to talk through shortly is very important to try and get down there. I'm sure a lot of folks are familiar with the graph on the left. This is the famous Architecture 2030, looking at emissions for buildings over time. And so in the near term, that study said that embodied carbon is actually 74% of emissions from now until 2030 because of how much building that we're building. What is maybe not common knowledge is that we're actually seeing this now on a real-time basis with portfolios for real estate developers when they're building a lot. So this is a famous New York City real estate developer. I didn't put the name on the slide, but it is public data. You can see in 2022, their embodied carbon footprint, which is their scope 3, has exceeded their scope 1 and scope 2. So typically when we're looking at operational, we're looking at a projection years in the future. But in terms of the sort of like importance, the time value of carbon, this is happening now. It's stuff that we're doing now. In terms of the grid, so we are seeing in general across the US grid, a downturn in emissions. And what that means in terms of thinking through the relationships between embodied and operational as a percentage basis, if you're a real estate developer who's building and you hold properties, what'll happen is as the grid decarbonizes, embodied carbon becomes a larger percentage of your total inventory, right? So it's going to become proportionally more important over time. This is maybe missing some numbers on this slide, but this is a map from the Carbon Leadership Forum's very amazing database of policies worldwide. It's also centered on North America. You can see that there's about 166 embodied carbon policies currently, and that's at all levels. So that's state level, county level, municipality level, which on one hand is great, right? Like we want to see more embodied carbon policies get through, of course, this is what we want. On the other hand, it is a complexifier if different states and different counties and cities have different policies. So if you're working across states and having to adhere to all of the specificity within these different jurisdictions, that can just make things more complex. Just a little bit about like what's actually in these policies. So a lot of them focus at material level from a scope perspective. A lot of them also address sort of material and building both, and then obviously building waste and circularity. And then there's different types. So CLF is tracking different types of policies. So it's not just regulation, although that's sort of the large number up there. It's also things like incentives, it's things like planning, executive orders, it's pilot programs. So the database is phenomenal. Give that team a shout out. If you're working in different parts of the country, you can go in and check what's the latest and greatest embodied carbon story in that particular location. And then you can see 2022 down here. This was kind of a banner year for policies globally. We have been on an upward trend, although in recent years there's been less. There's been a few less that have been passed. This is a study again from CLF about the relative efficacy of different kinds of regulation. So what this is looking at is a projection for New York City, looking at 3 or actually 4 different types of embodied carbon policies. I want to draw everyone's attention to the one in gray. This is whole building LCA. So that one by far, according to their model, is the most effective type. You can also look at it as we have done through Executive Order 23 and 22, various material level buy clean initiatives. Those are great, we definitely need those, but they're just not going to be as effective, according to this study, relative to a whole building LCA and treating that percentage of reduction at building scale as the sort of guiding North Star of where we need to go. And then I'm just going to do a little hopscotch around, and my esteemed panelists will go into more detail on some of these. In California, and Jeremy will speak to this with a little bit more specificity, Cal Green has been updated to have 3 compliance pathways, which I think, Jeremy will correct me, but roughly map to LEED, so 10% reduction or showing a certain percentage of decarbonized materials or using adaptive reuse. There's also AB 2446, which will require all buildings to submit an LCA and also hit a carbon reduction mandate of 20% by 2030 and then 40% by 2035. Massachusetts and Cambridge in particular has BUTO, which is it's more around building energy, but it also includes a requirement to submit an LCA as well, and they are working on a mandate reduction. And then in Denmark, you know, anyone who knows me knows I love the Danes, but what they've done is they've set a limit for carbon period on a square meter basis that doesn't differentiate between embodied carbon and operational, it just sets a cap. So you've got 10.5 kilograms of CO2 over how many years? I think it's 50 years, and that's it. And how you get there is up to you, but that's your cap, and that's in the building code. And then JJ in a little bit will go through some recommendations, near-term recommendations for New York City. One thing which I think is needed, I don't know if we have any policy people in the audience, but one thing which is really needed in order to enact these policies and get them through committee and just like make sure that they're hitting the right targets is an understanding of carbon performance relative to cost and value. So I think what we really need is a ratio looking at incumbent, you know, business as usual solutions versus your decarbonized option, and what is that delta in terms of cost or value. It doesn't always have to be more expensive. But if there was a public database where municipalities and states could go and look and like receive this data and understand this data, that would really help them with their thinking around how to set limits, right? Because the concern is that either they're being too conservative or they're being too aggressive, and having this this relationship between cost and carbon performance would help them to move the needle. And then this is just a note on my venture. It's about taking startups and innovative materials through incubation and then into development. So if anyone's interested in that, feel free to grab me later. And then with that, I'm going to pass it to JJ.
Awesome. Yeah. Thank you, Josh, for the introduction and for setting the stage. I'm going to dive a little bit more into the embodied carbon policy and the landscape that we see here in the US, and then specifically in New York City and New York State. So I'm going to talk through a couple of topics today. I'm going to start with the national policy landscape, go a little bit more into that. Then I'm going to talk about the policy history in New York City and New York State. And then I'm going to get into our 10-year vision, what we're doing now to fit into that 10-year vision. And then as we're waiting for policy and government to catch up, what we can do as members of the private sector. So I'm going to start with a different CLF policy map. There are tons out there. I believe that this one's a little bit more outdated, but still nevertheless shows a lot of good data. So let's go ahead and start from west to east. As I talk today, there are a couple of buckets that I'm going to throw stuff into. I'm going to throw stuff into a codes bucket. I'm going to throw stuff into a financial incentives bucket. And I'm going to throw stuff into a requirements bucket. And those are three of the key recommendations that have been made so that New York City and New York State can achieve their embodied carbon goals. So starting with California, we see the codes approach. They, of course, enforce CalGreen. I'm not going to go too much into that, but that's been a landmark piece of code that has really changed how we think about embodied carbon in the built environment. Progressing from west to east, we see Colorado. In Colorado, they have enacted financial incentives for low embodied carbon materials. And what they say is, hey, you can get a sales tax exemption if you use low embodied carbon materials as defined by the Office of the State Architect. And then further going east to Massachusetts, specifically looking at Boston, they have zoning Article 37, which was just passed this year. And what that requires is that embodied carbon is reported for structure and enclosure for buildings greater than 50,000 square feet at 3 project phases: initial filing, design filing, and construction completion filing. And what they're doing with that is they're generating a huge database of embodied carbon, and then there are embodied carbon numbers for buildings. And they're also asking for designers to submit essentially an embodied carbon reduction plan. Also zoning Article 37, I know that this is a BSC, they require net zero operational carbon upon occupancy at this point. So Boston is really pushing the envelope on this. And we want New York to catch up, and New York is getting there. So let's go ahead and look at the policy history in New York City and New York State. There's a lot on here. What I want to draw y'all's attention to is 2019, when the CLCPA was passed. The CLCPA is the Climate Leadership and Community Protection Act. And what the CLCPA mandated for the state is that carbon emissions economy-wide are reduced by 40% by 2030 and by 85% by 2050. And at this point, we're not really there yet, but we're making strides to get there. The rest of this legislation followed the CLCPA being passed, and the CLCPA has kind of served as a guiding light for all this future legislation. So this is often referenced in a policy context when we're saying, hey, we made this commitment, we need to stay true to it, here's how we're gonna do it. So just some other pieces of policy that are on here, of course, State Executive Order 22, City Executive Order 23, the Low Embodied Carbon Concrete Leadership Act, which kind of got the ball rolling for other jurisdictions around the country. The New York State Climate Action Council issued the scoping plan in 2022, which has been really helpful in developing some of these policy roadmaps. Also in 2022, a carpet EPR bill was signed into law. EPR is extended producer responsibility, which basically says, hey, producer, you got this out of your factory, now you have to get it back into your factory, and you have to be responsible for it at the end of your life. So, or at the end of its life. So this one serves as a really good precedent for covering other construction materials. Of course, the OGS issued Executive Order 22 guidance. The City of Auburn passed a deconstruction ordinance. New York State committed to reducing embodied carbon from concrete for state infrastructure projects. This commitment was made to the White House. Not sure if that's still around. The EDC, of course, has their circular construction guidelines. And then just this year, the New York State Homes and Community Renewal, they issued their sustainability guidelines. And they prohibit the use of HFC blowing agents for insulation, and they also have stretch guidelines for embodied carbon. So this is another good place to look. So now that we know what's happened over the past 6 years, let's talk about where we want to go in the next 10 years. So what we want is we want New York State to be a leader in low embodied carbon construction and design, in circular construction and design, and we really, again, we want to be a leader in it, and we want it to positively impact the communities that we're building all these buildings for. So there are a couple of ways that we see this coming to life. We see, again, going back to incentives and financial support, codes and standards, and material reuse and circularity. And sorry, there was another bucket in there, requirements as well. So requirements kind of gets lumped into codes and standards sometimes. It can be its own standalone, but this is generally how we see achieving our embodied carbon reduction commitment per the CLCPA. So just talking about some incentives and financial support, the vision is that low carbon and circular construction will be the norm, supported by market incentives and policy. And what the goal is here is to create essentially a sibling sustainable economy. Sustainable design, sustainable construction, sustainable procurement. And how do we do that? We have to build capacity. The way that we build capacity at this point is through incentives and financial support. So sales tax exemptions for low carbon materials, grant programs for EPDs, expanding property assessed clean energy, so that the owners can always keep a little bit more money. Financial support for pilot projects, and that's what this ribbon at the bottom is showing. These are renderings from the EDC's Mass Timber Studio. And is timber low carbon? Maybe sometimes, depending on how you do it. But nevertheless, this is still a valuable project, and it's a valuable endeavor. And then also establishing extended producer responsibility programs beyond just carpet at this point. So next in the 10-year vision is codes and standards. So the way that we see this coming about is that New York building codes will require the accounting of whole life carbon. So the opportunities here are passing statutory emissions reductions, developing roadmaps with interim targets to build capacity ahead of code mandates, again, so that we're not squeezing the industry unnecessarily. We don't want all of this to come onto people and people to have to say, okay, great, now I have to work 80 hours a week and I can't get any of this done because it's impossible. That's not what we want. We want this to be easy. We want this to be maybe even a little fun, but what we want is we want positive impacts for the world. And we understand that just dumping this on people is not the way to get that done. Further in the 10-year vision, we have a material reuse and circularity bit. So we want New York State to be a leader in creating a circular economy for buildings and infrastructure, and we want existing buildings and infrastructure to be seen as assets instead of burdens. So the opportunities here is having the state pilot deconstruction and reuse projects, permitting reused materials and buy clean policies, because currently we just see quote unquote low carbon materials there. Set minimum percentages of reuse and reclaimed materials in state projects, and establishing regional reuse networks to aid workforce development. So that's the 10-year vision, and let's talk about what we're doing now to get there. So Louis, he introduced a lot of this policy already, so thank you very much. And I think that what I want to do, instead of just going through and telling y'all what's in these bills, is kind of giving y'all a little bit more context as to how these bills were developed. So going back to capacity building, we understand that it's going to be very, very difficult to just require low carbon materials if you don't have an EPD. And we don't always, for concrete, for example, we don't want to say, hey, can you just replace this much cement? Cement is a good proxy, but it's not the only ingredient that goes into producing concrete. You know, it also depends a little bit on the electric grid. It depends on the distance traveled. There are a lot of variables that go into it. So what we want is we want EPDs to be developed, and we don't want them to be a burden for small producers specifically. We don't want it to be so that we only have one concrete producer, one glass producer, one carpet producer in New York that's the largest. We want this to remain a fair system, relatively fair, and we want to make it so that everybody can participate. So that's how these policies came about. The Sustainable Building Materials Act, the codification of Executive Order 22, so that the work of the current governor is not just completely thrown away. Other pieces that have been introduced, of course, a 3-code pathway bill, very similar to Cal Green. And then this deconstruction, salvage, and reuse bill, which I don't think as many people know about. But what this does is it provides a template for jurisdictions to adopt ordinances supporting the deconstruction and salvage of building materials. And the way that it incentivizes this is it provides grants for building a dedicated reused materials hub. It provides grants for workforce development, for training. And this was introduced by, I believe, Assemblymember Anna Kellis and Senator Kavanaugh. So, of course, they've introduced all of these. But this is a really cool one that kind of gets us kickstarted on circular design and construction at the state level. So again, while we're waiting for all of this to come in, because none of the bills that I've discussed have been passed, they've been introduced, we're hoping to get them folded into the governor's budget this year, but there's no saying. What can we all do? We've all heard for so long that us as individuals, we can't do anything about the climate crisis. But the thing is, us in this room, we actually can. We are responsible for a lot of the greenhouse gas emissions that are being put into the world. And we as individuals at firms that design and build the built environment, we can actually make a change. So what are some private sector commitments that we see? We see AIA 2030, which is committed to zero embodied carbon emissions by 2040. As a structural engineer, I'm biased to SE 2050, which is saying net zero carbon or zero embodied carbon in structural materials by 2050. And one of the things that I really like about SE 2050 is they require the development of an ECAP annually. An ECAP is an embodied carbon action plan. And what it forces you to do is it forces you to reflect on the work that you've done over the past year and what you plan to do over the next year in order to get to 2050. And it's a nice interim target. Every year you have to say, hey, what have I done? What can I do now? So I think that that's a very valuable tool that we use. And then also these bottom two here, this is from Toyota and MasterCard. They're random. I just wanted to put that in there to show that we're not working in a vacuum. We directly impact their scope 3 emissions. If we're building a new facility for Toyota, if we're doing an office fit out for MasterCard, all the work that we're doing directly plays into their scope 3 emissions, and their scope 3 emissions are oftentimes like 80 to 90% of their total emissions. And they all have much more aggressive commitments than us. They're like, hey, we're gonna fully decarbonize by 2035, 2040. So we can fit into this, and we're not working in a vacuum in the work that we do. So with private sector commitments, I'm going to pass it over to Jeremy. So Jeremy can talk a little bit more about the work that he's done. Thank you.
Hi, so I'm Jeremy Scheinman. Nice to see all of you. I'm going to take you all on a little journey over the last 8 years. It feels like both a lot shorter and a lot longer than that. And how we at WRNS have kind of evolved our thinking around embodied carbon in response to changing targets, changing commitments, changing policy, and what that has looked like for us. Hopefully in a way that is helpful to someone. So here's a little timeline. We did our first LCA in 2017, and it's been kind of down the rabbit hole ever since in the best possible way. As you can see, there are tons of different commitments, different benchmark systems, competitions. There are corporations and campuses that have kind of joined in on the fun, so to speak, right? Everyone's making their decarbonization plans. ILFI got in on it, of course. We found some gaps that we liked, and now finally we're getting to the point where after all of these kind of individual private sector commitments and commitments have come about, codes and policies are finally starting to get there. So we will start in 2017. This is the Grange and Commons at Sonoma Academy, where we began our LCA journey. It was messy. We heard of this cool software called Tally, and we wanted to understand what embodied carbon was about. We were making some decisions that we thought were, the right decisions to make from a material standpoint, an energy standpoint. That list of analyses, those Excel spreadsheets over on the side, there they are, is only actually like a fraction of the analyses we ran. It wasn't a smooth learning process, I will say, but we learned a huge amount doing it. And as we were doing this, we moved to 2018. We are submitting for LEED, and in LEED V2009 around this time, there is the embodied carbon calculation pilot credit, right? This is kind of the beginning of embodied carbon in LEED. And this was about how do you look at a few specific materials and demonstrate that you are reducing the embodied carbon in them through your design decisions. And so we had to figure that out, right? We said, well, we've done this, we think. What does that actually mean? And so we looked at, rammed earth blocks instead of CMU was one of the decisions we made. We looked at CLT for some of our deck as opposed to metal deck or even metal deck with concrete as potential baselines. And we looked at reclaimed wood, which we used versus a new virgin lumber for the exterior cladding. And we combined these and we said, oh, okay, great. We're getting little bits and pieces of reductions here and there. And it looks pretty significant, right? We're looking at kind of a 20% reduction or a little more depending on what material it is. Of course, we later learned that all of these combined were only about a 2% reduction on the entire project, which was itself interesting, right? It doesn't mean don't do it. It just means understand the impact of the decisions you're making. Every percent counts, but it was interesting then for us to understand, well, what are all of these other things? How do we factor in the rest of it? And of course, this is all something that is not in a vacuum, right? There's a building associated with this, and one we rather like. And so, LEED transitions, we moved to version 4, version 4.1, and there's actually like a life cycle impact assessment credit. It's no longer pilot, it's in the full thing. We're here, we're ready for it. And this time it has kind of an upfront design impact. We are looking at the Silicon Valley campus for Microsoft, and they had an existing, campus there. It was 5 buildings. a kind of traditional egg yolk of building and egg white of parking lot, as was common and still is common in a lot of places. And we said, can we keep some of the existing fabric but build it into something that is kind of today and something that will last a lot longer? And can we do it in such a way also in the new construction that is also low embodied carbon? So we're not just incorporating existing buildings, we're incorporating mass timber. And we also, after learning some lessons from previous projects, started looking at the breakdown of how much is structure, how much is core and shell, how much is interiors, and how does that interiors break down, right? What are the important pieces of things? Is it walls? Is it carpet? And how do we track our reductions? This is something that is always a question, right? What is your baseline, and how do you compare the things you do to the things that you start with in some fantasy world or in some real world? So how do we account for the building reuse and our use of timber, in this case, as major impacts for reducing embodied carbon on the project? And this was also, it was a much bigger building. I should have mentioned the Sonoma Academy project is about 19,000 square feet. This Microsoft campus is about 640,000. So as you scale up size, does that impact your life cycle assessment practice? And it turns out it does a little bit, but also not as much as you might think, which is nice. We turned the page to 2020. A lot of things happened in 2020. One of the things that happened for us, and this is kind of when the projects got off the ground, but there was a competition a couple years earlier for the C40 Cities competition. And there was a site in the Civic Center of San Francisco. And here we started again looking at embodied carbon very, very early in the process. And what does it mean about, how do we think about the traditional life cycle of a material where you extract it and you manufacture it and you put it in your building and you use it and you throw it away? And how can we think about that slightly differently? And how can we do this early? When you don't have, if you've used Tally before, you don't have a full-blown Revit model. You just have 1 foot of wall or 1 column or 100 square feet of deck. And how can you kind of use these building blocks with then a lot of Excel calculations afterwards to understand the embodied carbon implications of your early design decisions? And incorporating that, you can see kind of in the middle here, right? There's that same graphic. This was all built into the proposal for the competition, which was just very, very early. And then kind of tracking that through and seeing how we did. Another hit on 2020, this is a new health services building at Princeton, where part of the decision for us as we were presenting early options was, are we going to build an all new building, or are we going to keep one of the existing buildings on the site or both of the existing buildings on the site? And you can't quite see, I don't think in here, but there's that existing building in the white back there. And this middle scheme was only picked for a lot of reasons. They really enjoyed the fact that we were keeping a historic building from campus. They also enjoyed the fact that it was speaking to their relatively new carbon reduction goals, right? So it starts speaking to a lot of different targets, this embodied carbon thing. We did our homework tracking and seeing what is the breakdown of the structure versus enclosure versus interiors on this project. How is it broken down by spec section? How does that fit in across some different benchmarks? And we'll see some of that later. And again, how do we look at our reductions? And this project was particularly interesting. Again, it's a hybrid CLT project with building reuse. So you can see there's reduction from reuse up here, there's reduction from CLT, and that happens not just in structure, but also in the core and shell aspect of it, right? You're reusing a building, so you're reusing some of the facade, and in the interiors. Now that you have your CLT, you might not need or want ceilings everywhere that you would have had otherwise. So how do these reductions track all the way through, and how do we show that in LEED? And we say, okay, great, we're doing all of these amazing things. And so for the life cycle impact reduction credit, it doesn't just look at embodied carbon, it looks at all of the life cycle impacts that you can have, all 6 of them. And so we ran this through and we checked it on our spreadsheet and we said, okay, great, we're reducing embodied carbon by 35%. That's no small thing. But then we're looking at these other things, and you can't increase any of the other impacts by more than 5%, and we're increasing 2 by more than that, and we're increasing in a third. And that wasn't great. So how do we then think about this building? What is the baseline for this building? Is it a all new typical construction building, or is it a CLT building? Kind of a hybrid CLT all new building, which is what then we did a second pass at this, and we said, well, we're going to reuse the building, but the new building wasn't actually going to be, typical construction. It was always going to be CLT. And so our comparison changed, and so the result changed, and now you can see there's a reduction across the board. This is a question I'm sure many of you deal with if you deal with this credit in LEED, it's like, or anything now, right? It's what is your baseline? How do you create the baseline that is the same, but not the same? And how do you do it in a way that you can kind of stand behind, right? It's not just, let's throw something out that doesn't make any sense at all. And so really the story from the LEED perspective became much more about this, right? It's the building reuse and the new building rather than everything combined. Another quick hit on 2020, corporate commitments. This is an example for an Amazon project. This is the reuse of their Lord & Taylor building in Manhattan. You can see here kind of what it looked like and what it is. And they want to track embodied carbon in their spaces, which is wonderful and allowed us to do a really deep dive into interiors and try to understand the impacts of the flooring, which is all of the reds and oranges, and the walls, which is all the blues, and the ceilings, which is all the greens, and also the workstations, which is that kind of ochre color in the bottom left. And it turns out that workstations have a really, really large impact on the embodied carbon of interiors, which we didn't know before. We wondered, but we didn't know. And it turns out to be about a quarter on this project. So how can we reuse existing workstations when we're doing fit outs, right? That's kind of an easy question to ask and an easy question to answer often. If we come back to Sonoma briefly, I'll start kind of speeding up as we get closer to today. ILFI comes out with their zero carbon certification, and this is something we're interested on this project because we learned we actually had done a lot of good things. And through this process, we start looking at PVs and the impact that PVs have not just on the energy use, but also on the embodied carbon and the kind of payback period for PVs, right? You're saving energy, but you're spending embodied carbon. So how long does it take for the saved energy to pay back the embodied carbon? And it turns out that's about 9 or 10 years. At that time, I think it's less now. In 2022, the 2030 commitment changed, right? They added embodied carbon. And this was a really awesome moment in our firm because at this point, we'd been doing these calculations for about 5 years. And it was always kind of a one-on-one. Like someone would say, we want to do this, or I would go to someone and say, let's do this. And we would talk and I would teach them and it would kind of happen over time. And all of a sudden there's 2030 reporting requirements. And so we get this kind of outside push on our office to say, well, all projects now, or almost all projects, need to do this. So we ran through and did, what is this, at least 9 projects that year that were kind of outside of the project that I'd normally been looking at. And how do we kind of then scale up our embodied carbon reporting, and what does that look like? And we had a carbonanza, which was just kind of fun. And we started then tracking more intentionally and comparing against, not just on a one-off basis against an industry benchmark, but across our kind of whole portfolio. This has 36, there are more that aren't here. This hasn't been updated as recently as it should have been. But we wanted to see how do we compare against the CLF benchmarks, against the COAT top 10 benchmarks, and against other of our own projects, and what does that look like for us? 2023, we finally got it together to get the life cycle impact reduction credit on an interiors project for LEED. This had been around for a while, but we had always found it difficult because, again, it comes back to the baseline creation. What is the baseline for an interiors project? It's kind of carpet and ACT and JIP, and that's what a lot of interiors projects are. And so it took a special project where the base building allowed us to, not allowed us, but the architecture of it afforded us the opportunity to not have all of those things, which was exciting for us because it allowed us to look at this from a slightly different angle. 2024, we've been doing all of this work in all of these different capacities, and something that we always struggled with was, what do we do on like really, really quick projects where it's entitled before schematic design, and for it to be entitled, of course you need renderings, and once you have renderings, then it's designed, even though you haven't gotten to schematic design yet. And so we said to ourselves, how can we impact embodied carbon in a way that actually works in that scenario, where we want to understand what we're doing, mostly for skin, because that's what happens on developer projects, right, at an early stage. And so we said, well, if we have these options, is there a way we can build something? And so we built this tool called Feather, where you define members and layers, and you kind of build up assemblies. And each assembly, you can look at a kind of unit embodied carbon value for whatever your assembly is. You define it. All of the numbers are based on CLF values, with a few exceptions that we explain. But you can build whatever you want, and you can customize. If you know that you have really awesome gypboard, or you have really awesome terracotta, or you have really awesome whatever it is, you can put in your own values. And then you can compare. You can say, what if I only have 60% of this instead of 70%? What if my window to wall ratio is 30% instead of 50%? You can ask these questions. And so this is something that is out in the world, and there's a URL later for anyone to use. So if you want to check it out, I encourage you to do that. And we use it on our projects now to kind of help us understand things early and quickly. And it turns out there are a lot of other uses for it too, which is nice. And finally, right, we get to 2005 and CalGreen. And the CalGreen updates have come, and we've been doing this for a long time. And we say, okay, well, we've been thinking about how the design how all of these requirements have been impacting design. And it turns out CalGreen doesn't really change that thinking very much, which is good for us, but it does kind of require thought. And so first is, what's covered, what's not covered. You can see it's, I'll say most buildings, not all buildings, but most buildings. It says here that university housing is not covered. That's not strictly true, right? Public university housing, which is what this project is covered. So we had to comply with CalGreen on this student housing project. And CalGreen is a choose your own adventure embodied carbon requirement. You can either choose a building reuse option, a life cycle analysis option, or a prescriptive path option. We have been doing LCA, for a long time at this point. And so we said, we're gonna look at the LCA pathway. And a lot of the requirements are very similar to LEED. It's a 60-year lifespan, cradle to grave, primary, secondary structural glazing, interior, exterior finishes. Not exactly the same as LEED, but very close. And there's a mandatory 10% reduction, again, from baseline. So this worked its way into our project, and we ended up with a 20% reduction. This is a, not mass timber, but largely, timber framing project as compared to what would otherwise be, I believe, metal stud. And so we're comparing there against a reduction to the CLF baseline here, which is great. And so we had to comply with this. We thought we put this in early. It came out, well, and this is now, under permit review and all of those fun things. But we're very excited about it nonetheless. And it's finally gotten to a point where we're not just saying like, well, this project is pursuing LEED, we should do this. Or you have these corporate commitments, so you should do this. Or you have this campus commitment, so you should do this. This is in the code, and so we have to do this, which is a really, really nice thing for us because it takes that burden off of us. And so what's next, right? Is it more codes? Is it other commitments? Is it more people pushing things in more places? And I think it's all of those things and more. Thank you. There's a URL for Feather.
Hi, everybody. My name is Lucille Callahan. Thank you for having me today. I'm going to speak about embodied carbon policies, but from the construction manager standpoint. I work for Turner. And I'm going to highlight a few projects that we are doing that have such requirements. But before I do that, I wanted to give you a sense of the scale of Turner Construction. It's we're the largest construction company in the United States. We have $17 billion of annual revenue, 11,000 employees, so large company. Every year we put together this fictional Turner City. Here it's 2022. But one number perhaps to keep in mind is 1,500 projects on average per year. And then as I was preparing for this panel, I thought, okay, how many of those projects are actually subjected to embodied carbon policies at the moment? And it turns out very few at the moment, only a handful, which was a surprising finding for me. I'm sure there's more in the pipeline, and there are more coming, more policies are being enacted, and these are only these three policies I have on the screen here, but bottom line, shockingly few. It raised the question, like, what is the impact of those policies right now? But I'm going to highlight one of those few projects. The first one is a renovation for DGS, the state of California. It's a $450 million renovation in Sacramento that included seismic upgrades, a new facade, so substantial renovation. And this is our first Buy Clean California project. And we're about to complete it and deliver it to the client. So it's a big milestone. And I asked our team on the ground, like, how was it to comply with this policy in practice? There are many sustainability requirements for this project. They're on track to achieve LEED Platinum. It's also going to be net zero energy. They're shooting for that. But on top of that, there was the Buy Clean California Act to comply with. So you have to collect TPDs for the eligible materials under the policy. And you have to collect them from the subcontractors. So the submittal, then you need to make sure it's compliant. It has to be valid at the time of purchase. It needs to be a facility-specific EPD. It needs to be third-party verified. So sometimes there are submittals that get kicked out just based on that. And then on top of that, it needs to comply with the global warming potential limit for the applicable material. So here I have an example for rebar. It's a Nucor EPD. It complies with the requirements, it's valid, it's third-party verified, and then it's facility-specific. It provides numbers for several mills in the United States. And you can see here I'm using the limits for January 2025. So they're lower than the ones that were applicable for this project, which were the 2022 ones. But just, it went down a little bit, and it added 3 mills to the list of mills shown in red here. So then, once we have the CPD, we have to direct our subs. Okay, you can go and purchase from the mills that are not in red, and you should absolutely not purchase from the other 4. And that's just one example for reinforcing. You have to do that for the other materials, and each material have their little pitfalls. Like for steel materials, you have to make sure you're not confused between fabricated and unfabricated products. For glass, there are only certain types of glass that fall under the policy. For insulation, there's a question about the unit. It needs to be converted to be directly comparable to the limit established by DGS, sorry. And then the last step in this process is once the suppliers have purchased the material, we need to have a purchase order that documents the provenance of the material. So it's, I guess the takeaway here is that it's paperwork and an added layer of submittal, and it falls on the contractor to make sure that we comply, at least for the buy clean policies. I think for the, you were showing the choose your own adventure version, the LCA one will fall on the design team. The buy clean one falls on the contractor. I wanted to highlight another project. This one construction is just starting right now. It's flood wall in Lower Manhattan. This one it's one of 3 projects. This one is the one along Battery Park City. And it turns out Battery Park City Authority, the owner, is a New York State agency. So that's why it needs to comply with those New York State policies. And New York State Executive Order 22 is a requirement to track the materials. So we have to provide the GWP values documented in EPDs where available, and also quantities. So it's a documentation effort and tracking effort. And then the buy clean concrete guidelines, we have to meet certain limits on the concrete mixes. And right now, with the first pass at this policy, the values are relatively high. So I think should be relatively achievable to meet those limits. And as time passes, the limits are expected to go down. But I expect that there will be a similar learning curve as what we've seen in California, where some staff is going to be designated with managing this process, and will need to know all about EPDs and track that. So talking about carbon accounting and tracking, I wanted to briefly touch on what kind of tracking we do at Turner as a company, and others on the panel have also touched on that. We're tracking our scope 1, 2, 3 emissions, and finding that our scope 3 emissions are dominating the total. But we're also tracking 5 materials more systematically with EC3 models. Now we're able to issue this annual embodied carbon report and translating that into a baseline for our buildings based on those 5 materials. It's concrete, asphalt, glass, timber, and steel, I guess. I think those are the 5. And we're also tracking our job site emissions. And all of this kind of comes together in a platform that we have that we call Green Board. And that allows us to also issue our ESG report. So it all comes together via this platform. And I'm going to finish with a new standard that everyone curious or passionate about embodied carbon policy should be aware of. It's being developed right now. It's the ASHRAE ICC standard 240p. I'm on the committee developing this standard. It's co-sponsored by ASHRAE, the Mechanical Engineers Association, and the International Code Council. It covers the whole life cycle, both operational and embodied, so not just embodied. And that's very important. It establishes minimum requirements and provides enforceable language. So that's really what sets it apart from other guidance that have been issued before. And the goal is to harmonize the methodology, and it will support decarbonization across the industry. What it does not do is establish a limit, or it just tells you how to calculate those greenhouse gas emissions for a building over the whole life cycle. But I think it will be very important as future policies get developed. It's going to be it's going to be a methodology that you can reference. So for example, I could see an AHJ say, oh, you need to follow this methodology and document your emissions to get permitting, or you need to calculate your emissions and be under a certain limit. I don't know. They can do whatever they want with it. It just establishes the methodology. And that's the end of my presentation. Thank you for listening.
All right, are these things on? Yeah, great. Awesome. Okay, we've got a couple questions and then we'll open it up. So, JJ, I'd like to start with you. First question, how can folks, if they're interested, attendees at this forum, but how can people get involved to help shape the future of embodied carbon policy in New York City and in New York State?
Yeah, so there are a couple of ways that people can get involved, from very low level of involvement to very high level of involvement. Very low level is just keep advocating for lower carbon designs and keep pushing for better materials, system optimization, so that, of course, your designs have lower embodied carbon. Also, if you want to get really, really involved, I invite you to join the CLF New York City Hub's policy working group. We meet the second Wednesday of every month from 4 to 4:30 p.m. So if you have that slot open and you want to talk about embodied carbon policy, please let me know. But then also within AIA, we have code and the policy subcommittee and the decarbonization subcommittee. We also have the building science committee here. Just talk with the people around you and just talk to them about embodied carbon, how we can get it written into policy, and just keep pushing that forward. Also, something else that's really, really important that the state government specifically wants to see is they want to see case studies, and they want to know how policies around the rest of the country have impacted the work that you're doing. So if you have any work in California, Massachusetts, Colorado, I think Minnesota, if you're doing any infrastructure work in Minnesota, and you have stories about how you were able to incorporate low embodied carbon designs and construction methods on your project, please just send them my way. I'll make sure that they get to the right person. But yeah, there are several ways for people to get involved, but I think the number one thing is just keep talking about it and keep pushing for it.
Absolutely, that's great. Follow-up question to that. Obviously, there's a difference in the zeitgeist happening at federal level and then at state level. So I'm just curious to hear your thoughts on sort of how do we as practitioners who are interested and care about this issue, what are sort of the opinions or thoughts that you might have on navigating between the two?
Yeah, so I don't think it's a secret that there's a bit of an imbalance between the views of the federal government all the way to the city government at this point. And I think starting with the city government, we had a mayoral election this week, a more progressive candidate won, Zoran won, and he has a green schools policy, which is really focused on the operational decarbonization of schools. And this is one of the first times that I've seen a candidate that even talks about building decarbonization. So I think knowing that, he already knows about building decarbonization, he was willing to write it into his policy platform as he was campaigning. I think that's really promising at the city level, where we can go back to the mayor's office and we can say, hey, we know that you were working on some embodied carbon stuff in the past. We know that you were working on some operational carbon stuff in the past. We appreciated the direction it was headed in, even though we didn't 100% agree with the content in there. Can we revisit it? So I think just pushing it at a local level is really, really important, just making sure that that conversation, again, doesn't die, and that we are just directly, reaching out to our city council members. We're participating in our community board meetings, and just, however you feel about it, you can feel whichever way you feel about it, but just getting your voice out there and getting it heard is so important. And then, of course, we have the federal level, which is the exact opposite. I don't think that what's happening cannot be good for the environment. But I don't think that's a reason for us to get discouraged. I think that what we do instead is we just play the same game. We say, okay, you want to push more local policies. Okay, let's see what's popular in New York. Let's push local policies that are popular in New York. We can do that. And just, using that momentum that's around that and just reframing it and saying, okay, this may not be a huge environmental loss. What this is this is a local policy win. So let's push local policy. So just making sure that we don't get disillusioned by, a lot of the headlines, and we say okay, What are you saying that works to my advantage? How can I fit into your goals so that we can promote a better, safe, more just world through lower embodied carbon designs? So.
That's great. Yeah, thanks, JJ. Jeremy, I'd like to turn to you next. WRNS has been doing fantastic work for a long time on the design side of, responding to requirements from LEED, from Architecture 2030. And I'm kind of curious, how has this changed thinking about embodied carbon from maybe a portfolio level at WRNS, and how has it potentially informed your design process tracking across projects, and potentially how you might engage a client who perhaps doesn't have a mandate?
Yeah, absolutely. So I think the kind of, I'll answer the last part first, maybe. Some clients still aren't interested. And right at the end of the day, we are all beholden to our clients. And that means that we just do it without them knowing. It means we'll mention it. And if there is the right opportunity to say something about it, sure, right? And we'll talk about building performance or sustainability holistically as much as we can, and try to find, I'll say, like the gateway drug, like whatever specific piece of sustainability they can latch onto. And kind of grow from there. And hopefully that does, in a direct outward way, include embodied carbon. And it may not always, and that doesn't change the fact that we are going to try to include like low embodied carbon cement or efficient building design or reuse of materials or all of these other things in the design process. We just won't speak about it in exactly the same way. It's not maybe quite to the same extent, but there's a colleague in Louisiana who has two different business cards. One that says Director of Sustainability and one that says Director of Building Performance. And it's a similar idea, right? Where it's all in how you frame it. It's not that you're trying to change what you do. It's about how you're speaking to it. And all of these kind of external forces and kind of the more clients who have these commitments, it allows us to kind of push what we do forward. It allows us, when 2030 kind of changed their reporting structure to include it, we expanded our internal tracking. We set up standards. We have tally standards for our office that says, even if you haven't used tally before, here are the kind of specific material settings you need to apply to this, that, or the other material if you don't know better or if you don't know otherwise. And kind of just figuring out a way to make these things simple for everyone so that we can do it. We want to do it on all projects. We're not quite there. But to do it on as many projects as we can. Yeah.
That's great. I'm really excited to see the development of Feather. I think that this, potentially really helps various teams within the firm, make advancements quickly, and potentially really helps some of the more junior staff. I'm curious if you're allowed to say, I don't know if you are, but what would be sort of like the next steps for y'all with developing further tools?
We don't have a plan to develop more tools at the moment. Feather was kind of at first a labor of love, and turned into something that we thought was useful for us, and then quickly turned into something we thought would be useful for other people as well. So we put it out into the world. There's no kind of licensing agreement. There's no password. You just go when you use it. And if it's helpful to you, great. And we hope it is. And if you have comments, please, if you use it and have comments, please tell me. We have dreams of it kind of growing. At the moment, we're not quite there, but we can see ways where instead of it just looking at embodied carbon, it also looks at energy, right? Wow. And you could, this is an ideal world, but how do you put in your zip code and it will pull the energy code and say, okay, you need insulation. It needs to be R15 or R20 or whatever it needs to be as you're doing this. So it will kind of automate some of those things to incorporate that. But at this point, it's kind of build up embodied carbon. So I showed envelope, but it's also structure. It's also interiors. You can kind of set up whatever you want that way.
That's awesome. Thanks, Jeremy. Lucille, I'm going to go to you next. So I think what's really interesting about being such a large contractor is just how much material from different subcontractors and vendors you are purchasing every day throughout the year. And I'm curious, okay, so the projects which have the mandates right now, as you showed on that slide, surprisingly few projects. But I'm curious from sort of the same question I asked Jeremy, but from the CM side, how has going through those projects thought about your approach to embodied carbon, perhaps even on other projects? And then a second part is how does Turner potentially think about tracking carbon performance and cost performance across projects, if you do? Yeah.
So I'll start with the first question, but I think the enactment of those policies really created momentum, and it created opportunities for training our staff, so that it's not just the people who are focusing on sustainability, who are by nature interested in embodied carbon, that are going to have to learn. It's also the other people across the board, the people who are in pre-construction, the people in procurement really have to know what an EPD is and be able to understand what the policy is about. So, and I think that helps across the board with skills and processes. Like I showed that huge spreadsheet of someone developed that. I think we need better tools than that, but it's coming together as time goes by. And so that's one piece. And then on the other side, you have all the clients all the other projects that are not directly impacted by those policies, but are driven by clients who are interested and have corporate requirements. And I don't know, I think of all the data centers we're building right now that have embodied carbon reduction goals. That's also pulling everyone in this direction. What was the second part of your question? To cost track.
The second part of it was how are you thinking about carbon performance and cost if you're tracking that across projects?
Yeah, so I think right now they kind of occur separately, because we have the EC3 models, we have the cost estimating process, and it's not totally coming together yet. At least on a I liked your slide with the dollar spent and how that. We don't have that tool yet, but I think eventually we'll be able to, because we're collecting so much data. Yeah.
Right. That's great. Okay, lightning round. Ready? So this question is for each of you, and this can be a policy thing or just a general embodied carbon thing. What is the one thing that we need to do? One sentence.
LCA at some kind of policy level.
LCA on some kind of policy level with ASHRAE standard 240p as a cornerstone.
I would like to say the same thing, but what I'll say is I think that before we get there is just capacity building. So however, we need to do capacity building through training, advocacy, just getting the low carbon materials to the market, and getting people educated about low carbon design, so that when we get to the LCAs, they're as effective as they could be. But urgently, it needs to happen now.
Great. Well, I think we can open it up to folks if folks have any questions for anyone. See someone right there.
I have kind of I don't know if it's a simple question, but because we have a contractor and a practitioner that's building with these laws in mind or what have you, I guess my question is, and I always bring it back to money, is do you find that when if you've ever done this, where in both instances where you've taken a building, let's say you made a 20-story, 200-unit building or something, or an office space, whatever, that was similar, one client wanted to do it, or it was in a jurisdiction where they had to, and another client, similar type of building that didn't have to and just built it the regular way, has there been any, if you guys notice any substantial differences in cost? Now, and I'll just sub question or just sub context that and say, we know about, if you're holding onto the building, the long-term savings of life cycle and of utilities, et cetera, if it's more energy efficient, et cetera. But I'm just talking about the base build.
I think it's difficult to answer that question, but I think what my example of the building in California illustrated is it was adding resources on the contractor side and also limited the procurement options a little bit. So by nature of doing that, it's gonna, intuitively, you would think there's a cost impact. But I think a lot of people are achieving reductions at little to no cost too, just by choosing when there's an opportunity of procurement, oh, this is about the same cost, but this one is lower carbon, we should always get the lower carbon product where possible.
Yeah, I have maybe a two-part answer. One, there was a project that we did, it's almost built, and we're running the LCA, and one of the things you focus on when you're doing this for LEED, because you need to compare, and the easiest way to compare is say, well, we have one building that's our design building, and our baseline building is basically the same. You just tweak a very small number of things because LEED requires you to be the same in just about every aspect. And so we generally will look at concrete because it's easy, it's concrete, it doesn't really change anything else about the building. And so I go to the design team and I say, hey, what did we do for concrete on this project? And they said, I don't know, ask the structural engineer. So I go to the structural engineer and I say, what did we do for concrete on this project? And they said, I don't know. Look at the specs. That's exciting, right? And so we go and we look at the concrete submittal, and it's like a 50% cement replacement mix. And this is like a dirty secret I don't really even want to tell, but we would have, had we known, asked. It happened without asking, and it just happened, which means it's cost effective. It actually is a cost benefit to the contractor. And this was a project in the Bay Area of California where the market is different from New York, I understand. But it was actually cost effective for it to be the low embodied carbon concrete. It didn't come from anyone, as much as I want to take credit for that decision. It came from the contractor, it came from cost. The other thing I will say is these decisions, in some cases, there is a cost benefit. It is cheaper to do the low embodied carbon option. In many cases, I think there is a very slight increase in cost. I will say in the majority of cases. And the way to minimize that slight increase in cost, and it's in the ballpark of less than 1%, depending on what it is to talk about it early. Because if you talk about it late, it's not a fraction of a percent, it's 5% or 10%, right? And so it's making sure that these questions are asked early and it's brought into the design at concept, at schematic, not while you're trying to procure concrete on something that's being poured tomorrow. Because then it's not gonna happen. Yeah. Or it's, I don't know, $8 million.
The only thing I would maybe just add to that is also to consider schedule implications, right? So, timber versus concrete is sort of an age-old embodied carbon discussion. And if you can also include savings from reduced cycle time floor to floor, that can be one thing to help. So just keep a wide search space when you're thinking about cost.
Yeah, and I'll add to that, that yes, timber is amazing because you can do a new story every day, and sometimes you can do multiple stories in a day, depending on your floor area. But in addition to that, I think that looking at it from a design perspective, a lot of the times your low embodied carbon design is going to be your low total material quantity design. So if you're doing this optimization through design, you should have what you're looking for as a designer is you're looking for lower quantities. So that should always be lower cost. And then when you're looking at what's actually happening during construction, I think the Port Authority, they put out that you can get somewhere between 20 and 30% reduction in embodied carbon for concrete with zero cost add. And they do a lot of work with concrete. So I trust their numbers on that. And then also in the US, we have from a structural perspective again, we have great steel. We have electric arc furnace steel for the most part, except for one mill in Indiana. And we have great steel in the US. So again, leverage our local power. So yeah, I think that oftentimes there shouldn't be a huge cost add. Again, also if you just start the conversation early. and you just make it a core tenet of your design.
There in the back.
Can everyone hear me? This is curiosity for Lucille on the development. What's happening in the room when you're discussing this in terms of thinking like what is this going to be used for? Is it going to be a standard that other codes and regulations point to? Is it purely for people who want to do this and want to do it better? From a standard calculation perspective, do you see it being integrated into other pieces of programs and codes?
So I think the hope is that it's going to be referenced by other codes or as the unified method. And when we're in the room, we try to think about how it's going to be used, but we're focusing on that methodology and making sure it's enforceable and like code language. So it's really not. It's not very aspirational. It's more about this is the minimum requirements to comply with this method. So it's a very different mindset from what CLF has put great guidance together. Like what would be a great LCA? It's not that what this is. It's but there's also sometimes there's been tension in the room between like people on this committee would be saying, oh, they should just use tally and follow the tally methodology. It's like, no, tally is going to follow the standard. It's the other way around. So I think sometimes there were some misunderstandings. Yeah. Does that answer your question?
Yeah.
Okay, well, if there's no other questions, I will pass it over to Kritika for some closing remarks. Yeah? Kritika. Thank you, everyone.
Okay, and so with that concludes our annual Building Science Committee Symposium. Thank you all for joining us today. I hope that everyone came away with a little something. I think we had 5 extremely rich and strong panels this morning, sessions. So hopefully it has piqued someone's interest, and if nothing else, give a little bit of insight into what is happening with embodied carbon and circularity and policy and these other things that affect, building science as a field. We would like to extend a huge thank you to all of our speakers and moderators today. Could not have had such a strong session without you. As well as a big thank you to AIA New York and the Center for Architecture, particularly Salmata Kaba, who has been the program coordinator for this. She's been a huge help. Thanks very much, Salmata. Our core committee members, Krishnov Roy, David Levine, Michael Busing, and Cheryl Saldana, who has just, I think she walked out a little bit earlier. And again, if anyone has any interest in the Building Science Committee, to join, there's a barcode or a QR code, rather, on the side of the wall here. You can scan that and learn more about our committee and how to join and participate if you'd like. Don't forget, please, to sign in for your AIA credits if you haven't already. And does you have any other comments?
No, I think we're all ready to get drinks. So thank you all.
Thanks very much, everyone.